will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Welcome back. In this lecture, we are going to create the ECR repository and also create the Docker image locally, and then even push the Docker image to AWS ECR. So let's go ahead and then do the step one by one. Okay. So we'll go to ECR service in AWS Management Console. So search for the service ECR, which is nothing but Elastic Container Registry. And let's go there and go to repositories, right? So you can even directly click on repositories here, right? ECR repositories. So let me close this and create a repository, right? So let's go here and then take the name as AWS ECR Kube Nginx, okay? And then paste it here. So this is my repository name. So it's not just AWS ECR Kube Nginx. So this will be the repository name, but the repository URL means it is going to be entire from here to here. Okay, so it is going to be unique for you. This value is going to be different for you also. Okay, so also enable tag immutability to prevent image tags from being overwritten by subsequent image pushes using the same tag. So we will enable it. And enable scan on push to have each image automatically scanned after push it to repository. So it will do a security scan of your image once you push it. So we can enable it. So that's a very good setting. So you can push it. Okay. So and then it will provide a detailed security report about your Docker image. So I'll click on create repository and our repository should get created, right? So if you want, we can see our push commands here, how we are going to do it. Okay, so this is the push command for us whenever we build our Docker image. Okay, so this is for our latest one. Okay, so but anyway, we can leave these things here. We have anyway documented here all those things in our lectures, or even if you want, you can select this and then one more time if you want to refer. For Mac OS, what will be your push commands, and then for Windows also, AWS also provided a detailed documentation here for the same. So now we'll go back to our GitHub repo and then start working on creating a Docker image locally, right? So let's go to 10 ECR container registry 01 AWS ECS Kube Nginx, right? So I want to change this name to EC. So I want to change this ECS to ECR. I have done it. So let me refresh it and then it should come here. Okay. So 01 AWS ECR Kube Nginx. Okay. So we are going to go inside this folder and then review the files and then build it and then push it. Okay. So let me go to our this one. So which is nothing but our GitHub Visual Studio Code. And if you see in 10 ECR Elastic Container Registry and EKS, you can find 01 AWS ECR Kube Nginx and 02 is related to Kube manifest. Okay. So first we'll focus on building our Docker image. So inside this you can find you will find the Docker file. So from means like Docker file, inside Docker file what we are saying is bring the Nginx image and then copy the index.html whatever is present here, okay, to USR share Nginx HTML in the Docker image whatever you are going to build. That's all. Very simple Docker image we are going to build, and then we are going to push it to the ECR repository, right? So we need to go inside this folder and then run the Docker build commands. So we need to go to 01 AWS ECR Kube Nginx. So let's go to the terminal and go to 10 ECR Elastic Container Registry related folder, and I'll go to 01 AWS ECR Kube Nginx. So now we are going to build the Docker image. So the template is nothing but docker build -t and then ECR repository :tag, means like repository URI :tag, and then the location. Location is nothing but the current location. So dot will be the story here. Okay. So now let's see what is my repository URI, right? So let me go back here, right? ECR, and you can see that this is my repository URI. So which is US East 1, and it is same. So ideally these two things, if I copy this one and whatever is, I'll just paste it here and then remove it. And if I go back to my this one and this one, both should be same for me. So but in your case you need to build it accordingly by putting in your notepad. Okay, so it is same. Okay, so not an issue for me. So what I'll do is I'll remove these things, I'll remove these things. Okay, and then save it back. Okay, so if you want, what you can do is you can say file, new file, and then copy this command here and then get your repository URI from here, right? So that is an easy job for you, right? So let me do this, and then here you can give your version, right? So I'm going to give 1.0.0, and this is our docker build command what we are going to use, and then execute there. Okay, so that is the same one. So let me go here and then paste it. So successfully built the image. So I'm going to say docker images. So I'm going to have lot of images. So let me say clear and let me see my image here. Okay, so this is the latest image whatever I have built just now 13 seconds before. So the image and then its tag also displaying here. So I want to run it locally and then test how it is behaving. Okay, so docker run -- name and the name of your container whatever you want to run. Okay, so you can give whatever you want. So I gave whatever my image name, the same thing I have given here, and port is local port, and then means like on my desktop port, and the container port I am mapping here. And --rm, what it does is like whenever you do a docker stop, automatically your docker container will be killed. Okay, so it will not be available there. Okay, in previous processes. Okay, so and then -d and then the docker related image information, the entire image information. So I'm going to take this and copy it and then put it here. In your case, you provide your ECR repository URI :tag and the name of the container. You can put the same thing, not an issue. Okay, so I'll say clear and then paste. Okay, so now if I say docker ps, so I have this container running now. Okay, so what I'll do now is like I'll go to localhost and then access it. Okay, so it is running on port 80. So welcome to Stack Simplify AWS EKS Masterclass. Integration with ECR registry is up and running locally, right? So if I go ahead and then stop this container, right? So you can go here and then take the command and then stop this container and verify it should be not available. Okay, so stopper docker ps -a -q, nothing is available. That's good. Okay, so now you have built the image locally and then tested it. Okay, in this step we are going to push that to our AWS ECR, right? So let's go ahead and then push that now, right? As usual, you need to have CLI version 2.6, which we already discussed in prerequisites also. So first we need to do is get the login password and then push the docker image. Okay, so I'm going to say AWS ECR get login password and region is US East 1, and then take that password and then pipe it to the next command. Okay, so which is nothing but docker login -- username is AWS and password is stdin, which is whatever the command output coming from here. Docker get ECR get login, whatever you are getting from there, you are passing the password here, and then which image you are going to push. So this is the docker repository URI you are going to push. Okay, so but one thing I am doubtful about here is I didn't mention the tag. Okay, so but repository URI only there you are getting the login password here. Okay, so push with tag is here. Okay, so that's good. Okay, so docker login username password and the repository URI is this one, right? So that is the one. Good, so this is the repository URI. Okay, so this looks good. So let me copy this and then paste it here. Okay, and it should do the docker login for us successfully. Okay, your password will be stored unencrypted in so and so file, but that's fine. Login got succeeded. So now we want to push this image. So before pushing it, if you go inside and then verify, there are no images available here. Okay, so let's go ahead and then push that now. So I'm going to push it. So in your case, it is going to be your repository URI :tag. Okay, So let me come here and then paste it. So it is trying to push, it will take a while. So maybe less than a minute it will push it. Small image, right? But here you are clear, right? So you get your login password for this respective region, and then for Docker login with username AWS and password is this, and repository URI is this, which you brought from here, right? So repository URI. So you are going to provide the password and then do the login to our Docker repository, to this respective Docker repository. Okay, and then you are going to push it. So now let's see, it got pushed. Okay, so let's go inside and then do the refresh if we want. So now you can see that 1.0.0 image tag got pushed. Okay, and during the push we also said that it need to scan the stuff. Okay, so vulnerabilities. So this is a basic Nginx image which we have taken out of the box, and these are the current scanning results. So with critical 0, but with high impact 1 you have, and then medium 16, low 21, and then informational 52. So that's what the vulnerability scan it has done. So this is the very high impact thing related to Perl before has an integer overflow related mishandling of a PL XYZ something. Okay, so like that you can have instruction injection related stuff. It might happen something. It is trying to tell us that. So you need to fix all these things to have a valid and then highly secure repository for you. So that's a very good option in AWS Elastic Container Registry about vulnerability scanning automatically happens on our images whatever we push here. Okay, so this completes the creation, means like a creation of a Docker image and then pushing it to the Docker AWS Elastic Container Registry. Okay, so in our next lecture we'll focus on about Amazon EKS. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In step 7 we are going to use this ECR image whatever we pushed here in our EKS deployments, right? So we are going to understand the deployment and then service whatever we have created as part of this section. Okay, so we are going to have a deployment, node port service, and then ALB ingress service. So all these 3 files we are going to review, and also we are going to review the worker node related ECR access related policy. And once we review these things, we'll go ahead and then deploy the stuff. So let's go back and then review the K8 manifest created as part of this section, right? So we'll go to our Visual Studio Code. Let me close this temporary thing whatever we have created, close the Docker file and close this, and let me maximize. And if you go here 02 cube manifest, okay, in 10 ECR Elastic Container Registry and EKS you can find 02 cube manifest. So you will have Nginx ECR Nginx deployment, ECR Nginx node port service, and then ECR Nginx ALB ingress service. So let's start with ECR Nginx deployment. Okay, so as usual, standard deployment whatever we have created, no change in it. How we have created deployments earlier, it is the same thing. Only difference is it will have the image whatever we have created, that URL. So I can remove this, and even one more time I can add it. Okay, so what you need to do is you need to go to this template and then update your image URL here. Okay, so you need to update your image URL here to make your things work with the image whatever you push it to the ECR, right? So this is my image URL, right? So image URI. So you can see in repositories, inside this repository, so this is the image URI which I am planning to use. I copied it and then I pasted it. Okay, so resources also have given, that's fine. Okay, so now you are going to run 2 replicas of that, and this looks good. Okay, so standard deployment definition. So that's the reason one more time I'm not going with the API version, kind, metadata, all this stuff. Okay, so far we have done multiple times about the deployments. Same, we have created a node port service, and the only thing here is, as we have created our image and then copied the index.html to the root context of HTML, right? Means like Nginx root context. So our health check URL path is /index.html. Earlier in our previous sections we have seen /app2 or app1, something like that, right? Here it is going to be index.html. Other than that, ports are going to be 80 and then 80, and the standard node port service definition only. Okay, so we have done this from our fundamentals to now multiple times. Okay, so that's good. And next is ALB ingress. In previous all sections we have done the same thing, ALB ingress. So what we are going to do is like, so this is the one, right? So I am also going to update the label here with the same label. Okay, so just to have common labels conventions. So ECR ingress service we are going to create, and then so in its annotations only the external DNS name you need to update if you want to with a different DNS name, right? Why? Because this is my DNS. So ecrdemo.kubeoncloud.com we are going to create, and in the service name for /star here you need to update your Kube ECR node port service related service name here. That's all. Okay, so this you really don't need to change if you use the same templates, but the changes here include only the image URI you need to change, right? So that is one. And the second is node port service, nothing changes, and in ALB ingress you need to change your ecrdemo.kubeoncloud.com. So in these templates what you want to change is only primarily two things. One is image URI in deployment and ALB ingress service related hostname, whatever you want to DNS register. That's all. Okay, and that should be good. So this is about the manifest whatever we have created, and then we are going to deploy. So let me close these things, and we have discussed the manifest. So the next thing is to review the access policy, IAM access policy. Okay, so we need to go to EC2 here, right? So we'll go to EC2. How to find our role for our worker node group, right? So we'll go to running instances, right? And we'll select any one of the instance, and then which is related to our worker node group. You can cross verify that. So this is related to my EKS stuff only. Okay, EKS demo 1 ng private 1. Okay, and I'll go to description section, and you can find the IAM role here, right? So I'll click on this role, right? And now if you see here, you should have something called Amazon EC2 container registry read only, and then Amazon EC2 container registry power user. Okay, so you will have everything here. Okay, read only comma power user. Okay, so I'll add this here in our documentation also. So these two policies should be associated. So these are already associated. How these are associated also we can cross check here, right? So we can go here, and then if we go to our EKS cluster using EKS CTL, and then if you see create EKS cluster and then node groups, so you will find something called, you have created a cluster, and then whenever we are creating the node group, right? So you are saying here full ECR access. Okay, so you are associating a policy for our node group, whatever we are creating, saying that full elastic container registry access. Due to that, we have got these policies associated for our worker node groups, which means whatever the pods we are going to deploy, whatever the Kubernetes workloads we are going to deploy inside this node group are going to get the ECR full access automatically. Okay, so that's about it. So let me go back and go to our 10 ECR elastic container registry, and if you see here, we have discussed both the things related to K8 manifest and then EKS worker nodes, right? So in our next lecture, we are going to deploy the Kubernetes manifest and then verify the stuff and then access the URL and then do the cleanup, right? So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to do the Kubernetes manifest deployments now. So let's go ahead and then deploy the stuff, whatever is present in 02 kube manifest folder, right? So please ensure that you are in 10 ECR elastic container registry and EKS directory, and clear. And I'm going to say kubectl apply -f and then 02 kube manifest folder, right? So it's going to create our respective deployment service and then ingress. So I'll say kubectl get pods, right? It is going to do into a default only. Okay, so my 2 kube ECR pods are running, right? So I'll say get svc, so it should create a equivalent node port service. That's good. And then I'm also going to say get ingress, right? So ingress URL also came, so we can go back to our browser and management console, and we'll go to EC2, right? So it should be getting provisioned right now. So let me go to load balancers, and our load balancer is getting provisioned application, and you can verify the tag. It should be ECR ingress service, and in listeners we'll have port 80 with a redirect, and this one certificate associated, and /star should go to the respective target group. So let me open that target group, and it has the path as index.html, whatever we provided at the node port service level, and in targets, so it's getting registered. Okay, so let's wait for a while to get the things registered. So I'll go to target groups and then refresh one more time and then see. So it will take a 2 to 3 minutes. So let's wait for that. In meantime, we can go to Route 53 and verify our DNS here, right? So which should be ecrdemo.kubeoncloud.com. So if you go here, so kubeoncloud.com, and inside that you should find ecrdemo.kubeoncloud.com. So this is also good. So let's go back and go back to target groups, refresh one more time and wait for it. So let's refresh and then check one more time, and these are healthy. That looks good. So one more check, what we need to do is ns lookup, right? ns lookup and ecrdemo.kubeoncloud.com. so it's resolving, and with same means like this ALB DNS name and this DNS name should have the same IPs, right? So which is nothing but ingress DNS name. So 65.131, 65.131, this looks good. So now let's take this domain name and then go to the browser and then say new tab and then say http://ecrdemo.kubeoncloud.com. So index.html is at the root context. Automatically, ideally, it should load, right? So now we can see that welcome to Stack Simplify AWS EKS Masterclass. Inside that, integration with ECR registry is completed, and then we are able to access the URL in the browser directly. So this completes end-to-end demonstration of whatever EKS and ECR. So now what we are going to do is we are going to clean up the manifest whatever we have created, because we really don't want to burn our cache for this respective load balancer URL primarily. Okay, so I'm going to say kubectl delete -f and then 0 to kube manifest. So whatever we have created, everything will get deleted. That's all. Okay, so let's cross check everything got deleted or not. So if we go here and then load balancers and then refresh, it's gone. Okay, so that's about it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about core DevOps concepts like continuous integration and then continuous delivery or deployment on a high level. So to achieve this DevOps in AWS on EKS, so we can use few tools like code commit, code build, and then code pipeline in AWS. So using these things, we are going to implement continuous integration and then continuous delivery. So let's see the stages in release process now. So we'll have source stage. So in source stage, we are going to, if we take any application, so we need to check in the source code to our version control repository, and then we can even send those things for peer review, those checked in code. And in addition to that, we can also provide pull request process implementation. So that's about in the source stage, we do it. In build stage, so we are going to compile the code and build artifacts like war file, jar files, container images, or even Kubernetes manifest files, and then unit test them and then move on to the test phase. So we will do the integration testing with other systems in test phase, and load testing, UI testing, security testing, and then test environments, dev QA, and then staging environments. So all come under this test phase. And then we'll have something called production phase. So deploy to production environments and then monitor code in production to quickly detect the errors. So now let's see which stage belongs to which type here. Okay, so which means like source and build stages comes under the keyword most running keyword in the industry now, which is continuous integration. And the next test and production phases come under continuous delivery or continuous deployment. So one more thing here is infrastructure as code. If you see continuous integration, continuous delivery, continuous deployment, so all these are big buzzwords in the industry nowadays. Okay, so now how these are related to our regular release process is what this slide outlines. Okay, so and now let's see infrastructure as code. So whatever we have in source, build, and then test productions, so all these stages, if you want to automate using AWS CloudFormation, so you can automate that and then just check in the templates, and then all these source stage, build stage, test stage, and then production stage, all things related to their infrastructure also can be written in code and then available for us. So that's about the infrastructure as code. And next thing is continuous integration, right? So in continuous integration, what does this mean on a high level? So automatically kick off a new release when new code is checked in. So that's one thing. And build and test that code in a consistent, repeatable environment, and continually have an artifact ready for deployment. So that's the continuous integration. So let's also see what is continuous delivery. Okay, so in continuous delivery or deployment, automatically deploy new changes to staging environments for testing. So deploy to production safely without affecting the customers, and deliver to customers faster, and increase deployment frequency and reduce change lead time and then change failure rate. So these are the advantages of continuous delivery process if we implement it. So now how this AWS developer tools or code services you can call, how these fit into this continuous integration and continuous delivery pipelines. Okay, so AWS has something called code pipeline, which will be in integration with different AWS tools. So example, for source, it is going to use the AWS code commit, which is something like a GitHub repository. So here we call it as code commit repository. And for building, so we usually see Jenkins, we might have seen in many places, but in AWS we can use code build, and which is a tool which provides us to build our artifacts and then push it to S3 buckets in AWS. And next is testing. Okay, so either you can use code build plus third-party tools to do our testing related things. Okay, and next is deploy. So in our case, for Kubernetes, we are using code build in combination with kubectl to do the deployment in our use case. So I brought them under the deploy stage here. Okay, and next is monitoring. Okay, so from monitoring perspective, you will have something called CloudWatch Container Insights. So using that, we are going to do the end-to-end monitor of our container applications deployed on Kubernetes cluster, and also Kubernetes cluster related components, and then Kubernetes cluster related resources also will be monitored using CloudWatch Container Insights. And we have a dedicated section for CloudWatch Container Insights, and then you can learn more and more about that there. Okay, and next thing is how these tools will be fit in under which category. So we are going to see that in this slide. So continuous integration comes under code commit, code build, source build. So in source and build stages, we have code commit and then code build. So we can map them to continuous integration. And code build with kubectl plus CloudWatch Container Insights, you can put them under the continuous delivery or deployment section. Okay, so that's about on a very high level introduction about AWS code services, and then how we are going to achieve DevOps use cases using these things. Okay, so we'll start the hands-on activity from our next lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about what we are going to learn as part of this entire thing, right? So we are going to create a ECR repository for our Docker images to be stored there, and we are going to create our code commit Git repository, and then check in our Docker and then Kubernetes manifest, whatever we are going to use as part of this specific section. And we are going to write a buildspec.yaml or review the buildspec.yaml, which will build the Docker image and then push that Docker image to the ECR repository, and deploy the updated Kubernetes deployment manifest to EKS cluster. So in addition to that, we also need to be aware of few important roles that need to be created and then associated with the code build role. So one important role is STS assume role, which is nothing but EKS code build kubectl role, which will have the EKS describe function inside that. So with this role, we will be able to apply the changes to our Kubernetes using code build role from code build. So for that purpose, we'll create this role and then associate that to the code build role. So in addition to that, code build role also should have the access to push the images to this ECR repository. So it needs ECR full access. And this respective STS assume role, you need to associate in this respective code build role. You need to create a STS assume role policy and then associate this role in a way it is required. So we are going to do all these things in different steps and in a very step-by-step and then organized manner, so that you really don't miss any steps here. Okay, so all the steps are detailed documented so that nothing will miss or nothing will misfire us to not to succeed about this section. Okay, so even for STS assume role also the detailed steps are provided, and even for creating auth config map related information on our EKS cluster, those also we have very detailed information provided here, and you can just go through this section and then execute it, and then you will be successfully implementing the DevOps for our Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Now we are at the step 3 of our DevOps use case, and we are going to perform a prerequisite check before moving on to the next steps. So the prerequisite check here is like the applications we are going to implement as part of this DevOps use case is a simple Nginx application which is fronted with a ALB ingress controller, which is nothing but our application load balancer in AWS. So to have this ALB ingress service to run, it needs the ALB ingress controller pod to be running. So if you see here in our course, we have implemented and continuously using them from section 8 onwards. So from 8 we have implemented the application load balancers and also the external DNS. So those two things we are going to use everywhere so that the application whatever we are going to deploy looks like a full-blown implementation. So the same cluster whatever we have implemented, those things are running here or not, we just need to cross check ourselves. So if not, then ALB ingress service is not going to get created, and then we are going to have issues. So that's the reason we have added a prerequisite step here for this one. Okay, so we are going to go to our terminal and then say kubectl get pods -kubesystem. In kubesystem you should have ALB ingress controller pod up and running. So that's good. So I can create a ingress service now. In the same way, I'll say get pods, kubectl get pods will take us to my default namespace external DNS is running. So which means whenever I create a ingress service and then if I try to register the DNS name devops.whatever the domain.com, so it should get registered using Route 53 DNS server. So all those things are going to happen as part of our entire implementation. So now as our things are working good on our cluster, so we'll go back to our next step, which is create the ECR repository for our application Docker images. So we'll go to Elastic Container Registry and then create a registry named EKS DevOps Nginx. Okay, so let's go here and then type for Elastic Container Registry, right? So or we can even say ECR and then it will find us. Okay, Elastic Container Registry. And once we go there, so in our previous lecture only we have created this repository AWS ECR kube-nginx, right? So now also we'll create one more here, which is EKS DevOps Nginx, and I'm going to enable tag immutability and then scan and push, both the things. So this completes the creation of our ECR repository. So in our next lecture we'll focus on the code commit repository. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand on a high level about what is code commit service in AWS, and then we are going to create a code commit repository for our EKS DevOps use case, and then we'll push the content related to it inside our local GitHub repository and again push it back to our remote GitHub repository. So let's go back and understand what is this code commit repository, right? So it is nothing but a version control service hosted by AWS. So we can privately store and manage documents, source code, and then binary files. It is secure and then highly scalable. So it supports standard functionality of Git. So code commit supports Git versions 1.7.9 and then later. So it uses a static username and password in addition to standard SSH. So code commit is integrated with different AWS services, which makes its solid presence in AWS. So it is integrated with CodeStar, CodeBuild, Code Pipeline, and then Cloud9. So these are related to developer tools. In addition to that, so it is also integrated with AWS Amplify, CloudFormation, CloudWatch, CloudTrial, Elastic Beanstalk, Key Management Service, and then Simple Notification Service. So as its integration is this tight with other AWS services, its presence is very strong in AWS, and then if we use it, we are going to yield lot benefits from that whenever we use it for our GitHub repo in our AWS. Means like whenever we use it as a Git service for our code inside AWS. So in addition to that, so what are our steps we are going to perform? So we are going to create a code commit repository and then clone that to our local Git repo and then push some code, which is nothing but our kube manifests or Docker files or whatever is required for this DevOps demo. So all those things we are going to push that data to this local Git repo and then commit that data and then push the same to our code commit repository. So let's go ahead and then do that now. So we'll go to our GitHub repository, right? So we are going to create a code commit repository with name EKS DevOps Nginx. So let's go for our service code commit, right? So it went to Code Guru somehow. Let me search for code commit. Okay. And we have other templates here. That's fine. So other repositories. So we are going to create a repository name EKS DevOps Nginx. So EKS DevOps demo, right? So now I'm not going to enable any Amazon Code Guru, which is related to Java. Ours is a simple Nginx and then Docker files inside that. So I'll leave as is and then I'll click on create. So now my DevOps Nginx repository is created. The next step is to go ahead and then generate the Git credentials for this. Okay. So we can go to our IAM service, open in new tab, and we can go to users. And I have one IAM user named Kalyan, and I'll go to this security credentials and we'll find something called HTTPS Git credentials for AWS code commit, right? So we are going to generate these credentials, and once we'll come back to code commit here and copy our URL and then clone it to our local. So this git clone URL we are going to clone. So I'll go back to my terminal. So I have created a folder EKS DevOps demo. So inside that I'm going to clone my repository, right? So let me click on that and it is failing. So because the Git credentials, so I want to show you particularly this one because so the Git credentials, whatever we generated, and it is not matching with the older things. Okay, if it is in MacBook, so what you need to do is you need to go to keychain access, right? So inside this keychain access, and then you will find something related to Git code commit US East 1 region, right? So it caches my old data here, right? Old Git credentials. So I'm removing them, right? So now good. So now one more time do the Git clone. It should pop up for the username, right? So it's popping up. So now I'll copy the username, paste, and then password. I copied the password and paste it, right? So now it has cloned the empty repository. If I see EKS DevOps Nginx repository is here, and we can go inside that, and if we say git status, nothing is added here, no commits yet. Okay, so I'll say clear, and I will go back to my Visual Studio Code. So before going to Visual Studio Code, we'll go to our GitHub repo and then discuss about these files before adding them to our repo, right? So we have buildspec.yaml, which we will discuss in our next steps in detail, and standard Docker file. So, and then this Docker file is going to have something called we are going to copy this index.html from app1 folder to Nginx container. That is what we have written in this Docker file. We are going to see that now, and we'll have some kube manifest folder which will have the Nginx deployment, Nginx node port service, and then Nginx ALB ingress service. So let's go ahead and then give a very high level look about them before copying them. Okay, so I'll go back to my Visual Studio Code. In 11 DevOps with AWS developer tools, I'll have a folder called application manifest. So inside that, so here as part of this anyway, we are going to discuss the same thing we are discussing now. Okay, so which will have a app1 folder which will have the index.html. So whenever we are testing multiple versions, we are going to change this v1, v2, v3, and we have the Docker file. So we'll download the base Nginx image and copy the app1 folder, whatever is present here, to the HTML app1 folder inside the Nginx container, so that whenever we access our URL devops.kubencloud.com/app1/index.html, the page will be served from this folder, right? So now you have the standard deployment, node port service, and then ingress service. In addition to that, the buildspec.yaml. So buildspec.yaml we are going to discuss in detail in a separate lecture. So for now, these are our standard deployments which we have done earlier also: deployment manifest, node port service manifest, and then ingress service manifest. Okay, so now let's move on to our code commit and then copy these details, right? So how I am going to copy it is, you can copy these files from your thing and then paste in your respective directory. So as I'm using Visual Studio Code, I'll try to do it this way. Okay, so add folder to workspace, and then I'll try to add my folder EKS DevOps demo here. Okay, so this folder is added here. So I'll copy the app1 kube manifest, build spec, and then Docker file. So all these things I'll copy and then paste it here, right? And I'll minimize this, and I can see that I have the app1 folder with index.html. I have its equivalent Docker file and the kube manifest folder copied, and then buildspec.yaml copied. So I'll go back here and then I will say git status, right? So looks good. So all these things are added in my git repo here, okay, which is nothing but EKS DevOps Nginx, right? So I'll say git add, which is added them, and then git commit -am. I'll say added first set of files, right? And then we have committed to local. So if I say git status, nothing is there in my local branch. Okay, so I'm going to say git push. So this should push to our remote repository, which is code commit repository. So it pushed it successfully. So let's go here and then click on code, and it should open our EKS DevOps Nginx here, right? So you can see you have the app1 folder which will have the index.html inside that, right? In the same way, you have all the manifests, kube manifest, buildspec.yaml, and then Docker file. If you want, you can go inside and then see the kube manifests also, right? So everything looks good. So you can see the commits also for this repository. So just now whatever one added first set of files. So commit also completed successfully. So how many branches we have? You can click on here and then see we have only default branch, which is master branch. So you can have additional settings here related to whatever you want to configure here. So like if you want to configure notifications for every check-in and then whatever happens, okay, so you can do that here. So additional triggers you can configure and all those things. Okay, so but for now our focus is on moving on with our DevOps use case implementation and not exploring about this code commit in detail. So we'll move on with our next steps. Okay, so let's go back here, and then we have committed everything, and then we have also discussed about these files on a very high level. So in our next lecture, we'll focus on discussing about STS assume role. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to create a STS assume IAM role for code build to interact with AWS EKS. So code build will be a service which will be doing our build Docker image build and then also doing the respective deployment to our EKS cluster. So to do that, so it needs some additional permissions. So let's see what are those. So in an AWS code pipeline, we are going to use code build to deploy changes to our Kubernetes manifest. So this requires an AWS IAM role capable of interacting with EKS cluster. So in this step, we are going to create an IAM role and an inline policy which will have the EKS describe permission that we will use in code build stage to interact with the EKS cluster via kubectl. So to do so, we need to perform the following steps. Okay. So we are going to export our account ID. So you need to replace your account ID here. So you can find your account ID in different ways. Usually the easiest way for you is like you can go here to billing and then also find it. But you can open any one of the roles. Okay. So whatever the roles, whatever you have created, EKS-CTL, right? So and if we can open any one of our EKS-CTL roles, example our node group role. So you can find our account ID here. So your account ID, you can put it here whenever you are doing it. Okay, so export your account ID, right? Copy, and then let me clear this stuff and then paste it, right? And next thing is to create a trust policy. Okay, so I'm going to get entire this root principal trust values here. Okay, so let me copy this entire trust policy stuff here, right? So paste it. And once you have done that, so it need to replace with the account ID information. So that's the reason what you need to do is you can verify whether it has replaced it or not. Okay. So you can see that my account ID is replaced inside that. Good. So now we are going to create a IAM role, EKS code build kubectl role. So which is nothing but EKS code build kubectl role. So let's go ahead and then create that now. So once it is created, we can get the ARN of that, right? So you can make a note of this if you want to, right? In your, why? Because we are going to leverage this ARN later. So you can use this later. So let's make a note of it. Okay. So I'll come back here and we will define a inline policy stating EKS describe, and then we'll push that to a simple IAM EKS describe policy file here. Okay. So it will go inside a file, right? The complete JSON. And then I'm going to associate that inline policy to the newly created EKS code build kubectl role. So let me go there, copy, and then associate that. Okay. So once the association is completed, let's go back to our IAM management console, go to roles, and then type for EKS. And if you want, we can even search for our direct role name here, right? So this is the role name whatever we have created. Okay, so come here and refresh once, right? And search for this role here. Okay, so it got created, and if you see that role, it has the root path here. Okay, and one important thing here is it has the EKS describe thing. Okay, so permissions related to EKS describe thing. So now let's go back here, right? So we have successfully created the STS assume IAM role, right? So now update the EKS cluster AWS auth config map with this new role created in the previous steps. So in EKS cluster, we'll have something called config map named AWS auth. So inside that, whatever the role we have created, we need to update it inside the EKS cluster. So let's go ahead and then do that. So we are going to verify what is present in AWS auth config map before the change, whatever we are going to perform. So let's go ahead and then see this now. So it has something called a username with the system role EC2 private DNS, and the role ARN is going to be our node group role, which is our EC2 instances, private instances, whatever we have created, right, inside the IAM inside the EC2, if you see, this is the node group, private node group for our EKS cluster, right? So with 2 nodes, its equivalent role currently we are seeing inside the AWS auth config map. So these are the instances, right? For them, whatever the role you see here, so which ends with 9F0Y. Okay, so the same thing you will find it here. Okay, so it is for the, means like the username is system nodes related stuff, and then it belongs to system nodes group and then system bootstrappers group. So now whatever we are planning to create, right? So it is going to be for system masters. Okay, so the role ARN is so and so whatever EKS code build kubectl role, and the username is build, and then groups it will belong to system master. So this is the complete thing. Okay, so if you have already in the same terminal, then not an issue. If not, then one more time export your account ID and then set the role value here. So till end whatever is there, so you need to have the spaces, all these things as is. So paste it, enter, right? And now get the current AWS config map data and attach a new role info to it, and then place it in AWS authpatch.yml. So here the role data will be replaced. So let's go here and then run this command directly, right? So AWS authpatch.yml, right? So done. That's good. So now let's with kubectl patch the config map AWS auth. So with the file whatever we have created. If you want, you can go ahead and then see what is present inside that file before applying the patch. So earlier you have seen only here this level of information, right? So now you have additional information here with username is build, and the group he belongs to is system masters, and the role ARN he is going to use is EKS code build kubectl role. That's what we are going to apply now. Okay, so let me copy this and then paste it so that it will be applied. So once applied, patched, so I'm going to say clear and then verify the same it is present in our EKS cluster or not, right? So that's good, it's applied for us. So now one thing important here is these two things, these two steps looks little confusing, but if you need more information about it, you need to read a lot about your STS assume role and then STS related troubleshooting guide also with IAM. Okay, so in detail if you want to understand lots of stuff here, you need to learn lots of stuff, but the concept goes very big, and then instead of focusing on DevOps, we'll go and then focus on IAM related stuff here. So that's the reason I'm not going into too much deep, but I have ensured that the steps whatever created out of the box with just copy paste will work for you. So I'll see you in the next lecture. In the next lecture, we'll focus on reviewing the buildspec.yaml and then other stuff. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about code build on a very high level. What is this code build service and then how we are going to use it, right? So code build is a fully managed build service in the cloud. So it compiles our source code, runs the unit tests, and then produces artifacts that are ready to deploy. So it eliminates the need to provision, manage, and then scale our own build servers. So it provides pre-packaged build environments for the most popular programming languages and build tools such as Apache Maven, Gradle, and then many more. So we can also customize build environments in code build to use our own build tools. So it scales automatically to meet the peak build requests. So if you see here how to run the code build, right? So if you want to run code build manually, you can run it from management console, or you can run it from CLI or from SDKs or code pipeline. So in our case, we are going to run AWS code build using code pipeline. So that's what we are going to do. So how code build works? So let's see that now. So if you are using the code pipeline, what happens on an overall story, we are going to see that now. So as a developer, you are going to check in the code to your respective source code repository, right? So what happens is like once the change is triggered inside the source code, the code pipeline will know that, and then it will trigger the pipeline operation. So immediately code build will trigger and then take the latest source code version from our source code commit repository or GitHub repository or whatever is configured as source code repository. So from there, and then we'll start the build process. So during the build process, so based on if build is failed, if you want to send the notifications, right? So it can send the notification using Amazon notification service, simple notification service, right? So, and it also logs all the build logs inside the CloudWatch during that process. So in addition to that, it will have a build environment, which is a purely a Docker container environment, or we can configure our own, we can build our own Docker image and then use that as our build environment, whatever we need. Okay, so we have options to use managed Docker images for build environments, or custom built Docker images also we can use here. So once the build is completed, right, so build logs are stored here and the notifications are sent via SNS. So once the build is completed, it is going to store the artifacts inside the S3 buckets. So our focus here is like, we are not going to trigger this code build using not CLI or not management console or not SDK. We are going to do it with code pipeline. So we have seen the entire code pipeline on a high level flow, how code build works in combination with code pipeline. So the next thing is the architecture. So the code build architecture we are going to see on a very high level. So this is the build environment, so which will have the managed images, and then our custom images we can push it to EC2 container registry, or our images can be present in our Docker Hub, but those images we can use as our build environment inside the code build. So that is a very, very good feature, right? So if we have already a existing build process in our organizations, and then if you want to integrate with code build, then get that respective container or your manual build process, convert it into your own container, and then bring it here and then start using it under code build. So now, so this is the build environment. The next thing is the source, right? So code build supports its own, means like cloud related, AWS related code commit service. So in addition to that, it also supports source as simple storage service, which is S3, and also it supports GitHub, GitHub Enterprise, and even also the Bitbucket. So the build artifacts, once the build is completed, it is going to store in the S3 buckets. In addition to that, build logs are stored in CloudWatch, and build notifications are sent using simple notification service. So what are code build steps on a very high level, right? So as a developer, I check in the code to local Git repo and push the same code to code commit. And so from code build, if you want to run the build manually, so then you can reference that respective code commit version, whatever the source version, and then run your build, and then it automatically stores the artifacts in the simple storage service, which is S3. So now what we are going to do in our next step is, so we are going to review the buildspec.yaml and then code build environmental variables. So for this entire build process to happen, there will be one important artifact which it needs. How my code build process need to be defined, how my build process need to be defined, what should happen pre-build, means like before build, pre-build what should happen, and before build also what commands it need to run, and then during the build what commands it need to run, post build what commands it need to run. So all those processes will be defined inside a file called buildspec.yaml. So we are going to understand about that buildspec.yaml, and in our use case in relation with the DevOps, what are those environmental variables we are going to pass. All those things we are going to discuss now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Just now we have completed our code build introduction, and then we are moving on with our step 8 related buildspec.yaml and then environmental variables in our code build, right? So environmental variables required for our code build are going to be the repository URI, so which is nothing but if we go to our ECR, which is Elastic Container Registry, right? So whatever the repository we have created, EKS, DevOps, Nginx, right? So its equivalent URI, whatever is present here, right? So this is the one we need to pass as repository URI variable. So when we are creating the code build project, so we'll see that later, but these things are, we need to make a note. So and one more is EKS kubectl role ARL. So when you executed this step, right? So in step 6, create STS assume IAM role. So whenever we created this role, so we got the ARN value, right? So this is the ARN value. So here just if you replace your account ID and then if you don't change any of the above templates, just replace your account ID and then use that, okay? So or if you want, you can take this and then go to IAM, right? Go to IAM service here. So this is the one, right? So go to roles and then search for this role, right? And open this role and then you will find the ARN here. So get that and then ensure that you put it here as a note for you. And your EKS cluster name. So our EKS cluster name is EKS demo 1. So we are going to use that. So these are the information you need to make a note before moving on to the next steps. So now we are going to review the entire build spec file, very big file we have written. When you see it, it looks super big, but it is super simple. So I'm going to make it super simple for you. So let's go there, okay? So in 11 DevOps in application manifest, so you can find something called buildspec.yaml, right? So I can make it a little bit bigger for our convenience. So right. So now if you see in version, we have version 0.1 and then 0.2 in buildspec.yaml. So if you try to Google it here, right? So AWS code build spec, right? So it will take us to the specification document here, okay? Specification reference we can say even, right? So it will have the entire reference. So version 0.2 and all the information related to it, okay? So but from this whatever is required we have taken, okay? So our thing is install. We have phases like install, pre-build, build, and then post build and then artifacts, okay? Build, post build, and then artifacts. So inside that, before starting the pre-build process, if anything you want to install, you can define the inside the install. This is a simple YAML file, and inside commands whatever things you want to install you can give. So earlier when we don't have this latest Docker images available which is provided by AWS for code build, so what happened is like we need to install lots of stuff, okay? Example, if you are dealing with Kubernetes, you need to install your kubectl, you need to install your EKS CTL, you need to install equivalent AWS CLI, all those things. But for now, since AWS Amazon related Docker images are available for code build with latest versions, so what happens is nothing is required to be installed here. So what does that mean? Let's go to the end of this file. There will be a URL for you for reference, okay? So what we are going to do is let's take this, right? So I'll go and then once I'll say first I'll say AWS code build Docker images, right? So let's search that, okay? So by code build. So these are the Docker images we have. So the latest currently is 3.0 and but whatever latest you want you can verify. So this link whatever here present is the same link I have provided here for reference, okay? So if I click on this, okay, so it opens this file and inside the, if we open the Docker file, right? So what all packages it is going to install as part of this respective code build image, we can find it here, right? So it is using Amazon Linux 2 as a core, and then it is installing lots of stuff, SSH and then GeoIPM install, lots of packages it is installing, OpenSSL, right? So SSH key scan and lot of things. But what is important for us, it is installing Git, it is installing Firefox, okay, Gcode driver, Chromium driver, so like this. But our important thing here is AWS tools, right? So it is going to install AWS IAM Authenticator and it is going to use the latest current 1.16.8 related AWS means like our Kubernetes version related stuff only. You can see, right? It is going to install the kubectl and version is going to be 1.16.8. So our latest kubectl. So whenever you are doing this and then at that time 1.17 or 1.18 or whatever the cluster you are using, just cross check whatever you are using the equivalent kubectl from this code build Docker image. So like this you can check, right? So you can go here. So you can say code build Docker images and then Google it and then take the latest image, right? Whatever we are using here is 3.0 and whatever you want to use at that point of time should match your stuff, right? So 3.0 and then if you go inside the Docker file, you will find something called AWS tools here. Okay, so AWS tools. So it is installing IAM Authenticator, kubectl, ECS CLI, which I am not interested. It is installing EKS CTL also. Okay, so all these things it is installing, and by default it also will install the AWS CLI version also, which is 1.17 or something. In our course we are using, means like in this course most of the time whenever we use AWS commands we are using AWS version 2 latest here, but in Amazon related code build images I still didn't get this level of image already built here, but it is not impacting us anyway, so that's fine. So even CLI 1.17 or 1.18 related to AWS, we really don't have any issue. For us, kubectl version 1.16 should work for our cluster 1.16. So that means like we have the EKS latest cluster and also kubectl also the equivalent version. So we really don't need to worry. So this is about the core thing related to, nothing related to be installed as part of commands, because kubectl don't need to be installed because it is there. IAM Authenticator don't need to be installed, it is there. AWS CLI, it is there, we really don't need to install. So that's the reason nothing is present in this area. But let's move on to the pre-build area. We have some stuff to do inside the commands. So one is the Docker tag, which is nothing but our image tag. We are going to tag it with the date in this format, year, month, date, hour, minutes, and then seconds. And in addition to that dot, we are also going to have an environmental variable named code build resolved source version will be there in code build. So inside that we are going to use first 8 characters we are going to use for that source code thing. Okay, so we are going to see when the Docker image is built. And in addition to that, next thing is update image tag in our Kubernetes manifest. So this is the important one. So we are going to use the sed command to replace whatever is the repository URI :tag. So this repository URI you are sending via environmental variables, and then tag you have here. So the whole information as part of this, right? So tag whatever is generated now with this current time and then date with this code build resolved source version, right? You are going to update the same thing in your Kubernetes DevOps Nginx deployment manifest here. So it is going to replace container image with that value, right? So that's what you are going to do it in your kube manifest 01 DevOps Nginx deployment.yaml. So this completes these lines. So we are also going to verify the AWS version, right? And next thing is, whenever you want to do a Docker push to your repository, ECR repository, you need to do a ECR get login. Since you are using the 1.x version of your AWS CLI, you need to use this command. Okay. So, but if you see in our section related to ECR, right? So here, whatever we have done, so here we have used our local is version 2, AWS version is 2.0.22, something related to 2.x. So that's the reason whenever you are doing the Docker push, right? So create and then push, right? So before push, so where is that? We have done somewhere here the Docker repository, Docker image locally, and then push Docker image. You can see AWS ECR get login password and then region pipe to Docker login with username and then password stdn. So this format you are going to use for your AWS CLI 2. But the current build image, whatever AWS is providing, right, in this respective is AWS CLI version 1. So that's the reason, means like with this respective Docker image, it is providing CLI version 1. So we are using this AWS ECR get login CLI version 1 related get login command we are using. So with this you will be logged to your Amazon ECR, and then you are just exporting your kubeconfig home directory here, nothing more than that. Okay. And then next what you will do is in the build phase you will do the Docker build, right? So Docker build, and in the current location itself you have the Docker file here, which means like in your code commit repository in the master location itself, means like on the root location itself you have the Docker file here, and then you are going to tag it with repository URI whatever you have provided in environmental variables and the tag whatever you have generated here. So in that way you are going to build the image, and in the post build commands you are going to push that image, right? So you are going to push that image Docker push repository URI and then tag. Already you have logged into your ECR. So immediately push will happen. So once it is happened, it will say Docker image push to ECR completed successfully. So the next thing is to kubectl apply -f and then kube manifest, right? So it means like once you push the image, that image need to be deployed to your EKS cluster in post build. So to do that, you need to first assume your role as EKS kubectl role ARN. Whatever we have created, EKS means like EKS kubectl role, whatever we have created here, right, in our previous step. So the same role we are going to use, means like this is the role we are going to use. Where is this? Okay, so we need to assume this respective role, EKS code build kubectl role. So let's come back here. So assume that role, that will generate some credential information. So from that credential information, you will get the access key ID, secret access key, session token, and then expiration. So once all these are available, and then once these environmental variables are set, so you can use a command called AWS EKS update kube config with your cluster name here. So that's the reason cluster name also you are sending it as an environmental variable. So whenever you run this command, automatically your kubectl is set up there to connect with your respective cluster. That's all. So now once this is done, you can go ahead and then apply the changes, and the changes will get reflected. In addition to that, you can even generate your respective DevOps means like respective image URI information in a JSON file, and then export it into build.json, and then create an artifact file build.json. And also you can generate all your kube manifest, whatever the files are there, right? So 01 DevOps, 02 DevOps related node port service, and 03 ingress. Also you can make it as output artifacts, because in future if you want to extend this and use some other tool to like Lambda or something to create and then increase your pipeline stages, so this build.json and then kube manifest whatever created here will help you in exploring and then adding your pipeline to the next level. So for that purpose, and once this is generated, also you can download these artifacts from S3 and then see that inside this 01 Nginx deployment, if this container image is replaced with the new ECR image. So all those things we can check. So in our next lectures, as part of our checks also, we are going to anyway do that. So this is about the overall build spec, whatever we have written, and these whatever I have commented here, these are like for your additional information, means like as part of this STS assume role, what it is getting and then storing in credentials, you can print in your build log and then verify. So you can uncomment this, and then see what is present in credentials, what is present in key ID, access key ID, secret access, session token, all these things you can see. So this is about the overall build spec.yaml, big build spec.yaml, which looks very simple when we understand it. So about it. So in our next lecture, we'll move on with the next steps. So I will see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this lecture, we are going to understand about code pipeline on a very high level, right? So code pipeline is a continuous delivery service to model, visualize, and automate the steps required to release our software. So its benefits include, we can automate our release processes, we can establish a consistent release process for our applications. So we can even speed up delivery while improving the quality. So it also supports external tools integration for source, build, and then deploy phases. And it also provides a view progress state at a glance. In addition to that, we can even have the pipeline history details for our reference. So code pipeline architecture. So we already know that source, build, and deploy are the major stages inside the code pipeline. So from source perspective, it primarily depends, or it primarily integrated with code commit, EC2 container registry, and then simple storage service, and also GitHub. In addition to that, so from build perspective, it uses code build and then Jenkins. And from deploy perspective, it uses CloudFormation, code deploy, Elastic Beanstalk, service catalog, simple storage service, Elastic Container Service and also Elastic Container Service blue-green deployments. And to monitor the source, it is going to use either the CloudWatch when we are using the code commit or other services, and when we are using GitHub, it is going to use the GitHub webhooks. And so what is this continuous delivery, right? So as developers, I check in the code to the source, and what happens at that time? So whenever the change happened on our source, a CloudWatch event is triggered, and then this entire pipeline gets triggered, and the build process starts, and then changes are built and then push it to the S3 bucket for our artifacts, and then the same is pulled and then deployed to our respective staging environment or whatever the environment configure. And then an email approval flow is sent, and then respective approver, if he approves, then only it will be deployed to our production. And then once again customer start giving the requirements, it comes back, and then developers makes the changes, and then again checks in the code, and entire pipeline story follows. This is on a high level the continuous delivery flow. So in our case, how we are going to implement it, right? So there are different ways to implement this stuff, but we are going to do in a minimal way, whatever is possible for us, right? So as a developer, I will do my Docker related Docker files and also kube manifest. I'll check into the local Git repo, and I'll push the same to the code commit repository. What happens? Immediately a CloudWatch event will be triggered. If I configure the pipeline and then pipeline is available for this respective source, automatically a CloudWatch event will be triggered, and then pipeline will be triggered. So immediately a code build process will start, and then whatever we defined in our code build process, which is nothing but these things, right? So the entire things are going to get executed, the pre-build steps, and then build steps will execute, and then it will create a new Docker image, and then it will push the Docker image to the Docker repository, which is nothing but our Elastic Container repository. And it also pushes the artifacts to the S3 bucket. So whatever the artifacts generated, these will be available in the S3 bucket. And then it also applies, means like the next thing after post build, we also said that kubectl apply -f kube manifest, right? So it will take into consideration whenever this command is executed, automatically the changed Docker image will be applied to our respective deployment, and then old pods will get terminated, and then new pods will get created. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous section, we have completed the code pipeline introduction, and now we are going to create the code pipeline and then test it. So in this step, we are going to create the code pipeline, and then it is going to fail, but don't worry. So we are going to do a break and fix approach here, because we need to understand more about the roles whatever we have created, and at which point the code build is failing, and then how to fix it. So all in all, we are going to learn in a troubleshooting way the whole thing. So even the next steps are also designed in the same way, step by step. Okay, so let's go ahead and then create the pipeline with the name EKS DevOps pipe. So I'll go to management console, and then I'll say code pipeline, right? So we'll go there, and we'll go ahead and then create a pipeline, and pipeline name is EKS DevOps pipe, and service role is going to be new service role as is default, and role name also going to be default. And this whatever the type you are allow AWS code pipeline to create a service role, so it can be used with this new pipeline. So yes, we need that. Okay, so we are going to leave all the defaults here, and in advanced section also the artifact store, it is going to have the default one whatever is present, and encryption key also default. So we are not touching anything from pipeline settings perspective, just providing the pipeline name here, and then I'll go to next. So here comes our source provider, which is nothing but you can have code commit, ECR, S3, Bitbucket, and then GitHub. So whatever you have seen here in your architecture diagram, right? So if you see here, right? So from source perspective, you have seen these things, right? So code commit, container registry, simple storage service, and then GitHub. So in the same way, you are seeing those things, right? In addition to that, one more bit bucket here. Okay, so we can add it anyway. So now we are going to add code commit here, and it is going to provide all the repositories available for us. And what is our repository? Ours is EKS DevOps Nginx. So I am going to select that. And my repository branch is master branch. We didn't create any development branch here, so we'll leave it. And change detection options, right? So we want, means like even it will have a AWS code pipeline can do it, which is periodical checks, which is not good, but AWS CloudWatch is most dynamic. Okay, so we'll try to, means like any change happens to our source immediately to trigger the pipeline. So which option you are going to select is what it is asking here. Okay, so whatever AWS recommends, Amazon CloudWatch, I'm going to use the same thing, and I'll click on next. So source part is done. Now we are moving to the build part. So in build part, I'm going to use code build or Jenkins. So right, if you see here, so we have in build part, we have the code build or Jenkins. We are selecting code build, right? And region is US East North Virginia, and the project name. So if we go back, so we are not going to select anything from here. So we are going to create a new project here. Okay, so create project. So it will open a new window here. So we can make it maximize this. So I can say like this so that it is maximized. And we are going to create a new code build project as part of this process. Okay, so the project name. So that's what we need to provide here. So I can say, I can go back and get the project name here. Okay, so this is the name I want to use it, EKS DevOps CB for pipe. Okay, so I will go back here. So inside this, so I should go to this one. Okay, so it is EKS code build project for EKS pipe. Okay, and we are not going to give any information related, additional tags information. We will leave it as is. And from environment perspective, we are going to use managed image. So we have discussed about this. So either you can use managed image or a custom image, whatever you want to use. Okay, so we are going to use AWS managed image, and operating system is Amazon Linux 2 we are going to use. Always try to be on the Amazon standard so that you will be in a very greater shape. So I always try to use Amazon related stuff. So Amazon Linux I'm going to use, and the runtimes I'm going to say leave it as standard, whatever is there. And here comes the images part, right? So it has the Amazon Linux 2 1.0, 2.0, and then one more 2.0, and then finally 3.0. So whatever is there latest today, 3.0, I have selected it. This related Docker file also we have reviewed about AWS tools related to IAM Authenticator, kubectl, and EKSCTL. If you remember, we have discussed about it. So image version, always use the latest image version from this runtime. Okay, and environment type is Linux, and I'm going to enable this flag if you want to build Docker images or want your builds to get elevated privileges. So I'm going to check that option. And then service role, I'm going to create a new service role whose name starts like this: code build EKS DevOps CB for pipe service role. Okay, so this is what it generates now. And in addition to that, in additional configuration settings, right? So timeouts, we are not going to touch anything, and then VPC related also we are not going to touch anything, right? So if you want to run this build in your respective VPC, you can select, and then in which subnets you want to select, you can select. One thing important here is, if you want this build to run in your private subnets, you need to have in that VPC NAT gateway setup, and from private subnets you have your outbound rules set up there. Okay, so outbound security group related rules set up, but all these things we really don't need for us. Okay, so we are just testing it, right? And we need to define 3 environmental variables, if you remember. So those things we are going to define now. So I'll go here. So it is present here also. So the same readme file I'll have in my Visual Studio Code. So it's becoming difficult to do tabs in the same Safari browser. So what I'm going to do is I'll open this like this, right? And I'll go to my Visual Studio Code, and I'll go to the readme file, and I'll go down, and if you see here, we are at this respective location. Okay, so we are asking for the repository URI, right? So I'll copy this, and environmental variable name is repository URI and value is this one. Okay, so which is the same thing. If you want, you can go ahead and then bring that from your ECR repository, right? So from your ECR repository you need to bring that, so which we already made a note, so we really don't need to worry. So let me come back, right? So I have provided this. Next environmental variable we are going to have is EKS kubectl role ARN. Okay, so this one also I made a note for my environment, right? ARN EKS code build kubectl role. So I'll provide the same thing, and one more is EKS cluster name, right? So and it is going to be EKS demo 1. Okay, so now we have completed the environmental variables. We need to provide the buildspec.yaml. If we check in our buildspec.yaml at the root context of our code commit repository, right? So if you remember, in our code commit repository EKS DevOps Nginx, so buildspec.yaml is at the code root context. Okay, so we really don't need to worry. We can say use a buildspec file. That's all. Default option will be fine for us. And buildspec.yaml, we really didn't give any different names here. It is plain buildspec.yaml. So we can leave as is. And now for CloudWatch logs, so we can even say the same name here. Okay, so that it will create equivalent CloudWatch logs for us. Okay, if you want, we can even uncheck it. Okay, and S3 logs also, if you want, you can enable. So I really don't need anything, so I just gave the same name. So with -group and then -stream, it is going to create the CloudWatch logs. Okay, so now we'll click on continue to code pipeline, right? And it will take us back to our project here. Okay, so it will take us back to our project here. See, successfully created EKS DevOps CB for pipe in code build. Okay, so now I'll click on next. Okay, and for us, we really don't have any deployment phase, but let's see what is available here. Okay, so you have app config, CloudFormation, code deploy, Elastic Beanstalk, ops, work, stacks, service catalog, skill kit, ECS blue green, and then S3, right? We don't have anything related to our respective EKS. Okay, so we don't have anything out of the box available for us here. Okay, so that's the reason we can leave it as is, and then we will click on next, skip deploy stage. Okay, we have skipped the deploy stage, and now these are our pipeline settings. So we have the EKS DevOps pipe. This is the pipe, and then these are the source information, and this is the build stage information, and deploy stage nothing is there. Okay, so I'll click on create pipeline, right? And as soon as we create the pipeline for the first time, it is going to fail. Okay, so let it fail and then see what happened. Okay, and then in our next step we are going to make it a success. So if you want to create a notification rule for this pipeline, so that whenever the pipeline is triggered, you need to get an email and all those things, so you can click on these things and then create those stuff. Okay, so notification name includes any supplemental information, succeeded, failed, cancelled, anything. Okay, so for all these events, if you want, you can enable the SNS topic for this. Okay, so you can go to SNS and then create a target and then add it here. Okay, so but really currently this is not the core focus, so we'll cancel it and go back to our pipeline, right? So now the source is succeeded, one added first set of files, and it is in the build stage. Once you click on this details thing, right, and click on new tab, so it will take you to the code build area in the section where it is running. So if you see here we can see all the stuff what is happening. Okay, so let's start with the install phase, right? In install phase, whatever we have written is nothing to do using latest using latest Amazon image for code build. So all the AWS tools are there, we really don't need to do. That's what we said. Okay, so and install phase is succeeded, it moved to the next phase, pre-build phase, and then it created a tag, right? And then it updated the image tag in kube manifest with these information, and then it verified the AWS CLI version, which is very, very important. The CLI version it outputted here, right? AWS -- version is 1.18.78. Still we are in the AWS 1. Latest version of 1.x only we have here. Okay, and then we are moving on to the login to Amazon ECR is completed, and then running the command ECR get login, right? So login to ECR. So ECR get login, it says that an error occurred, access denied when calling the get authorization token option. So whenever it is trying to log into our ECR Elastic Container Registry, it is failing. So because of access denied exception. So in our next lecture, we'll focus on fixing this issue and then moving forward for the next steps. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In the previous step, we have stopped here at the access denied exception area, right? So whenever we are trying to log into ECR with get login, access denied, we are getting it. So why? Why? Because the code build role, whatever we have created as part of this section, doesn't have access to Elastic Container Registry, right? So let's go back here. So update code build role to have access to ECR, which is full access. Okay. So our code build role mostly should be this way. Why? Because whatever the name we have used to create the stuff, right? So in those lines, it should be like this, but we really don't need to worry about that. So what we'll do is we'll go here and we'll go to phase details, and in pre-build phase, it failed. So at this section, it is telling us very clearly. So now we'll go to environmental variables. You can see whatever it is set, and build details. Okay. And if you see here is the role you can find, right? So code build EKS DevOps CB for pipe service role, right? So I'll click on that role. It will open in a new window with IAM, right? So this is my code build EKS DevOps CB role, right? I'm going to attach a policy. So whatever I said here, which is Amazon EC2 container registry full access. Okay. And I will say that, and it should be there, and attach the policy, right? So now this related error, whatever we are seeing, right? So this should go away, and then we need to move to the next step in our build. So let's go ahead and then do that now. So to do that, we need to make a change and then trigger the pipeline again, right? So there are two ways to do it. Okay. So one is you can trigger the pipeline from there, or you can go here and then select the pipeline and then say release change. Okay. Release change will detect the most recent changes in your location and then release your change. Okay. So I'll say release and rerun the pipeline immediately. So there are no changes, but what is going to happen? We are going to see, right? If you see here, the pipeline source completed and then immediately build started. Okay. So we said release change only. Okay. So we'll go here and then one more time, we are going to see what's going to happen, at which step it is going to fail. And one more time also it is going to fail because one more change we are supposed to do from roles perspective. So we'll see what is that. We have created this code build role, but for this code build role automatically created as part of code pipeline. So it doesn't have this Amazon EC2 registry full access. So we have given that, but still it will fail because there is one more thing happened here, right? So as part of our build spec.yaml, so we are also going to assume a role here, right? So which is assume a role EKS kubectl role ARN, right? So here we are going to assume this role, right? For if our code build have this role, then only code build has this role, then only it can assume this respective role and perform these operations. But currently it doesn't have, so it's going to fail. So let's see, once it is failed, we are going to see what happened, right? So submitted, queued, and then provisioning is happening. So let's wait for it to get to the next level. So it's running. So if you see here, AWS version is completed, and let's wait for the next steps now. So running command login to Amazon ECR get login got succeeded, right? So some warning, but login got succeeded, and then we are moving to the next steps, right? So it is going to do the Docker build. So it is doing the Docker build now, right? In the build phase, it is doing the Docker build, and build completed, and it is running the post build command, which is nothing but is trying to push the image to the ECR repository, and then it successfully pushed it. So image push to ECR got completed. So you can see EKS DevOps Nginx 20/27/10/11/22. So means like all the means like date and then time and then also the code build revision version. All these details it has provided for its tag for this respective image, and then it pushed successfully. And now comes here the failure, an error access denied for this section AWS STS assume role. So it is failing with access denied when calling the assume role operation from code build. So code build doesn't have the assume role for this, so it is failing. So let it fail. Before that, before fixing this, we'll move and then see our version, what our ECR Elastic Container Registry about this respective image. Whatever starts with FC93 is pushed to our ECR container, right? So ECR registry. So Elastic Container Registry, open it and go to our DevOps Nginx page, means like EKS DevOps Nginx related repository, open it, and our FC93, this got pushed just now, right? So that's good. So which means the first part of thing is working. So the push has been worked successfully. So which is nothing but, so this part is succeeded. So code build has built it and then pushed it to the ECR. So this part is completed. Now code build need to go here and then push the same thing, means like push the manifest to the EKS cluster. So it need to do that. So let's go ahead and then fix that in our next step. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous lecture, we have completed till here where we are getting the failure from AWS STS assume role with access denied, right? So now what we need to do is we'll go back to our GitHub repo and then we'll fix it that respective step. So update code build role to have access to STS assume role we have created using STS assume role policy, right? So we need to create a STS assume role policy now. So let's go to our IAM, right? So so let's go to policies in IAM and create a policy and choose a service, right? So when you choose the service, search for STS, right? STS, and in actions select inside right assume role, and in resources, right? So in a specific resource section select add ARN and provide your ARN of your EKS kubectl related code build role. So which is nothing but whatever you have provided in your environmental variable here, right? So this role you need to provide. Okay, so if you want, you can even search this role EKS code build kubectl role in your IAM and then get that information and then paste it here. Okay, so you can go here and then go to IAM, right? And in IAM search for this respective role, right, with this role name, right? So go to roles and search for this role, open this role and then copy the ARN from here and then paste it here. That's all. Okay, and then click on add and then we are done here. Okay, so if you want, we can click on review policy and then provide the name of that. Okay, so this is the STS assume role. So the role name I'm going to give is EKS code build STS assume role related policy. Okay, so where is that? So it should be somewhere here. Okay, and I'll provide code build to interact with EKS cluster to perform changes, right? So I'll come here and provide this and then create the policy. Once this policy is created, I'm going to go to the roles, right? And then associate this role, means like I have a code build EKS DevOps CB related role, right? So means like my code build role. So I can go here and go to build details and go to my code build service role. Okay, so this is the role. So I'll go to that service role and I'll go to attach policies and I will try and then search for our EKS code build EKS code build, right, STS assume role related policy. Okay, so I'll say attach policy. That's all. So now my code build EKS DevOps related whatever is associated with my code build project also gets the STS assume role related policy associated with it. Okay, so now what happens is if we run that changes, then it is going to succeed. So let me close this, let me close this, let me close this, all I am closing. So now we'll go to pipelines, right? And now one more time we will select that pipeline and then do the release change. Okay, so we still didn't make changes and push anything. We can do a release change like this. Okay, so in our case what I have done is in my documentation we can do this way, or we can even do something called make a change and then push it. Okay, so whatever the things works for us. Okay, so make a change and push it from your local, or do this way. So I just done a release change here, anything is fine. So now let's go here and then verify this stuff. Okay, and this is going on. So once this is ready, we will see what happens. So good. So now it verified the AWS version. So lots of things are getting succeeded. Now the build thing is going on. So once the build is completed, so it is going to move on to the next steps. Okay, so push also completed. Now you can see it here, running command AWS STS assume role, this one got succeeded and it went to access key ID, next step, and then secret access key. All these next steps are getting executed. And then now if you see here, we said that AWS EKS update kubeconfig name EKS cluster. So it already updated our kubeconfig information, and then it moved to the next step of kubectl apply -f kube manifest. Okay, so it applied the change so that deployment got created, node port service got created, and then DevOps service got created. So all these things got created. Why? Because it is the first time, right? So those are not there, and then it got created, and then changes completed, and then it also created the artifacts here. Okay, so which we can reference for future stages if we implement anything. Okay, so now these changes completed. So let's come back here and say kubectl get pods, right? So on our cluster we should have EKS DevOps related 2 pods up and running. So I'll also say kubectl get ingress, right? So ingress should be created. So now what I will do is we can go to in our we'll open and then go to EC2, right, and go there and then go to load balancers and verify our load balancer application load balancer is getting created. So it's getting created, right? So we'll also verify our Route 53 domain. So that should be also registered, right? So our Route 53 domain should be mostly devops.kubeoncloud.com. So let's also verify that, right? So let's go here and go to kubeoncloud.com and you should see DevOps related thing here. Okay, devops.kubeoncloud.com. So that's good. So once this respective load balancer is provisioned, right, so we'll be able to verify the stuff. So we can even see the target group and targets. So it's still in progress and then they are healthy. So we'll see load balancer is active now. So let's take the DNS and do the NS lookup. Okay, so this is always good to do this verification, and it provided some IPs 222 at the end and then 13. So I'll do the same for NS lookup and then devops.kubeoncloud.com. So it also provided 13 and then 222. So which means we are good. So now we'll go to our browser, right? http://devops.kubeoncloud.com/app1/index.html, right? So now I got the app version v1. So that's good. So in our next lecture, we will focus on changing the version to v2, checking the code, and then how it changes we are going to see. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous lecture, we have completed testing by fixing the STS assume role fix. Okay, So now we are going to change the app version to v2 or v3 and then check in the code and then see how pipeline triggers and then how the changes flow across the thing. Okay, so now let me go and then close this EC2, or we can leave it like this. So the next thing is make a changes in the index.html. Okay, so we can say v3 or v2, whatever it is. Okay, so we'll go there and then make the change, right? So let me make this smaller, let me close this, and here is the folder I have added from my local git repo, right? So, and this is the index.html. So I'm going to say something like v3, okay, and then I will save it. Okay, and if I go here and then say git status, so there is a change for our index.html. So I will say git add git commit -am and v3 deployment I will say. Okay, and I will say git push, right? And now we'll go back and then verify the same thing on our pipeline. So let's go here and go to our pipelines, and if you open this DevOps pipeline, so currently nothing, one added first set is the source it is referencing. So let's wait for the changes to happen. So now the changes came in. So v3 deployment is the source it is referencing now, and it moved on to the build phase. And then here if I click on details, we will see the build logs now, right? So let's wait for the build logs to come in here to see what happens, right? We got the logs and then it says that status also succeeded. So we can go down and then all the changes looks good. It is going down, 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 down. So it went here and then assumed the role, and then if you see it here, earlier it got created because it is the first time. So now it is saying configured, right? So for EKS DevOps deployment, okay, so inside this EKS DevOps deployment object it said configured, but we didn't change anything related to node port service or ingress service, so it is in the unchanged state only. Okay, and then we completed this. So now we can go back and then verify our EC2 management console. This is nothing, unchanged. Okay, so nothing happened here. Okay, so now if we click here, enter, it should become v3, right? Whatever we have provided. So one thing we didn't check here is S3 buckets, right? So we also need to see our source build whatever has the artifacts section. So in artifacts section for our build spec.yaml, so whatever we said is take the build.json and then kube manifest. Okay, so kube manifest should have our respective deployment file, and then this value should be replaced with the latest container image. So we need to verify that. Okay, so that's our understanding and then learning process about what happened inside that, right? So let's go there and then verify that. So go to build details, and if you go inside build details, so if you see here artifact upload location inside artifacts, so if you click on that, this is the correct build whatever happened as part of this current build. Okay, so I'll open that, right? And it opened this respective build, so I'm going to download it. So I have downloaded it and then opened it in my local BLKHS7WA, right? So it is matching the same thing here. I'll go inside kube manifest, right? So if you see here in the build.json open with the Visual Studio Code, you will find the image URI, right? So at the end you will see that 09631C52, right? So you can see the same in our build logs also, we should see that. Okay, repository, when we are pushing it, we are printing it. Okay, so here, okay, so 09613C52, so this is what we pushed it, and then we found the same at the end. You can see 3C52, the same thing you should see in our DevOps deployment object. Okay, so go to kube manifest and then see this, and you will find that. Okay, so container image is replaced with the repository URI and then tag with 09613C52. So that's the thing. Okay, so we have verified those things. Good. So now I am happy. Okay, so this completes this, and now what we are going to do is we have verified this stuff. Okay, v3 stuff. Okay, now we are going to make a change to our ingress manifest by adding additional devops2.kubeoncloud.com. So it's not only these changes are not only for our Docker application images, but even if you want to apply the changes for your kube manifest, only thing is your application build one more time generated and then new Docker image came, but still you will be able to do it this way. Okay, so devops2.kubeoncloud.com we are going to add for our manifest here. So this is our ingress manifest in our local git repo, right? So I'll go here and then copy this and I'll put a comma space and then I'll say DevOps2 and then I will save it, right? And if I go back here and then clear and if I say git status, so my ingress service has a change. So I'll say git commit -am and I'm going to say v4 and v4 deployment, or I'm going to say ingress DevOps to DNS name change, right? And then I'm going to push this change to the remote code commit repository, right? So the change is pushed. So let's go back here and go to our code build and go to our pipeline, right? And now soon the pipeline should trigger. It triggered. So if you see here, code commit is picking the latest source now. So let's wait for the source to be picked. Once it is picked, it will move on to the build phase. So let's wait for it. So good. So now we got the ingress DevOps to DNS name change related thing. So now the build is running. So I'm going to click on details and we'll go to that respective build details and then logs. So we can see build got succeeded and all the phases got succeeded. So let's go to build logs and verify what it changed, right? So you can see ingress manifest got configured and then deployment, because Docker also runs for creating a new Docker image. So deployment also got configured and then node port service unchanged. Okay. So now let's go back to our Route 53 and then verify if we have a new 2 more DNS names here. Okay. So let's go to hosted zones and KubeOnCloud. So we need to refresh the entire stuff here. Okay, so screen refresh. Okay, browser refresh. That's good. Okay, and I'm not sure why this still didn't come. It got it right. So devops2.kubeoncloud.com. You can see them here. Okay, so now let's go to here and then clear it and then say ns lookup devops2.kubeoncloud.com and then it's resolving 13 and 222. It looks good. So now take it in a new browser, new tab, https://devops2.kubeoncloud.com/app1/index.html. So now we should have our application up and running with v3 version, right? So this is very nice now. So this completes the DevOps section implementation with code commit, code build, and then code pipeline. So if you want to delete all the manifest whatever we created, we need to delete definitely, because we have a load balancer here which is charging. Okay, so which is chargeable and then it will be of high price, right? So first let's remove the manifest. So as you in your local already kubectl is configured, so I am going to say, and I am inside this DevOps Nginx folder only, and I have the kube manifest here. So I'm going to say kubectl delete -f kube manifest. So I'm doing the full cleanup of my whatever I have created inside Kubernetes cluster. So once that is done, so we'll also remove the other stuff, right? So now this is done. If I go ahead and then say kubectl get pods, nothing should be there, right? External DNS only, right? Yeah. Now let's go here and my load balancer is gone. Good. So now this is good. So now we'll go back and then remove our pipeline is per month $1 or something it charges. If you want, you can even delete the pipeline. Okay, so I'm going to say delete, no resource object needed for this source action. So delete. Okay, so I deleted it. Okay, so now pipeline is gone. So we have the code build projects here which we are going to clean up. So EKS DevOps pipe. So I'm going to delete it. So delete build project and I'm going to say delete. and I'm also going to delete the old ones which I have created as part of this. Also let me delete this so that it will be cleaned for us. Okay, good. So now only one thing we have with us is code commit, right? So let's go here, and then in code commit we have something called EKS DevOps Nginx. So if you are not interested, you can delete this repository, but usually I hold my repository here. It doesn't cost much for me, so I leave it like this. Okay, so if you want, you can delete this repository also. So this completes the cleanup process also. In addition to that, if you want to delete all the roles whatever we have created as part of this, so you can go there and then even delete those. Okay, so we can say IAM service, and if we go for the roles, so we'll find something called EKS, right? And then we'll find something called code build EKS DevOps. This is one role which we have created, and EKS code build kubectl role, this one we have created. So let's delete them. Okay, good. And these roles are related to CloudWatch related roles, events. If you want, you can even delete them. Okay, so I'll leave it as is for me. So this completes the entire DevOps section we have implemented. So in our next section, we'll focus on another concept like microservices or auto scaling or something else. So until then, bye bye. Thank you. Welcome back. In this section, we are going to deal with microservices and deploying those microservices on EKS cluster. So what are these microservices? So let's get a very high level overview about what are these microservices, and then we'll move on with an example and then deployments. So microservices, also known as the microservice architecture. It is an architectural style that structures an application as a collection of services that are highly maintainable and testable. So they are loosely coupled, independently deployable, and organized around business capabilities, and owned by a small team. Each microservice can be owned by a small team. So let's see the benefits with this microservices architecture, and then what all additional availability things also we are going to get based on microservices. So from developer perspective, it is going to be a developer independence. So small teams work in parallel and can iterate faster than larger teams. Isolation and then resilience. So if a component dies, we spin up another while and the rest of the application continues to function. And scalability. Smaller components take up fewer resources and can be scaled to meet increasing demand of that component only. So that is one important benefit for us. Lifecycle automation. Individual components are easier to fit into continuous delivery pipelines and complex deployment scenarios. Not possible with the monoliths. Relationship to the business. So microservices architecture are split along business domain boundaries, increasing independence and then understanding across the organization. So in our next lecture, we are going to take an example of microservices and then implement it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to work on a microservices deployment. So in addition to whatever we have used earlier, elastic load balancing, classic network, all these load balancers, we are also going to add one more AWS service as part of this, which is simple email service. So we'll see why we are going to use additional service of AWS for our microservices. We are going to look into now. So we are going to have two microservices, and one is user management microservice, and which are going to have the following APIs inside that. So create user API, list users, delete user, and then health status. Even we'll have some other APIs which we really don't need, update API and other stuff. And so whenever we create a user, it is going to store that user in the users DB. So now we are going to have one more microservice. Already we have discussed that microservices are independent units of our code, which means like they are completely independent, and then we will be able to call from one microservice to another microservice. So with that said, so we are going to have one more microservice named notification microservice. So it is going to have something called send notification API and its own health status API. So what happens now? So, and when it need to send the notification, it need to connect to the SMTP server. So what does this notification mean? So whenever a user is created, it is going to send an email using SMTP server. So let's see in a step-by-step manner. So as a API developer or API user or whoever it is, so if you tries to create a user using Postman client, right? So whenever we create a user, so the user gets first stored in users DB, and then this respective create user API from user management microservice going to call the send notification API. So whenever a new user is created, so we need to send a notification for that respective user's email address. So we'll call the send notification API. So the email will be triggered, and using the AWS SMTP service, so we are going to send the email to the end user. So this is what the overall use case from microservices perspective, so which we are going to deploy on the Elastic Kubernetes service. So let's see all these things in a architectural pattern. So we have seen in a functional pattern how this is going to work so far, right? So let's see in architectural pattern how this is going to fit on Elastic Kubernetes service on AWS. Moving on, so microservices deployment on AWS EKS. So we are in AWS cloud, and whenever we create the EKS cluster, so which is nothing but the cluster control plane we can call it as, and it creates our VPC, respective subnets, and public private subnets and equivalent NAT gateways. Okay, so now whenever we create a node group, EKS manager node group, and we are creating it in private subnet, which will be more real to the real-time use case. So we are not trying something on public subnet, so we are trying to be more realistic in real time how it is going to be. So we are creating it on the private subnet. So in this we have created a two node group, so which will have worker node 1 and then worker node 2. So as soon as these are created, the outbound communication for these worker nodes will be via NAT gateway, and even to the EKS cluster control plane, or any workload deployed here want to access to the external environment, they go via NAT gateway only. Okay, so now moving on, the next step is so notification microservice deployment. So right, as usual, we already know that if we want to create a deployment on Kubernetes, we already know that we are going to have a deployment manifest, and to expose it we are going to have a service manifest, correct, right? So notification microservice, we are going to deploy that respective application as two pods, and then what we are going to do is this notification microservice needs access to our SMTP server. So we are going to use SMTP server as simple email service in AWS. So we are going to create a SMTP external name service in our Kubernetes cluster, so wherein this notification service calls this simple email service endpoints via external name service present inside these worker nodes. Okay, so now the next thing is this notification service should be called by the user management service. So for that purpose, this notification service needs a, means like this notification microservice needs a notification cluster IP service which we created. Then what happens, right? So we are going to have a RDS DB for our user management microservice. So for user management microservice deployment, whenever we deploy it, its equivalent pods get deployed, and using MySQL external name service, they are going to connect to the Amazon RDS database, right? So now once they connect to the Amazon RDS database, this application inside UMS pod, which is user management microservice application, is going to come up online. So now the next thing is you want to expose this user management microservice to the internet world. So what are the options available if I am sitting inside the private subnet? So the options available for me when I am sitting in the private subnet is either the load balancer of any type. In AWS, it is going to be network load balancer, classic load balancer, or ingress load balancer. And we try to always use the latest and then greatest. And as we are going to use microservices in future, we might have multiple microservices. Considering the design in such a way, so we are going to use the ingress service, which is nothing but application load balancer. So first we will create a UMS node port service here, and then we are going to create a ingress service. So which is nothing but UMS ingress service. So this UMS ingress service will be pointed to this respective UMS node port service. So now the next thing is, whenever the UMS ingress service is created, right? So automatically it is going to use our Kube Cloud star.kubeoncloud.com related SSL certificate from the certificate manager, and we are also going to use the external DNS, right? So for that purpose, it is going to register our ums.kubeoncloud.com automatically here. Okay, so we are also going to register one more DNS, which is services.kubeoncloud.com. So now with Ingress, we also have our Route 53 DNS also registered. So as an user, my next step is to access it and then test it. So I'll try to use user management / user or health status or whatever I want to use. I'll try to use it to access it. So all this testing, I'm going to do it via Postman. So this is the endpoint for our create user. So when I'm trying to create a user, what happens? The request will come to the Ingress service. And from there /* we have directly routing to all to the UMS pod. So the request will come to UMS node port service, and then from there it will split and then do the load balancing between UMS pods present there. Okay, and then from there it will go ahead and then go to the external name service and then create that user inside the RDS database. So once the user is created in the RDS database, then it need to call the notification service, right? So it will call the notification cluster IP service, which will send the traffic to the notification respective pod, and then notification service will call the SMTP external name service to send the email via simple email service. So now this simple email service will send the email to the respective end user, and then there they will be able to see the email. So this is the entire architecture we are going to build now, right? Means like this is the entire stuff we are going to implement as part of microservices deployment on AWS EKS. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous lecture, we have understood about what are microservices and then what we are going to deploy as part of microservices deployment on EKS. So let's see what is that one more time. So this is the entire architecture which we are going to implement now. So what we are going to do is we'll go to our respective GitHub repo section, which is 12 microservices deployment on EKS, right? So step 1 and then step 00 we have completed. So just to look on a very high level, the use case is from user management microservice create user API. If you create a user, it is going to create that user and then store that data user in the database. And then it is also going to call the notification services, send a notification API to send an email to that user when we called the create user service. So that's about the entire use case description. And then these are the Docker images we are going to use as part of this section, which is user management microservice. So this is the one, and notification microservice from Docker Hub, Kube notification microservice 1.0.0, and then notification microservice v2 version, which is 2.0.0, right? So now as a prerequisite step, so there is going to be one prerequisite step related to RDS database, ingress controllers, and then external DNS. And then one more prerequisite step related to SMTP server, which is AWS simple email services. So in this lecture, we will primarily focus on prerequisite 1. Okay. So first thing is we need to ensure that we have our RDS database up and running. So we have created RDS database as part of section 06 EKS storage with RDS database. So as part of this respective section, we already created the RDS database. So if it is not running and then if you have stopped it by any chance, let's go there and then start that database. Okay, so mine is running, so we really don't need to worry. So and that respect to RDS database, we are going to associate in our Kubernetes for our user management microservice application using external name service with this respective manifest. Okay, and the second thing is ALB ingress controller and then external DNS. So if you see our architecture here, so we have also highlighted that we are going to use the ingress service here for exposing this respective application user management microservice to the internet world. So for that purpose, you need to have the ingress controller installed and then running. So that's what we need to cross check. And then in addition to that, we also need to ensure that external DNS is also running, external DNS part, so that whatever the application we are going to install here or create its equivalent ingress service, so its DNS also auto registered inside the Route 53. So for that purpose, external DNS also should be running. So their equivalent sections when we have done is in 0801 ALB ingress install and then 080601 deploy external DNS. During these two sections, we already have done that, and those should be already available. So we can cross check that. Okay. So let me clear this out and paste it, right? So ALB ingress controller is running, and one more is in default namespace, we are going to have something called external DNS pod is running. So we are good here. Okay. So now we'll look into prerequisite 2, which is create simple email service, which is SES SMTP credentials we need to generate as part of this section. So if you see here in the prerequisite 2, so first thing is we need to generate our SMTP credentials and then validate our email addresses and then move on to the next steps. Okay, so it is subdivided into 2 steps. One is generating SMTP credentials and the second is verifying our email addresses. Okay, so first start with creating our SMTP credentials, right? So let me go to the simple email service. Simple email service in AWS. So if you see here in the SMTP settings, okay, in left navigation you can see SMTP settings. You can generate your SMTP settings here. Okay, so server name is going to be this for this respective entire AWS region, US East 1. So and then ports, default ports are going to be these things, and we are going to generate the credentials to access this SMTP server. So I'm going to say create my SMTP credentials. Okay, and I can say this as either whatever the name I want to give. It says SES SMTP user. I'm going to say Microservices SMTP user or user management microservice or whatever, right? So I'm going to say Microservices. Okay, Microservices SMTP user. Okay, so now I'm going to say create, and it generates some credentials for us. So let me make a note of these credentials. So copy. So we can even take these things and we can even download the credentials. And in addition to that, so we can take these credentials and then directly update wherever it is required. So what I can do is we'll leave it here. We have generated the credentials, and one more time we'll go inside simple email service on a new tab. Okay, so we'll save it here. Later when we are updating, we'll copy from here. So I'll go to simple email service now, and this step we have completed now. Okay, so download the credentials and update that the same for below environmental variables which you are going to provide in Kubernetes notification microservice deployment.yml. So you can copy these things and go to your Visual Studio Code and take any new file, right? File, new file, where I'll create here just, okay, I don't know what is happening, so I'll say new file. Okay, temp. Okay, and I'll paste it here, and this is going to be our mail server host, right? So if you see here, the mail server host is going to be whatever the same thing, and now the mail server username, so this is going to be our username, right? And this is going to be our password. So I made a note of these things, and my from address for my from where the email is getting initiated or from address in my email should look like stacksimplify@gmail.com. So this is my settings I am going to update in my notification microservice related environmental variables. Okay, so now first thing here is we need to verify our email addresses. So we are not going to use the production grade SES service. We are going to test only for testing purposes. So whatever the email you are sending it from, means like the from address and to addresses whatever you are sending it, so all those things need to be added here and then validated. So that's what I have written here clearly. So the from address, right? So we need 2 email addresses for testing notification service. Verify a new email address. So email address verification request will be sent to that addresses, clicking on to verify your email. So from address and then to address. So both you need at least 2 email addresses for you, and then those email addresses should be in verification state from management console, right? So I'll say verify a new email address, and I'm going to say stacksimplify@gmail.com, and one more email which is to address also I'm going to use, which is nothing but dkalyanreddy@gmail.com, right? So let me close this, and I opened my Gmail for Stack Simplify and then dkalyanreddy, and I got the email related to that just now. So I'm going to click on this verification email, and one is done. I am also going to do for the stacksimplify@gmail.com too. So I'm clicking on that. So this is also done, right? So let me go back now and then refresh it, right? So now verification status should be verified. So this tells that these 2 emails we can use in from and to currently. Okay, so we can even send test emails and even test it now from here. Okay, so only 2 options we use it here. One is SMTP credentials, so where we have taken the server name from here, right? And then credentials we have generated from here, and then made a note of those credentials here. And from address we said that whatever is the first email address we verified here, right? This one. And to address the other email address, how many number of to addresses you want, you can add those things. Okay, so now these everything is completed. So you can also verify that whatever the user created, right, this respective user will already be there in our IAM. Okay, so this user is created as SMTP user in your IAM console, so it will be here. So in future, if you really don't want this user and then you want to delete it, you can go to IAM and then delete it. So these credentials are going to be dummy for you. These are not going to work for you. You need to generate SMTP credentials from your AWS account and then use it in your case. Okay, so anyway, after this respective section, I'm going to delete this part. So at that time, these things are going to be invalid. So that's about the SMTP credential generation step, which is nothing but step 3. Okay, so we have discussed step 2 and step 3 in this lecture. In our next lecture, we will move on with discussing the Kubernetes manifests required for this entire microservices use case. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this lecture, we are going to discuss about the Kubernetes manifests related to user management microservice and then notification microservice, and also our ALB ingress service. So step 4, 5, 6 and then 7 and then 8. So all these 4 steps are primarily related to this manifests only. So let's start with step 4, which is create notification microservice deployment manifest, right? So I have created everything and then put it ready here. So it's a standard deployment manifest. So we really didn't add anything special here, but we'll go and then review it step by step. Okay, so let's go to, if you see here, 01, 02, 03 to 07 are our templates in 12 microservices deployment on EKS, and inside that kube manifests. Okay, so you know that 01 is related to our MySQL external name service, and then you need to replace your external name here related to your RDS database. So whatever the RDS database endpoint is present with you, so you need to replace this value. So let me go there and then show you that one more time. Okay, so this endpoint you need to replace here. So this is the endpoint information what you need to replace in 01. And user management microservices deployment. We are not going to touch this first. We'll go back to notification and then come back to user management. Okay, so this is user management microservice deployment, and this is user management node port service. Okay, those two are standard ones. Okay, so now we'll go to notification microservice deployment. So if you see here, API version, kind, metadata are standard stuff here, right? And inside deployment, you know that we'll have spec, replicas, selector, and then pod template. Okay, so selector will have the match labels with whatever is present in pod template label. This is same. Okay, so that is good. And replicas, we know that we are going to have 2 replicas of our application, right? So we can have 2 or 1, whatever we want, we can have it. Okay, so that's fine. So I'm just having it 1 for now. So now the next thing is in pod template spec, you are going to have the container name, and then image is whatever we have discussed here, right, in our section related to images. Stack simplify cube notification microservice 1.0.0. And for user management, you have seen already in multiple sections, it is going to be 8095 as the port. So here it is going to be 8096. So here one additional thing I have added, it is image pull policy always. Okay, so you can remove it. So what this does is, whenever you are doing the notification microservice deployment, immediately, even though it is present in your worker nodes, that respective image, so it is going to download it from Docker Hub. So just to add some additional option to let you know that we will have in container definition something like image pull policy. So always means always it is going to go to Docker Hub and then pull that image to these worker nodes and then use that image from worker nodes. So if this option is not there, what it is going to do is like, so it is going to use whatever previously downloaded notification service image, okay, with whatever the same tag is available. So that's about it. And now you can see it here, environmental variables, whatever we discussed, right? So these are the things. Okay, mail server host, username, password, and then from address. So let me copy the username from here, whatever we made a note, or we can go here and then copy the username from here also if you want. Okay, so I'm going to copy this and go back to our notification microservice deployment here, and I'm going to paste that, right? So that's the thing. And mail server password, I'm going to remove this first, right? And I'm going to get it from here, right? Copy and then paste. And username, we know that it is stacksimplify@gmail.com. The from address from which the email is getting initiated means like it looks like whenever you reach the email, the from address should be this one. Okay, and mail server host, you can see SMTP service. So let's go ahead and then see what is this SMTP service. Okay, so you can see here notification microservice SMTP external name service. Okay, so API version, kind, and metadata, and then spec, all these are same as MySQL external name service. Okay, only thing, the value under the external name is going to be whatever is present here, right? So in simple email service, in SMTP settings, right? So if you see here, this is the server name. So that is what will be your external name here. Okay, so that whenever the notification microservice want to connect to SMTP server and send the email, the mail server host is going to be SMTP service, which is nothing but the SMTP service external name service. SMTP service, this is the service which we are referencing here. Okay, so if I name it as SMTP service ABC, so this email, this value becomes SMTP service ABC. So it's just only a naming convention. Okay, so I'm just going to remove this, but that's the thing. So we created external name service here and then referenced that in our environmental variable here. So we have completed discussing about this notification cluster IP service, notification microservice deployment, and then notification related SMTP external name service. Okay, so which means our step 4, create notification microservice SMTP external name service, and then notification microservice node port service is completed. So in our next lecture, we'll focus on these other steps, which is UMS node port service, user management microservice deployment, MySQL external name service, and UMS ingress service. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous lecture, we have reviewed all the Kubernetes manifests related to notification cluster IP service, notification related external name service, and then notification microservice deployment manifest. So now we are going to look into user management microservice, which is UMS node port service, UMS deployment, UMS MySQL external name service, and then UMS ingress service. So let's go ahead and then review them now. So if you go to our GitHub repo, so the step 7 here, whatever it outlines is like update user management microservice deployment manifest with notification service environmental variables. So if you see in this architecture diagram, so UMS service need to call the notification service. So how it is going to call? It will call the notification cluster IP service, and then cluster IP service will call its own notification respective pod, right? So now let's go back and then review that in our Visual Studio Code. So user management microservice. So if you see its environmental variables, this is the same user management microservice deployment template, whatever we have been using from EBS block store and then RDS databases or network load balancers, application load balancers, Fargate everywhere. Okay. So that's the reason we are not going in detail what is kind, and then what is spec, what is selector, what is spot template here. Okay. So we are directly getting into the environmental variables, and in environmental variables, so these are the standard ones which are related to RDS database, which we have discussed in our RDS section. Only difference is here we really didn't put our secret in a separate YAML manifest. Okay, so this is one Kubernetes object, and with the 3 hyphens we have separated and then added one more secrets manifest here directly. Instead of having them in 2 separate files, both deployment and then its own secrets, we have put it in the same file. That's all. Okay. So now in addition to those environmental variables, we are going to add 2 more environmental variables, which is notification service host and then notification service port. And notification service port, we know that it is going to be 8096. That is good. Okay. So for notification service, it is 8096, and user management, it is 8095. And the notification service host value is going to be the notification cluster IP service. So you can go to this notification cluster IP service and get this name from metadata, and then you can directly update it here. So now you have completed the updation, means like we already have it updated here. So we just discussed about that. Okay. So now you know that user management will have a node port service here, because that using the node port service only, we are going to integrate it with the ALB ingress controller, so which we discussed in our ingress controller section also. So this is the node port service standard template, which is coming from previous thing. Only thing is health check path is going to be the same thing whatever we have earlier also. No changes to our node port service from our user management node port service from our previous templates. Okay, but now let's come back to our ingress SSL redirect ingress service. Okay, the name is going to be EKS Microservices demo. This I have changed it. So, and the label, so you can put the label as the same. Okay, so you can map it to user management REST app. Okay, so okay, fine. So EKS Microservices demo, and if you see it here, so / SSL redirect is already there from beginning, which we have seen. And in this, if you want to change, what are the things you need to change if you are doing it, right? So primarily you need to change your SSL certificate path here, right? Means like your SSL certificate information with your account ID, and then all these things you need to put in this template to make it work for you. And rest all, and then you need to update your own domain. So this is services.q1cloud.com. So in your case, it is going to be something else, right? You see here, this ALB ingress manifest also only 2 changes as we discussed, which is your certificate you need to update, and then your domain name you need to update. And one thing you need to make a note of is this one is going to send the traffic to user management REST app node port service, which is nothing but our this respective node port service, which eventually will catch up the pod using this selector and then send the traffic to user management microservice container here. Okay, so that's about it. So this is about the manifest discussion from 01 to 07 in these 2 lectures. Okay, so we have discussed everything. In our next lecture, we will go ahead and then deploy and then test everything. So I'll see you in the next lecture. Until then, Bye bye. Thank you. Welcome back. In this lecture, we are going to deploy all these manifests, which is nothing but ingress service, node port service, microservices deployment, notification deployment, all these 7 manifests, and then test it now. Okay, so let's go back to our GitHub repo, and we are in our step 9 and then step 10. We are doing it right now, and then even we'll do the health status, which is step 11, and then even step 12. Okay, so which is step 12 and then step 13. All these testings we are going to perform now. So let's go back to our step 9 and then deploy it. So to deploy it, we need to be in that respective folder, right? So cd 12 is nothing but microservices deployment on EKS. So I'll say kubectl apply -f kube manifest. Okay, so this should deploy all our Kubernetes manifests created as part of microservices. So which is nothing but MySQL user management microservice and its DB password secret, and node port service, notification microservice, SMTP service, notification cluster IP service, and then EKS microservices demo ingress service. Okay, so now if I say kubectl get pods, so it's running, so which means like notification already up, so we can say kubectl logs -f, and then we have straight away, if multiple pods are running, we can even run the commands like this. Okay, so I will say this way. So okay, so we really don't need to worry about what is present here, so which is pod related extra name. Okay, so I have added this with egrep so that you can just take this command and then cross check your logs. Okay, so started notification service, we really don't have anything issue with notification service. So now we'll also verify our user management service. Okay, so I'll paste it now here, verifying the logs of our user management service. So it also started, so which means everything is good. So I'll also say kubectl get pods, so all are running, ready. Okay, so good. So now we are going to also verify our external DNS logs, so it should add the stuff related to our 2 new DNS entries for us, right? So which is services and then UMS. Okay, so whatever we have configured on our respective ingress manifest. Okay, services and then services.kubeoncloud.com and then ums.kubeoncloud.com. Good, so they have created it. So now we will go back to our EC2, right? So and verify our load balancer also. So only we should have user management standard deployment only, so it should be running user management microservice related stuff. So load balancer is provisioning. We'll go to target groups, so it is still waiting, so it is waiting for the registration, so we'll wait for it to get completed. In meantime, if you want, we can cross check, go to route 53 and then cross check our DNS names. So let me close this hosted zones, and if you see here, go inside that, and if you go here, so we have services.kubeoncloud.com and then ums.kubeoncloud.com. so everything looks good. So now our next step is to go ahead and then verify the stuff once the load balancer is up and running. So clear kubectl get ingress, so it's good. So go to load balancer and it is active now. So as usual, we always do the ns lookup test, so copy and then I'll say ns lookup and then paste it. So I got the IP is 104 here something and then something.63. So I'll say ns lookup space services.kubeoncloud.com. So same 63 and then 104. In the same way, I'll also say for UMS, right? So user management microservice, it's the same 104 and then 63. Good. So now we'll go ahead and then verify our these things. Okay, user management microservice health status. Okay, and it should be up and running. See, user management microservice is up and running. So from user management microservice only you can call the notification health status. So I have done the coding in such a way. So now why? Because whatever you want, you can call from your notification, means like from user management, you can call the notification for send notification, right? In the same way for health status also you can call the same way. So I am calling it, okay. And what happens, we'll see notification service is up and running v1. And if you want, you can even additional notification service information will be there, so which is related to printing the host name, okay. So you can see notification microservice 655 something and then bjkxf, okay. So this should be related to our kubectl get pods, right? So you can see notification pod is bjkxf, which matches here. We are printing the host name of our notification microservice, okay, means like the Docker container respective host name. So this completes the verification, right? So verification of microservice health status stuff. But now we need to import our Postman project and then test it, okay. So we need to import the Postman project for us. So it should be available here, AWS EKS Masterclass Microservices Postman collection. So you can go to your Postman and then just import that file, okay. Or you already has done this work in step 0403 also. Once when you are doing with the user management microservice with MySQL DB. So when you are doing this in your EBS block store, you have done this step already. But just for additional thing, I also added the same Postman project here also for your reference in 12 microservices deployment on EKS, okay. So now let's go back to our Postman, and then first what we need to do whenever we go into the Postman, the first step for us here is in the step 12 is to create our environment, okay. So let's go here and then add environmental URL, which is nothing but services.kubeoncloud.com. So here is the settings, manage environments. So I'll click on this, and then earlier we tested ALB, Ingress, CLB, NLB, UMS, node port. Now we are testing this one, right? So what is this? This section is related to microservices, right? Microservices on EKS, and the URL will be this one, and this value, initial value should be this one, HTTPS and whatever your domain.com. Mine is kubeoncloud.com. Whenever I put it here, current value also should be the same thing. So always the same value should be initial value and current value, and always it picks from the current value only. So you need to ensure that whenever you enter the data in initial value, current value is auto populated. Add it, close it, and now if we go here, no environment to, I need to select microservices on EKS. So this is the environment we created, microservices on EKS. First I'll test the health status, and we got it is good, okay. And I'll list the users, right? So mostly admin 2, admin 3, ALB test 2, some users are there here, okay, right? So we can leave those users as is, or if you want we can delete all those, okay. So I'll say ALB test 2, okay. So I'll delete those, ALB test 3. So some users are there which I have deleted, so which I really don't need them. So now if I go and then list all users, so I should have admin 2, admin 3, and then ALB some basic, okay. So that's fine, 3 users are there. Now I'm going to create a user. So I'm going to say body, and one thing we need to be important is what is the, in SES, what is the thing you have identified as your second email address, to email address, right? So that one you need to cross check, okay. So let's go to simple email address and go to email addresses. So we designated stack simply this as our from email address, and then D Kalyan Reddy as my to email address. So now here the to email address is dkalyanreddy@gmail.com. So I am going to test micro test1. My username is micro test1, and first name is micro f name and micro l name, okay. So now I'm going to create the user. So earlier you have seen that you used to get notification related, service related 500 error. So now that should not be the case. So sent request, so I got the 200, right? So which means if you list the users, so micro related user should be created now. So micro test1 user got created. So now if I go to my Gmail and verify it, right? So I got the email now. You can see it. Hello, micro fname, your Stack Simplify account is created successfully, right? So which means just now I got it 0 minutes back. Hello, micro fname, your Stack Simplify account is created successfully. So which confirms us that, so whenever from here I have done a create user, so the user, okay, whatever is created using UMS pod has been stored in RDSDB. So that's what the list users tell us, right? So user is successfully stored in RDSDB. And then UMS next called the notification service, which went to the notification service pod. And then from there it called the simple email service and then sent the email to the end user. So that's the thing. If we want, we can even test one more user. Okay, so let's go here to our create user and we can even say micro test 2, right? And then I will say send, right? So see, user with email address already exists. So you cannot use the same email address for your multiple users. So that's the exception I have created in the course, in the respective code. So that's the reason one more email address with that is not accepting. So what you can do, so now if you want to add one more email address, so you need to go here and then first verify a new email address. So I'll say stack simplify dev2@gmail.com. Verify this email address. Okay, so I will go here and I'll go to stack simplify dev2 and I got the verification email, right? So this should be successful. Now I verified it. So I'll go back here and then refresh it. So one more email I have added, stack simplify dev2. So now I'll go here, which one? Postman, and my micro test, right? So if you see list all users, I have only micro test 1, right? Right, user not created. So test 2 with the email as stack simplify dev2, right? And save and then send. Okay, user got created. So let's see in the list users if user exists, right? So micro test 2 came here and let's go here and then verify the email. So you can see email, hello micro fname, your stack simplify account is created. That's all. Good, right? So this completes the microservices implementation here end to end in a Kubernetes cluster on AWS with the AWS related services. So you have used the EKS cluster, you have used Route 53, you have used certificate manager, you have used simple email service, RDS service, all this stuff, right? Application load balancer. So like this, and then NAT gateways for outbound communication, right? So whatever you are seeing simple external email service, the outbound, so this is going via NAT gateway. If you see here, so I just put it directly, but it goes via NAT gateway and then go to the simple email service in general. Why? Because from private subnet, it cannot go direct to simple email service, right? So it goes via NAT gateway and from NAT gateway, it goes to the simple email service. So that's about it. All in all, this is what is the entire microservices deployment on AWS EKS. So I'll see you in the next lecture. Until then, bye-bye. Thank you. So if you want to clean up, so then we can go ahead and then do the same stuff as usual. So kubectl delete -f kube manifest. Okay. So but what we are going to do in our next 4-5 steps is like before cleanup, we are going to perform additional stuff here, which is nothing but roll out new deployments with the 3 options we have, which is set image option, kubectl edit, and then update manifest. So how to roll out new releases to our applications? We are going to see all those 3 options and then do the cleanup. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to work on roll out new deployments for our notification service using 3 options available in Kubernetes. One is set image option, kubectl edit, and then update manifest and then deploy. So in any of the 3 ways, you can upgrade your application version from 1.0.0 to 2.0.0. So before going there, so we'll go to our notification service, and the current running version you can see is v1, right? So let me go here and then let's do this now, right? Let's go to step 14, roll out new deployment using set image option. So we can say kubectl set image for the deployment notification microservice. You can say that notification hyphen service is equal to, right? So notification hyphen service is nothing but your respective container name. So if you go to your Visual Studio Code here and then go to kube manifest and then go to notification microservice deployment, see, this is the name. So for the deployment notification microservice, this is the name, right? And for the container notification hyphen service container, the image it need to set is 2.0.0. So currently it is using 1.0.0. So I want to use 2.0.0 and then record this statement. Okay, so that's what it is saying. So let me copy this, okay, and then paste it here. And now automatically kubectl get pods, we should see that old notification microservice should be terminating and the new one should be creating. Okay, so now it got created. So 4 seconds. So let's if you want we can verify the logs, but we'll go here and then access it and then see notification service, right? So shift refreshed it. Okay, so you can see I have refreshed it and notification service v2 version is deployed just with kubectl set image option, right? So whatever we have done with set image for that deployment. So this is one rollout option we have, and default is rolling update. So obviously you have 10 replicas or 20 replicas, so it will be like default rolling update, so we'll not have any downtime. Okay, and if you want we can have the settings also there, how much should be taken in the rolling update model, 25%, 10 pods or 4 pods or whatever we want, we can configure. But putting that aside, so what now we are seeing the v2 version here. So now we can go back here. So you can see rollout status, you can see with this command. So but now already it's only one pod, it's already rolled out, so we'll not see anything here with this, right? Successfully rolled out, you can say, that's all. Okay, and you can see the new replica set will be created with kubectl get rs, right? So this is the new replica set with created for this respective new 2.0 rollout. Okay, and one important thing is this entire section related to rollouts we have seen in our foundation section, which is fundamental section, but now we are completely dealing with microservices. I want to add it as an extra option to see you one more time. But if you already gone through the fundamental section and then if you are aware of these commands, you can ignore this section. Okay, so if you want you can see the rollout history also here, because we said record is equal to true. So now the rollout history is for revision 2 is nothing but 2.0.0 version. Okay, and if you want to roll back to previous version, so you can say kubectl rollout undo that respective deployment. Okay, so if you do that, then it is going to go back to the older version. So now if you see kubectl get pods, right? So now the new one whatever it has created is terminated, and then it is going to again get the v1 version for us, notification v1 version for us. So if we access now the notification health status, so let me refresh this and we should get v1 now. Good. So now we have successfully upgraded to new version, means like went to the new version and then again roll back to the new version here. Okay, in step 15 again we are going to do the rollout new deployment using kubectl edit. Okay, so kubectl edit will using kubectl edit we can edit the deployment and then update the respective image path directly. So let me show you that. Okay, so we are doing the step 15 here. So I'll paste it, kubectl edit deployment and then notification microservice. So I can go here, I can go down and then go up from here. So from down if we catch it, it is easy, right? It's a pod definition. Okay, so now little up, where is it? Come down. So I need to search for 1.0.0. We got it here. Okay, so here is the thing. So image is stack simplify kube notification microservice to 1.0.0. So with edit we can change it to 2.0.0 and then save it. And if we see this kubectl get pods, so it should getting terminated and the new one is getting created. And you can even see with the rollout deployments or replica sets, or all these commands are common for us, right? So only thing is we can directly verify our application, right? So now it should be again v2. So let me come here and then refresh it. It is v2. That's the thing. So now what we will do is, like, if you want to again roll back, you can use rollout undo deployment. Okay, so I'll say undo and I'll verify get pods. It's terminating and the new one is getting created, and I'll go back here and it should be v1 now. Good, that's good. So we have rolled back. And one more way is, like, you can go back to your manifest here, right? So notification manifest and then change it to 2.0 and then say kubectl apply -cube manifest, and then this also should change us to version 2.0, right? So let's kubectl, and then if you say get pods, now it's terminating and then creating new one. And if we go here and if we refresh here, it should be v2. And again, if you want to roll back, again you change it to 1.0.0 and then say kubectl apply -f kube manifest, and then kubectl get pods, right? So it is terminating and then creating a new one. So let me refresh here and then it should be v1. So that's about the entire deployment strategies, means like rollout new deployment with the 3 options we have, which is the set image option or kubectl edit or update manifest and then deploy. So finally we can go ahead and then clean up our stuff. Okay, so let me see here, kubectl delete -f, right, and then kube manifest, and then whatever we have created so far all will get deleted. That's about it. So this completes our microservices deployment on AWS EKS with user management microservice and then notification microservice. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to look into AWS X-Ray as one of the tools for microservices distributed tracing. So we are going to deploy our applications on EKS, and then so for those microservices applications, we are going to enable distributed tracing using AWS X-Ray. So with that said, we are going to add one more AWS service to our entire deployments on EKS. So moving on, we will see on a very high level what is AWS X-Ray and then how we are going to deploy it, what is its network architecture, and during the process we are also going to look into daemon sets in Kubernetes. Why? Because we are going to deploy X-Ray related application on Kubernetes using daemon sets. So let's see all those things now. So what is X-Ray? So let's see how this is going to help us. So AWS X-Ray helps us analyze and debug distributed applications built using microservices architecture. With X-Ray, we can understand how our application and its underlying services are performing to identify and troubleshoot the root cause of performance issues and then errors. So X-Ray provides an end-to-end view of our requests as they travel through our application and shows a map of our application underlying components. So that is a very good feature, right? So if we enable the X-Ray, then we are going to get the end-to-end view of our application, including the components involved inside that. So we can also use X-Ray to analyze applications in development environments and also in production environments. So we can even do this for a simple 3-tier applications to complex microservices applications consisting of thousands of services. So everywhere we can leverage this X-ray feature. So now the benefits we are going to get is it provides us to review the request behavior came for our application. It also discovers us to allow us to discover the application issues, and it improves our application performances because we are going to discover the issues early in advance using the X-ray traces. So it is ready to use with AWS, any of the other services. Okay, so designed for a variety of applications. So now how X-ray is going to work. Okay, so this image I took it directly from AWS, so I have set it also as a copyright from Amazon. So if you see here, so whatever the X-ray traces will be collected by the X-ray service. So it will collect the traces and then record those traces and then group them. Means like trace is nothing but grouping our entire application request from starting to ending. If it is a 3-tier application, or if it is multiple microservice, one microservice calling other microservice. So it will collect the traces and combines the data generated from each service into a single unit called trace. So it will take and then create it as a trace, and then it will show it on our X-ray service map. In addition to that, there will be also a analyze issues feature, so that we can go inside each trace and then see the entire flow and then what is happening, and then understand in detail where the performance bottlenecks are there or where what issue happened exactly. So like that we can do all those stuff using X-ray. So moving on, so from X-ray perspective, we are going to deploy X-ray related object, means like X-ray related agent on Kubernetes using daemon sets. So due to that, we need to understand what are daemon sets. So in our next lecture, we are going to understand about daemon sets and also how we are going to use it in EKS cluster from network design perspective and all those things. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's see what are daemon sets in Kubernetes. So a daemon set ensures that all or some nodes run a copy of the daemon set pod in our EKS cluster. So as new nodes, means like as new worker nodes are added to the cluster, daemon sets pods are added to them. So which means pod which is configured as daemon set, those pods will be added per node with default configuration. And as we remove our nodes, means like in the auto-scaling mode, when we put our cluster autoscaler enabled for our cluster, so we keep adding nodes automatically and then we keep removing nodes automatically based on the workload we are getting, right? So whenever a new node is added, it is going to add a pod which is configured as daemon set is going to be added on that node, and also when the new node is removed, it is going to remove it. At the same time, deleting a daemon set will clean up all the pods created on all the nodes which is configured as daemon set. So here the pod in the sense a daemon set pod. So which is nothing but X-ray can be said as a, means like X-ray related agent, whatever we are going to install on EKS, we can call it as a daemon set pod, right? So that respective pod will get added when new nodes are added, new worker nodes, and then it will be removed when new worker nodes are removed, like that. And then when daemon set is deleted, all those X-ray pods will get deleted. So some typical uses of a daemon set are running a logs collection daemon on every node. Example, FluentD. Okay, so we are going to do this in our monitoring and then logging sections in the later part of the course. In the same way, running a node monitoring daemon on every node. So something like CloudWatch agent for container insights, which we are going to do as part of our later parts of our section, but that is one of the example. And running an application trace collection daemon on every node, which is nothing but AWS X-ray, and then that we are going to do it now as part of this section, right? So in a simple case, one daemon set covering all nodes would be used for each type of daemon, and most of the time we are going to use a simple case everywhere. Okay, so but there will be some complex cases where like multiple daemon sets for a single type of daemon, but with different flags or different memory and then CPU for different hardware types also we can use. But 99% of the cases we are going to use, means like most of the time we use simple case one daemon set covering all nodes would be used for each type of that respective daemon. In simple terms, it is like if you create a daemon set on every worker node, we are going to create that pod accordingly. So that's about the daemon sets on a very high level, right? So now let's see what we are going to do from X-ray perspective in a Kubernetes cluster. So you can consider Kubernetes cluster is a EKS cluster, and then you have two worker nodes, worker node 1 and then worker node 2. So you create a daemon set. What it does is that respective daemon set is going to create a pod in each worker node, which is nothing but, in our case, it is going to be X-ray pod. And then so when applications want to send the traces to this X-ray pod, right? So we need to expose that X-ray daemon set with any of the service to load balance the request. That's all, okay? So it is going to be X-ray cluster IP service, okay? So which means applications, now we'll deploy our UMS deployment application or anything, right? So any application, okay? So let's consider you have done the deployment of that application. So it created a replica set and then create equivalent pods, right? So now this you have exposed it with a load balancer to the external world. Now let's see the flow, what happens to the X-ray to the external AWS X-ray service. So as users, I try to access my user management microservice application, and inside this UMS pod, in each UMS pod, we have configured the X-ray SDK related configuration, which means these applications are enabled with X-ray related SDK features. So which means whatever the traffic coming to these applications, trace it and then send it to the X-ray pod. Those related application related development we have done in our user management microservice, okay? So now the request comes to this UMS pod, and then if it is a create user, it will create the user and then update it in our respective whatever the database, whatever is configured. I didn't depict the database here because our core focus should be here on our X-ray related stuff, okay? So now what happens? So now whatever it is done, whatever the application related job it has done, it will try to update the same thing to the X-ray pod, which means it is going to trace that information and then send it. So that request might come to any of the X-ray pod, and then these X-ray pod will have the information about that respective accounts, means like that respective AWS accounts, X-ray service, and then it is going to send that information to X-ray. Now, so this X-ray pod, so the UMS pod in worker node 2 can also send the traffic to worker node 1 X-ray pod. So why? Because it is a standard X-ray cluster IP service load balancer, okay? So it can send to any of the pods. So this is not the generic thing like UMS pods in worker node 1 will send to only X-ray pod in worker node 1, or UMS pod in worker node 2 will send to only worker node 2. It can send to any of the X-ray pods, and then they will send it to the X-ray traces, and then as we seen how X-ray works, it is going to collect all the results and then create a trace for it and also create the service map for it automatically. But one important thing here is you need to work on your development efforts here from your application perspective with AWS X-ray SDK in your application. Moving on, so microservices distributed tracing with AWS X-ray from a network design perspective, how it is going to look like. So in our next lecture, we are going to look into from network design perspective how it is going to look like, and also other X-ray service map and then traces how it is going to look like also. We'll see on a high level and then move on with the hands-on activities. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about how we are going to deploy our applications in relation with AWS X-ray on EKS cluster. So everything we are going to look into it from a network perspective, how it is going to look alike. So let's go there. And in AWS cloud, right? So when we create a EKS cluster, it is going to create equivalent VPC and then public subnets, okay? And then private subnets and then NAT gateway. But one thing important here you need to observe from our previous network diagrams is like I have depicted only one availability zone. So I didn't depict one more availability zone because of lack of space for the depiction on my presentation. Okay, so whatever you are seeing 1A, the same thing also will be there in another availability zone also. But here I depicted only one thing due to multiple components I need to cover in this depiction, and then which you want to see it, and the same thing will be available in another availability zone also. So now, so these things will get automatically created. So whenever you create a worker node group, means like whenever you created a EKS managed node group, so it also creates a worker node, and whatever the applications deployed on this worker node, and also this worker node related kubelet and all those stuff will communicate to the EKS cluster using NAT gateway. Why? Because these worker nodes are created in the private subnet. So moving on, whenever you deploy a X-ray as a daemon set, so it is going to create its X-ray pods per worker node, one X-ray pod, and then it is going to expose that respective X-ray pod related application using X-ray cluster IP service. So the next thing is we deploy our UMS deployment, means like user management application and then notification application. So it will have its own stuff, right? UMS will have its own node port service and then MySQL external name service. So notification service will have its notification cluster IP service and its SMTP external name service to send the emails via simple email service, and its own deployments, UMS deployment and then notification service deployment. Okay, so the next thing is, so you will also create your ingress service, which is nothing but your application load balancer in the public subnet, and then whenever you create the ingress service, it will reference the SSL certificate from the certificate manager, and also you are going to register your DNS name with inside the Route 53, right? So using external DNS. So that's about the ingress service. Now when users want to access, right, so the application, so for X-ray I have provided a dedicated microservice. So all other microservices whatever you have seen like create user, delete user or health status, those are different. And then for X-ray related thing, so in this UMS and then in notification I have written the code with X-ray SDK to enable the X-ray tracing for only this respective microservice, which means you are calling a notification X-ray microservice from user management microservice. So what happens at that time? So you can see here ums.kubeoncloud.com/user mgmt/notification X-ray. So the request comes to the UMS ingress service, and then it will go to the UMS node port service, and then request will go to UMS pod, and then from there it will go to the notification cluster IP service, because you are calling the notification X-ray service here. Okay, so and then from there request will come back to the notification pod and then serve the response whatever I have requested, right? So that's what happens on a entire flow basis whenever you access this respective URL. So what next, right? So whenever it came to UMS pod, it will analyze the traffic and then it will send the details to the X-ray cluster IP service, from which it will go to the X-ray pod. Okay, in the same way whenever the request came to notification service microservice pod, so from here, so to access this notification X-ray service, it is going to send the traces to X-ray cluster IP service, from which it will send to X-ray pod. So this X-ray pod will take the responsibility to connect to our X-ray service via NAT gateway. Why? Because everything is in private subnet, it will go via NAT gateway to our AWS X-ray. So now till here everything is good. So when you access other stuff, which is nothing but you worked on create user stuff. Okay, so user management, create user, it will come to MySQL and then it will store the data in RDS database, and then it will go to the notification service. From notification service it will go to SMTP. Via NAT gateway it will go to simple email service, and then send the email to the end user. But for this create user flow, whatever is there, we really didn't enable the X-ray stuff. Okay, so means like X-ray stuff in the sense X-ray stuff for contacting the services, in the sense like from this service to this service, how it is contacting. So there will be a different way to call one service calling another service in our code to show them as one service calling another service. So even if you call the create user service, it will be depicted in our X-ray, but when it is calling notification service, it will consider as a different client, in the sense like it's a different node in the X-ray. That's the reason whenever you are testing, try to test it with notification X-ray, so that you will get the complete picture how it is going to look like. So the reason is there will be a different ways to call our services from one service to another service. So in microservices, this is specifically a 1-minute introduction I am going to give what I have done here. So when you are calling a notification health status from our user management microservice, I am using REST template, which is the Spring Boot standard way of calling the REST services, one service to another service in microservices. Okay, but whenever I am calling the notification X-ray, it needs something called HTTP client builder, which is means like I am trying to use the X-ray related thing here. Okay, so which is nothing but X-ray related HTTP client builder. So that's the reason whenever I call the X-ray in this model with client builder, then only it is going to show that one service calling another service. So whenever I do with REST template, what happens is whenever you call your notification health status from user management, it is going to show in a different way in the X-ray. We are going to see that in detail in our when we are doing the implementation, but I am trying to explain it that and then nail down for you that whenever you access this respective service, then it is going to show you the how I am seeing the nodes in the same way you are going to see it. So like this. Okay, so how I see it, user management microservice calling the notification microservice, how I am seeing. When you test also, it is going to look this way only when you call that respective notification X-ray service. Other services whatever we have done earlier is not going to be same way. Now what is service map? You can see that as a client. So whenever I access it as a client, right, so it went to UMS node port service, from there it went to notification service and then send the traces to X-ray, right? The whole thing happened. So here also it's the same thing, right? So as a client, as a user, I came and then I called the user management microservice, and then from there it went into the notification microservice and then served my notification X-ray thing. Okay, so now you can see that we have also labeled it with user management microservice and then V1 notification microservice, everything, and then we are seeing all this in our X-ray service map. Next thing is traces, right? So whenever you want to trace this respective thing, so what happened and then for this respective call what happened I want to see. So you can see it in detail, right? So whenever I called that notification X-ray, it came to user management microservice and then it went to V1 notification microservice. So what happened in user management microservice, you can see it here. It went to a method get notification app info. That is the method. So let's cross check that. Okay, so you can see get notification app info. It went here in the code. Okay, and from here it is the thing, right? So from it you called like this, get services Kubernetes cloud / user management notification X-ray. It went to this respective method and then from there it is calling remote get 8096 / notification / X-ray. So that is the thing it is going to call. So which means it is trying to call this URL notification.service.xray URL. So which will be present in our here. So notification / X-ray in our application properties. So it called this link and then from when it is calling this link, this get notification app info forwarded the request to our notification cluster IP service, right? So that's what is present in our architecture also, notification cluster IP service. From user management microservice you will go to notification cluster IP service. So from here again where you went into the notification microservice, which is the microservice respective pod or container, right? So inside that you have something called notification app version service method. So from that you served the content. So what happened end to end you will be able to see here in a detailed trace information. So now next level, which means like again if you click on this user management microservice or this notification microservice, so this is nothing but a container, right? So this respective container, right? So EKS container. So you are going to see the segments in detail. So what is that segments is like? So from start time, end time, duration, and then the request URL is this one, and the request method is get, and user agent to generate this request means like who is the user agent is I used the Postman, so it is showing Postman, and the request client IP it is showing. All this information you will see in the overview tag of our segment section. Okay, so how we get the segment section is whenever we click on this, double click on this, we get this entire section. So in addition to that, as this is a EKS thing, right? So I enable the EKS plugin in my code. So if you see here in my code, if I go to X-ray and then X-ray config, so if you see here, I enabled the EKS plugin also with my code. So due to that, what it will do is like, where is this? Yeah. So it will provide that EC2. I also enable the EC2 plugin. So it will show on which instance ID and those information it will provide, and X-ray information it will provide. But you can see the most important thing in the resources section is EKS section. Okay. So in EKS section, you can find inside pod information to which pod this request went in. So exactly that pod name it is provided, and inside that pod which container this request went in. So that information also it has provided. So this completes the introduction for our X-ray end-to-end. Okay. So in our next lectures, we are going to go ahead and then implement the X-ray with our microservices. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to work on the microservices distributed tracing prerequisites section. Okay, so we are going into 13 microservices distributed tracing using AWS X-ray on EKS. Okay, so from introductory part, we remember that we discussed about understanding about AWS X-ray services, understanding about Kubernetes daemon sets, and then X-ray and microservices network design we have looked into, and also we have looked into samples of service map traces and then segments in AWS X-ray. So the use case we are going to implement here, which we also discussed in the segments section, that we are going to call a get notification app info from user management service, which will call the notification service notification X-ray. So which is nothing but we are going to call a URL and then like this user management notification X-ray, which will call the notification app info service. So which will also send the traces to our X-ray service. So we are also going to depict one microservice calling other microservice in our X-ray service map. We have also seen that in our service map section. So the list of Docker images we are going to use are with stack simplify /cube user management microservice and then notification microservice, which are highlighted with 3.0.0 AWS X-ray MySQL DB and then 3.0.0 AWS X-ray for notification microservice. So with that said, MySQL DB is mandatory when you use this service, right? So now the prerequisite section includes few things here. One is your RDS database should be up and running. So if it is down, so we have created this as part of our 06 section, right? So if it is not up and running, just go ahead and then start that RDS service. Okay, and whatever the database you are continuing from beginning, so that database, if it is stopped for any reason, just go ahead and then start that. And the second thing is ALB ingress controller and then external DNS. So if we have seen architecture diagram, we are trying to depict everything whatever is possible for us in AWS perspective. So we have, as part of this service, we are going to introduce X-ray, but we have simple email service, we have Route 53, we have certificate manager. In the EKS cluster, we have the RDS DB. All these stuff are part of this entire architecture. So with that said, so application load balancer is also one section. Okay, so for that purpose, application load balancer and then external DNS also you should be up and running, and then those should be installed on your respective EKS cluster. So every section we are adding this prerequisite step because so our specific templates will ensure that it will create a application ingress service only, means like application load balancer related ingress service only it is going to create. So we need to ensure that our ALB ingress controller is running, and also our respective pods related to external DNS is running, because we are going to DNS register and then test it. So external DNS is also running for me in my cluster. Okay, so with that said, so we have verified our ALB ingress controller, and also we have verified our external DNS. So in our next step, we'll focus on core X-ray daemon, how we need to run on our AWS EKS cluster. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this step, we are going to create IAM permissions required for our AWS X-ray daemon to run on EKS cluster, and then send the X-ray traces from AWS EKS cluster X-ray daemon to the AWS X-ray service. So for that purpose, you need to create a service account in Kubernetes. In addition to that, IAM role and then IAM policy, which will have the AWS X-ray daemon write access. So all these things, Kubernetes service account, and then AWS IAM role, and then IAM policy already there, which we are going to leverage it. So role and service account we are going to create with a single command using EKS-CTL create IAM service account. So let's go ahead and then create that now. So the name of the service account in Kubernetes is going to be X-ray daemon, and it is going to get created in the default namespace, and inside the cluster EKS demo 1, and the IAM AWS IAM policy it is going to attach for the role it is going to create is AWS X-ray daemon write access. Okay, so let's go ahead and then create the same thing now. So as soon as we create this, it is also going to create a CloudFormation template for us with the IAM role associated with it. So let's go ahead and then see that once it creates, it should be creating the CloudFormation account. So we'll also verify the same thing now. So it's deploying this respective stack, which is nothing but deploying stack means deploying CloudFormation stack. So let me go back to AWS Management Console and go to CloudFormation. And if you see here, we already have a EKS cluster related CloudFormation template and ALB ingress controller related IAM role, and then external DNS related IAM role, and also now this is related to this cluster is related to our node group with 2 nodes whatever we are running in private subnets, and now this is the one default X-ray daemon which is creating now. So like this it creates, and then once it creates we can go and then verify our stuff. So it got created, and if you go to resources section you can find the IAM account it has created, means like IAM role it has created. So I can click on this role, and then it should have the AWS X-ray daemon write access policy. Okay, AWS X-ray daemon write access policy. So this is the role it has created as part of this section. So in our next step we are going to verify what all it created. Okay, so let's go back to our terminal and I'll say clear, and kubectl get SA will give the service accounts in my Kubernetes cluster. Okay, so I should have X-ray daemon now. So it created exactly 70 seconds before, and then if you want you can even review, right, the X-ray daemon kubectl describe service account X-ray daemon, and it should have the role annotated here, whatever is the role ARN present here. So this role whatever is there, right, VR2 and ends with mmdb. So the same thing, mmdb, the same thing should be annotated on our service account. So this is gluing or connecting between our service account in EKS cluster and then IAM role inside AWS IAM, right? So now the next thing is verify the service accounts present in our EKS demo cluster. So using EKS-CTL get IAM service accounts in EKS demo 1 cluster. So this command will give all the service accounts which were created using EKS-CTL inside this cluster. So we have external DNS, X-ray daemon, and then ALB ingress controller. So 3 service accounts and then its equivalent IAM roles we have created using EKS-CTL, right? So now we are going to deploy the X-ray K8s daemonset.yaml. So before deploying it, we'll go ahead and then verify what is that YAML file. Okay, so if you go inside 13 distributed tracing using AWS X-ray, and then in kube manifest you will have 2 folders. Okay, so one is 01 X-ray daemon set and another one is 02 applications. Okay, so in 01 X-ray daemon set you will have the X-ray K8s daemonset.yaml. So inside that one will be with the service account information. So inside that service account information, right, which is X-ray daemon service account. So let's update the role whatever we have created just now. Okay, so this is the role ARN. You can copy it from here, or for this command output also it provides the same X-ray daemon ARN only. Okay, so I can take this one, right? Even this one I can copy and then paste it for my service account information. Okay, so I'll make it like this. So I have copied MMDB, the entire update the IAM role created for X-ray access. So this IAM role ARN I have updated here in my file. And the next thing is daemon set. So for daemon set also it will be similar like whatever we have seen related to deployment only. So only thing is kind is deployment, and update strategy it is going to use means like to update the nodes it is going to do in a rolling update fashion. And it also has the standard selector template, which is nothing but match labels with app X-ray daemon. So same as deployment template only, you can see only the kind is daemon set. Okay, and it also has the pod template with metadata labels app X-ray daemon, same is present in selector labels. Okay, so that's about it. And in pod spec the service account it is going to use is X-ray daemon, and it has some volume information X-ray config, and then container information it is going to use, and its resources, and then its ports X-ray ingest ports both UDP and TCP with 2000, and it is going to do a volume mount /AWS/X-ray. Okay, so that's about it. And another important thing here is config map, whatever it is going to do is nothing but TCP and UDP addresses listening on 0000 of 2000 with all IPs on 2000 on those nodes. And in addition to that, the service means like we already discussed about the whatever the pod it is going to create, it need to be exposed. X-ray pod it need to be exposed using a cluster IP service. So X-ray related cluster IP service with ports both X-ray ingest and then X-ray TCP with 2000 port TCP and UDP getting exposed here. So this is the X-ray daemon. So now let's go back here, and then we updated the information whatever is required here. The role ARN with MMDB is the last thing, right? So it should be MMDB. So let's cross verify MMDB. That's good. So now we'll go back here, and then so update also completed. Next is deploy this daemon set. So we are going to say kubectl apply -f kube manifest, and then inside 01 X-ray daemon set this file is there. So we are going to use the complete path to do the deployment. Okay, so I'll say clear and I will paste it, right? So once it is deployed, so we need to go inside our 13th section, which is microservices distributed tracing, right? And inside that we are going to deploy it. So I am inside the folder 13 microservices distributed tracing using AWS X-ray on EKS. There I am doing the X-ray daemon set deployment. So it should create the service account and then daemon set, config map, and then its equivalent service. So now we are going to verify everything. Okay, so kubectl get deployment svc service and then pod, all the 3 things. Okay, so now deployment got created and 1-of-1 deployment is ready, and then service got created, which is X-ray service with both ports, which is a cluster IP service, and it also created X-ray daemon in 2 nodes. Okay, so we can even say kubectl get pods -o wide. Okay, so it should be creating two pods in 2 nodes. Okay, so if you see 120 is 1 node and then 86 is 1 node. So per node it has created 1 X-ray daemon related pod using daemon set concept in Kubernetes. So that's good. So now the next thing is, so if you want, we can get the daemon set information here. kubectl get daemon set and kubectl describe daemon set, and the name is xray -daemon. So to view what is present in this daemon set, it has the image is xray daemon, and then image is Amazon AWS xray daemon, its ports, and then host ports, everything information related to that is present here. Okay, so it has created 2 pods, and then those information also available here. So now the next thing is review the deployment manifests and then application related stuff. So in our next lecture, we are going to focus on application stuff. So in this lecture, we have successfully completed creating the daemon set and then its equivalent IAM roles and then service roles. And in next lecture, we'll focus on application related stuff. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to review the microservices application deployment manifests and also the ingress manifests. Okay, so let's move on with step 5, review microservices application deployment manifests. So we have user management microservice deployment and then notification microservice deployment. So in our previous microservices deployment section, entire section, we have already created these things and then deployed it and then tested it. So what changes we are going to make for these things, that is what we are primarily going to look into, right? So in user management microservices deployment file, for the image tag, we are going to use 3.0.0 AWS xray MySQL D. So the tag very clearly states that 3.0.0 and then which is enabled with AWS xray, and it connects to the MySQL DB, which means we need MySQL DB. So why we specifically mentioned MySQL DB is, if you go inside the things here, right, Kube user management microservice, so you'll also have something called H2DB, which is in-memory DB. So you can directly deploy these H2DB containers wherein you don't have any MySQL DB related dependencies. So directly you can deploy them. So you really don't need RDS database or MySQL containers or anything. So internal in-memory DB will be available for us. But as per our architecture, right, so we are trying to depict everything and then leverage every AWS service. So that's the reason I have ensured that we are using MySQL DB tag here. Okay, so if you use H2DB tag, then automatically no MySQL related stuff is not needed, but rest all xray is going to work here as is. Okay, so no changes to xray how it is going to work. Only thing is, when you create a user, the user will be stored in H2DB, and then whenever you restart your container or that user will not be there, because that is only a persistent DB. And if you deploy 4 or 5 containers or 4 or 5 parts of that, then you will have different data in different in-memory DB respective to that respective pod. So it's only for testing purposes we use this type of stuff, this one and then this one. So these are not real-time stuff. Okay, so but for convenience purpose, I have compiled and then put it there. Okay, but always we try to use MySQL DB in real-time cases, and then we'll use the same thing. So that's about the tag we need to discuss about. And next is the change 2 is environmental variables related to AWS xray, right? So these are very important ones. So let's discuss one by one. Okay, so AWS xray tracing name, right? So if you go to our picture here, right, so inside service map, you can see here user management microservice. So this is the name of our microservice. So whatever you have provided here, it will be displayed here. Okay, so whatever we provide here, you can see here v1 notification microservice. So the same thing is getting displayed here. So your application name, whatever you want to provide, so that one you need to provide, means like in your application code you might have written something else. Okay, so in my application code also I have written something here, so I can show you, right? So if I open it here, so I have said user management microservice just simply like this. Okay, but if you want to override this value, if you want to override this value with this value, so you can use this send the environmental variable. I always prefer to do everything via, means like this type of things if available, I try to use via Kubernetes deployment manifest so that I can alter in future also, right? So that's the reason I used this variable name and then provided my name whatever is required for me here, okay? And next thing is AWS X-ray daemon address. So which means whenever the daemon is running, so it need to know, right? Our respective application container need to know to which X-ray daemon address it need to send the traces, right? So X-ray service dot default and then 2000. What does this mean, right? So if you see here in our templates, right? X-ray service. So you go here and you only created this service, okay? X-ray service in X-ray K daemon set. In previous lecture we created this service, okay, in namespace default. So X-ray service dot default will be my name of my daemon address, and the port I am going to use is 2000 port. Why? Because I exposed it as 2000. We can even see that here, kubectl get svc will provide the X-ray service with port is 2000, okay? So that's good. So that's about the daemon address, right? And next is X-ray context missing, okay? So if you use the value log error, it will log an error and then continue. It will not disturb our application, okay? But if you don't define this and then leave it like that, so the default is to use the runtime error. So when it uses runtime error, it throws a runtime exception, which is default option if not configured. So it's not good, right? So for me, for now, it need to log error and then continue. If X-ray is not working, what matters for me? My application should continue to keep running, right? So that's the purpose I defined this way. AWS X-ray context missing, log error and then continue. The same three environmental variables also will be present for our notification microservice also. In addition to that, there will be something called for notification microservice also. You will have 3.0.0 AWS X-ray tag. So you can find it here. Let me go to repositories, right? And you will have the notification microservice here, and you can see it here, 3.0.0 AWS X-ray, right? And here you will also have 4.0.0 AWS X-ray. So which will state that 3.0.0 is V1 version of your application, and then 4.0.0 for X-ray is V2 version of application. So whenever we are doing the canary deployments in our next sections, so we are also going to use 4.0 X-ray and then distribute the traffic between 3.0 and then 4.0, and both will be live for us when we are accessing via browser, right? So we are going to see those things also later. So that's the reason everything is compiled and then put it ready for us, okay? So now image tag we have verified in notification microservice also. Let's also view them from our Visual Studio Code perspective, right? So in Kube manifest you have 0 applications, and you can see 0 user management microservice deployment, okay? So there only we added these additional environmental variables, okay? And same for our deployment also, okay? And remaining things, MySQL external name service as is, it is same, okay? And node port service for user management, same, we didn't touch it, okay? And notification microservice SMTP service, we didn't touch it as is, okay? From previous section, which is microservices deployment on EKS. And notification cluster IP service also, it is going to be as is, we didn't touch anything, okay? Now we'll move on to ALB ingress and then discuss about the ALB ingress manifest, okay? So one thing important from your perspective is, whenever you are using this template, you need to update your certificate ARN, right? So if you have already updated it in your respective ALB application load balancer section and then trying to copy paste your template continuously for every section, then there is no issue, okay? If not, always ensure that you update your certificate ARN here, and then your external DNS names, okay? You might have your own domain name, right? Mine is cubeoncloud.com. So yours might be something else. So that one you need to update here for Route 53 section. So these are the reviews we need to understand about our respective deployment manifests and then ingress manifests. Rest all are going to be same. So in our next lecture, we are going to deploy and then test it. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. in this lecture, we are going to go ahead and then deploy the manifests and then test it. So before going there, we are going to quickly look into, I have changed the DNS names for us to be services-xray.kubeoncloud.com and then xraydemo.kubeoncloud.com. And I have also updated the same in our architecture diagrams and also in our respective ingress manifest also. Okay, so why I changed it is because there might be DNS cache issues once we execute our once we execute this section, the previous section related to microservice 12, and then immediately we execute 13. So there might be issues related to DNS caching and all those things we might encounter. And example I can show you here. Okay, so there is no services.kubeoncloud.com in my record sets here. Okay, so but if you see the DNS resolution here, it keeps resolving to the older IPs. So like this, there might be some issues you might encounter and then face other issues, and then your demo might not work for a while, and then later after 1 hour or 2 hours it might work, but wasting our time like that is not good. So that's the reason what I have done is like I have ensured that we have new domain names for this X-ray demo also. So like that only we continued in our previous sections also. We are going to continue the same thing here. So now let's go back and then deploy the stuff. So kubectl apply -f and then kube manifest, and our content is present in 02 applications folder. So till there we are going to go ahead and then execute the stuff. Okay, so I will say copy paste. I am in 13 microservices section and I am deploying the manifest. So it is creating the user management microservice, all the microservices. So kubectl get pod should list the pods, and I'll also verify the ingress. Okay, so that ingress also got created. So now if we go back to our Route 53, ideally our Route 53 domain should be created now. It should be getting created. It will take a while to create. So what we'll do is like we'll pause the video until entire whatever the EC2 related load balancer also got provisioned. So it should be in provisioning state. Once this is completed, then we will resume and then test all other stuff. Our load balancer is active now. So let's copy the DNS. Let's do the DNS checks first. So ns lookup and paste it, and it has 213 and then 156 at the end. So I'll also say ns lookup xraydemo.kubeoncloud.com. so 213 and then 156. This looks good. So we'll be able to access our service and then test it, right? So now the next thing is, let's go back here, and then you can access the service on our browser and then test it. So I can even take this directly and then access it on the browser. So if you see it here, application is notification microservice, app version is v1, and then message is enabled AWS X-ray. So we can even test this via Postman by adding the environment. So I'll add the environment and then say X-ray microservices, and I'll add the URL, and URL is going to be this much, right? Add it, and I'll change to X-ray microservices, and this is the notification X-ray service. So I'm going to access it, and notification microservice and then v1 and then enabled AWS X-ray for this respective service. We are getting that. So I'm going to access couple of times here and then go ahead and then go to the X-ray and then see the stuff. Okay, so you can even verify your Route 53 domains already created, right? So I need to browser refresh to get these details usually. Okay, so we got everything related to services xray.kubeoncloud.com or xraydemo.kubeoncloud.com. So now let's go back to our X-ray service, right? So X-ray, let me close this, and now the service map is creating for our last 5 minutes. So let it get created. So now you can see here the service map. From client it went to user management microservice, and from user management microservice it went to notification microservice. Okay, so in service map we can see that very clearly. So now if we want to get the traces of this information, so we can go and then click on traces, and we can select the specific trace. So these are health check related URLs which is triggering from load balancer or from our node port service, whatever we have created, right? So those things. But this is specifically whatever we have accessed from browser, right? X-ray demo.kubernetes.com/user mgmt/notification X-ray. So let's go inside that, and you can say inside that you can find these are the traces. These many times I have accessed as of now. Okay, so if I want, I can keep sending the requests, and then these traces keeps getting increased. Okay, so I'm going to access 5 more times I have accessed. So currently 5 is there. So when I refresh it, so now you should see 1 2 3 4 5 6 7 8 9 10. So we have got 10 traces. Okay, so any trace you can open it like this, right? And if you see it here, its map will be displayed here in detail. So response is 200 and duration is 677 milliseconds. Age is like 2.9 minutes before I have accessed this. Okay, and let me make this bigger. So it is the same thing, right? So user management microservice and then V1 notification microservice. So where are these hosted? So that you can see here, AWS EKS container. You can see in the down right, EKS container. And as usual, if you see and then go inside traces, how the request went in. So the request first hit the user management microservice container, right? So its information is here. This is the start time, end time, how much it took, and the request URL is this one, and request user is from macOS browser. I have tried once. That is the first request, right? And the client IP is this one. Okay, so if we go back and then take another trace, right? So like recent traces. So what will happen with the recent traces is, so let's make it bigger here. Yeah, and if you go down, and then if you open the user management microservice, if you see the request user agent now is Postman runtime. So because we accessed it via Postman, and then X forwarder for true, and then response status 200. So this is the overview section, but you will have the resources section, which will provide the log group in which our logs are present. And in addition to that, availability zone where this request is running, and then instance ID is our worker node ID, and then our worker node size, and the AMI ID for our worker node, Kubernetes worker node, and SDK version it has used, and SDK it used is X-ray for Java, right? And now this is the important fact. Okay, so which in Kubernetes to which pod it went, and inside that pod to which container it went also we can identify using X-ray tracing, which is nothing but it went to user management microservice pod, so and so pod. Okay, so if you want KMG6G, okay, so if you want, we can say kubectl get pods and then match our pod name here, right? So see KMG6G, that is the one, and inside that this is the container ID, it went where the request went in. So that's about the user management microservices tracing. Here it took 24 milliseconds, and from there it went to the get notification app info, right? So that is my method present in my user management microservice. So inside that method it went in, and then from there it called the notification cluster IP service, correct, right? So if you take the architecture after UMS pod, from this it comes, then it will call the notification cluster IP service. So it called the notification cluster IP service, and notification cluster IP service is notification cluster IP :8096/notification/X-ray. So that is the path it has called, and now from there it is going to go to the notification service. The next thing is from there it went to here, it took 8 milliseconds near this service, and then it went to notification microservice, okay, which is nothing but the notification microservice deployment. Inside that the respective container and then pod, right? So if you go here, notification microservice pod and its equivalent container. So that's good. So now from there it went into the again the method. Inside that container there will be a code running, right? What is that method? Okay, so this is the method, notification app version service method. It went in and then it served the request back. So to this level, we can see the detailed tracing what happened for our application. And if you see here, this is whatever you are seeing in the model, you can see in the JSON format data, raw data also, you can see it. So this is about the entire tracing whatever we have done, means like the request came from client to user management to notification service. As I told earlier, only for specific service inside user controller, I have enabled this stuff, which means whenever you call only this respective notification microservice related X-ray service, then only this from user management to notification will go, and then it will be displayed here. So it's equivalent module I have used here to develop this code. But rest of the other stuff, which is like nothing but if I call other notification health status services, example, you have something here, right? Notification service info and then notification health status. So for them, the new node is going to get created and then it will show as client only, client to that notification services. I am going to show it to you now. So let's go back and then access them now. So there are additional code changes required for every service to do, and then get this one microservice calling another microservice, how you want to do. All these things are development related efforts when we are doing it. Okay, but I just want to show you a few things here. Okay, so I'm calling notification health status service, right? And I'll call for some time, right? And I'll also call service info service. Okay, all we are calling by user management only. Okay, so what happens, we are going to see. Let's go here and then refresh it, right? So now the map updates in a different way. So let the map see. Now you can see. So client to notification, right? So this client here is nothing but whenever you are calling, it is user management microservice. Also call this and then you will get some additional data here. Okay, so another picture you will get. Okay, so I'll say our last 15 minutes, I'll say, and then refresh. So you will get a different picture here. So whatever you are calling this notification microservice, it is going via user management microservice, but still that user management microservice system is feeling that it is going to be a client only. The reason for that is I didn't enable the HTTP client builder for this notification health service. I am using standard Spring Boot related REST template for calling another microservice. So this is core development related, but why I am trying to explain this here is when you are enabling X-ray in your applications, there will be a good amount of development effort required for you, and then lot of thought process thinking is required here. So if you see here, there will be lots of references which tells us in which section what we need to do and all these things. Okay, so these are related to X-ray enablement on Kubernetes. But if you see here, right, so SDK Java configuration and SDK Java configuration plugins and HTTP clients and filters and then SQL clients. So like this, there will be multiple other stuffs in X-ray SDK for Java or X-ray SDK for Node.js and then other Python or whatever, right? So good amount of development level of work is required in your application to enable this. But when you enable it, these are the benefits you are going to get hand in hand. Means like you are able to see everything in a detailed way, step by step. So that's about the X-ray so far. So in our next lecture, we are going to clean up the stuff. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to delete the applications created as part of this section, which is nothing but 02 applications, whatever we have done. So we are going to remove it. So rest all we are going to leave as is. Rest all in the sense whatever is X-ray daemon running on these two nodes. So we are going to leave it as is. So why we are doing that? So there is a reason for that. Okay. So we are going to leave the X-ray daemon set running, which we will leverage in our next section related to canary deployments in Kubernetes on EKS. So whenever we do the canary deployment, so from user management service, it can distribute the traffic to V1 notification service 50% and for V2 notification service 50%. And when it is doing that, we need to see that in X-ray for our additional understanding. So for considering all those things, I want X-ray to be enabled. So that's the reason we are not deleting the X-ray related functionality, which is nothing but X-ray daemon related functionality, which we have created in 01 section here. We are not removing that. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about what are microservices canary deployments, and in this entire section we are also going to do the canary deployment of our applications in EKS cluster. So let's start with what are canary deployments. Canaries means incremental rollouts in a simple form. So with canaries, the new version of the application is slowly deployed to the Kubernetes while getting a very small amount of live traffic. So in our case, we have the user management microservice, which is also calling the notification microservice for its use. So now, we are also going to introduce one more version of notification microservice, which is V2, and then also diverting some amount of traffic to that. So in short, a subset of live users are connecting to the new version while the rest are still using the previous version. So if you see here, 75% of traffic coming to notification microservice V1 version and 25% going to notification microservice V2 version. So having both versions available in production and then available for the user subset of users is called canary deployments. So once we feel that notification V2 is well and good, and then it is performing well, and then if we want to cut over entire traffic, so we can move the 100% of traffic to V2 version. So using canaries, we can detect deployment issues very early while they affect only a small subset of users. If we encounter any issues with the canary version of our deployment, so in production environments, we can quickly switch back to our original production version immediately, right? So all these options are available with canary deployments. So once we perform our canary deployment, and then if we go back to our X-ray and then see it, so it is going to look like this. So from client as a user, when you access, the request goes to user management microservice, and then it will go, few traffic will go to V1 notification microservice, and then few traffic will go to V2 notification microservice. So let's see that in GitHub repository what we have planned for this entire section. So we are in AWS EKS Kubernetes Masterclass, and we are entering our 14 microservices canary deployment section, right? So we already discussed about the use case, right? So we are going to, from user management microservice, we are going to call both versions of notification microservice is the use case, and we can distribute our traffic to V1 and V2 based on the number of replicas we configure on our respective deployment file. So notification service V1 will have one deployment, and then NS V2 will have one more deployment. So example, if you configure 4 replicas in NS V1 deployment file, which is nothing but let me open the Visual Studio Code. So in Visual Studio Code, you see that we have something called notification deployment and then V2 notification deployment. So this is notification deployment V1 notification microservice, and this is V2 notification microservice. In notification deployment, if you say replicas 2 here and then for V2 also 2, then which is nothing but you are distributing the traffic 50% to NS V2 version and then 50% to NS V1 version. So like this, by altering the number of replicas between 2 deployments, you can have the canary successfully implemented with out of the box in microservices. So on Kubernetes. So out of the box with whatever the availability we have with basic deployments, we can do it without using any external services currently like we didn't deploy them on our Kubernetes cluster like Istio or AWS App Mesh or whatever it is. Okay. So in our demo, so we are going to do it with 50% traffic to NSV2 and then 50% traffic to NSV1. So the list of Docker images we are going to use here is user management microservice, the same one which is 3.0.0 AWS X-ray with MySQL DB, and we are going to use notification microservice v1, and this should be v2. I should update this. v1 is going to be 3.0.0 AWS X-ray, and v2 is going to be 4.0.0 AWS X-ray. So this completes the introduction part of our microservices canary deployments. And our next lecture will focus on the prerequisites for this respective section implementation. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In step 2, we are going to look into prerequisites required for our this section implementation. So as usual, we need to have the AWS RDS database up and running. So because we are using the MySQL external name service, and then we are referencing the same thing in our user management deployment service. Okay. So next thing is we also need to ensure that we have our ALB ingress controller and then external DNS pods up and running, because we are going to use the ALB ingress related manifest here, and also leverage the external DNS for registering the canarydemo.kubencloud.com in Route 53. And in addition to that, we also need to ensure that X-ray daemon is up and running. So for the fact that we are going to leverage all the X-ray related pods here. Okay. So which means X-ray related daemon set is deployed and then it should be up and running. Those things we need to ensure those are running. So let's cross check our ingress is up and running. So in every section, this is a common prerequisite step, but if it is not mentioned and by any chance we have issues, so then this prerequisite step is the core thing that these need to be required for those templates whatever built. Okay. So ALB ingress controller, it should be up and running, and in default namespace we should have external DNS and then X-ray daemon. So both should be up and running. So external DNS is up and running, and then X-ray daemons are up and running. Good. So this confirms that our prerequisites are good, and if you want, you can go back to your RDS database and then cross check. And for RDS, you have an option to also use alternate, which is nothing but instead of using RDS database, if you want to use in-memory database, just change this to 4.0.0 AWS X-ray H2DB. So the same is also shown in our hub.docker.com earlier also. So the same thing you can use for RDS database if you want to use that. Okay. So but always try to ensure that we are using MySQL type of stuff, so that means like when we are learning or when we are planning to learn also, we are leaning towards more real-time examples instead of some in-memory stuff. But for backup also, I have provided this image for you, and it is also going to work with all these use cases without any issues. Only thing is data is not going to persist if we try to create user and then list users, all those things. That's about it. So in our next lecture, we'll focus on reviewing the manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to review the deployment manifest and also the ingress manifest required for our application deployment. So in step 3, we are going to review the deployment manifest for V2 notification service. So we are going to distribute 50% traffic to each of the V1 and V2 version of application. So NSV1 replicas are 2 and then NSV2 replicas are 2. We have put it there. Even 1 if you put also, it is going to be 50% traffic. So if you see here, this is the notification microservice deployment 04. This is V1 notification and we have 2 replicas. And 08 V2 notification, we have 2 replicas. Okay. And the next thing is verify, means like the change one is in the 08 V2 notification microservice, your image tag should be 4.0.0 AWS X-ray. So verify the same thing. It is the same. And if you go for V1, it should be 3.0.0 AWS X-ray. So that looks good. And next is change to new environmental variables will be added here. So these things are going to be same, which is X-ray context missing and then X-ray daemon address. But X-ray tracing name, we are going to give it as V2 notification microservice, so that you get the name here, V2 notification microservice in from X-ray picture visual service map view. Okay. So that's about notification microservice related review of that respective manifest. And rest all manifests are same. MySQL user management from previous sections, it is coming as is, so we really don't need to worry about them. So next we will move on to ingress manifest. Okay, so let's go to ingress manifest, and first thing is SSL certificate. This is for you in the sense like whenever you are using this manifest, please add your SSL certificate ARN here. And the second thing is external DNS, right? So for external DNS, so you can use means like I'm using canarydemo.kubecloud.com. In your case, the kubecloud.com might be something of your domain.com. So that's about ingress manifest changes. And if you want, we can even change EKS microservices demo, and the name of this is Canary. If you want, we can even add this way for our ingress manifest name. Okay, so that's about it. So rest all looks good and then as is. So in our next lecture, we are going to deploy and then test the stuff. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to deploy the manifest. Okay, so let's go back to our terminal and clear and go to 14 microservices canary deployments, and I'll say kubectl apply -f kube manifest. So all our application should be deployed, and I'll pause the video until everything is created. So only one thing we'll check and then pause the video. So V1 and then V2 related notification pod should be created. Two pods are getting created. That's good. So until the load balancer is provisioned, so I'll pause the video. Our load balancer is active now, so we can cross check our DNS. As usual, the drill continues. So I'll say ns lookup, and it has something called 899 and then 107. So ns lookup, and I will say what is the name we have given for this. It should be canarydemo.kubecloud.com, right? So let's enter. So DNS is good. So let's go and then test this URL. Okay, so copy and then notification X-ray. So we can give it in browser and then test it, or we can even test via Postman. So for Postman, need to add the environment and all that stuff. So for now, I'll make it bigger and show you. So you can see one time app version V1 coming, and then one time V2 is coming. So let me refresh. Currently you are seeing V1. So let me keep refreshing it and we'll see what happens. Okay. See, now V2 came. So V2 and then V1 alternatively we are getting, means like how the 50-50 traffic distribution. So we'll keep getting V1 now. So let's see till we get V2 one more time. See, now we have got V2. So now let's go back to our X-ray and see what is happening there. Okay. So last 5 minutes, and then it is trying to compute the map, and we can see that whatever we have seen here, user management to V1 notification and then V2 notification, the same thing we are seeing it here. So that's a good thing. So which means like whatever the canary deployment, whatever we have performed, user management is service is distributing the traffic to V1 notification microservice and also V2 notification microservice. So this completes the section of testing deployment and testing of notification microservice canary deployment. So we also need to understand what is happening in the background, right? So as far as notification perspective, what is happening here is in both the deployment files. Okay, so we need to understand little bit about the, means like we need to go back and then refresh our memory about labels and selectors section. Okay, which means like from if you have a deployment and then how the service means like deployment fronting service is going to send the traffic to those respective pods, right? So this deployment has a label named selector label is match labels app notification REST app. So this deployment will find its pods using this match label and then whatever has in the pod template. In the same way, whatever is there in the pod template, the same will be also available in our notification cluster IP service, right? So you can see the selector label inside the notification microservice cluster IP service also is notification REST app. So in V2 notification microservice, we have the same thing, app notification REST app, and then in V1 also we have the same thing. So which means this respective cluster IP service is distributing the traffic to both the notification services using that cluster IP service with this respective selector label. So that's what is happening in the background. So we can even have adding like track is equal to stable or track is equal to canary, additional labels, and then play lots of stuff and then even complicate ourselves. But I try to make it very simple and then trying to say that this notification microservice related cluster IP service is having the selector app notification REST app, and same is available inside notification microservice deployment V2 and also in the deployment V1. So that's the reason this cluster IP service is able to distribute the traffic to both the deployment related pods. So that's what is happened in the background. So now coming back, so we are going to clean up the stuff. Okay, so we have completed the demo and then we are going to do the cleanup. So let me paste it and then do the cleanup. So this will delete whatever we have created, and in our next lecture we are going to understand about downside of this default Kubernetes canary deployment approach and the best ways to how we can perform additional canary deployments in an effective manner. So I'll see you in the next lecture. Until then, bye bye. Thank you. So whatever the canary deployment option, whatever we have seen is nothing but a service load balancing with the selectors and then labels. But what should be the downside of this approach, and then what are the effective best effort options available in the market, we are going to look into in these 2 steps. Okay, so let's go back to our presentation, and if you see here the downside what is there is we are going to discuss now, right? So let's consider you are going to have prod 50% and then canary 50% distribution you want to do, which is like your live running environment 50% distribution, and then canary environment you want to distribute the traffic 50%. So with out of the box on Kubernetes, what are the options available is only playing with the number of replicas, which is nothing but number of pods. So let's consider you have 1 pod for prod and then 1 pod for canary. So you can have 50-50 distributed, or 2 pods for prod and then 2 pods for canary, you can say 50-50 distributed. In the same way, you have a case where you want to distribute 75% of your traffic to prod and then 25% of your traffic to canary. So if that is the case, definitely you need to have 4 pods in your deployment. So 25 for this one, 25 for this, and then 25 for this, which is nothing but 3 pods for prod and then 1 pod for canary. In the same way, if you want 90% traffic distributing for prod and then 10% for canary, in that case you need to have 9 pods for prod and then 1 pod for canary. So like this, based on the number of percentages, means like based on the percentage distribution how you want to distribute between canary and then prod environments, you need to play with the number of replicas, which is nothing but pods. So which will end up in incrementally increasing our pods, and then the distribution might not be as easy and all these things. But if you are dealing with very less amount and then minor amount of pods and then stuff, this will give us the benefit instead of going to complex structured environments like Istio or AWS App Mesh. Okay, so these are not easy, they are defined and then they are evolving. But what I have seen with AWS App Mesh or anything, so things are not straightforward and a little bit complex. So whether we want to increase the complexity of our application, then we can enter into this service mesh concepts if we are in need of those things for our applications. If we're really not in the need of those things, or the features they are providing is not really needed for us today, then we really don't need to go there. If things solve with the simple things, then try to solve it in a simple way. Now let's go to with AWS App Mesh or anything, how it is going to look like. So if I say prod 95% and canary 95%, okay, so still for only a single pod, the 5% traffic will be routed. And if it is prod 70% and canary 30% also, still whatever the traffic coming, it will try to route the from the entire traffic, 30% it will route to the canary and 70% to the remaining pods. So if you see here, in both cases the number of pods doesn't change, because the respective AWS app mesh will sit in front of these respective pods and act as a envoy proxy, and then decide how it need to send the traffic to these things. You will have app mesh related gateway, and then or you can call it in Kubernetes terms of AWS as app mesh controller, and then you will also have envoy proxy in front of this each pods sitting, so that they will control the traffic, count the traffic, and then control to these pods. In the same way, even if you want prod 20% and canary 80% also, still this deployment might work for you with only 4 number of pods. Only thing is this pod is going to get overloaded. So at that time, maybe you will say that canary 3 replicas and then prod only 1 replica. So like that also we can change and use it. But on an overall basis, whatever maybe your percentage of distribution of traffic for prod and canary are changing, you really didn't change the number of pods in this entire design. So that's the beauty of using the AWS App Mesh or Istio. So the best options for doing the canary deployments is Istio, which is open source, or AWS App Mesh, AWS version of Istio with UI and then lots of stuff integrated with AWS other services. So that's about canary deployments end to end. So in our next section, we'll pick up another topic and then move on. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about horizontal pod autoscaler. So let's see what is horizontal pod autoscaler, right? So in a very simple note, horizontal scaling means increasing and decreasing the number of replicas, which is nothing but pods in our Kubernetes deployment. So HPA automatically scales the number of pods in a deployment or a replication controller or a replica set or a stateful set based on that resources CPU utilization. Not only CPU utilization, you can even configure any type of other metrics or custom metrics or whatever you want to configure. So as part of our demo, we are primarily going to focus on CPU utilization. So this can help our applications scale out to meet increased demand or scale in when resources are not needed. So thus freeing up our worker nodes for other applications. So when we set a target CPU utilization percentage, the HPA scales our applications in or out to try to meet the target CPU utilization percentage. So HPA needs Kubernetes metrics server to verify CPU metrics of a pod. So we do not need to deploy or install the HPA on our cluster to begin scaling our applications. It's out of the box available as a default Kubernetes standard API resource. So moving on, how this HPA works. So let's see that now. In a Kubernetes cluster, right, you have deployed a application. So it might be of type deployment or replica set or replication controller or stateful set. So it is going to span the pods, or it is going to create the equivalent pods where it is going to deploy our application container. So now what happens is we are also going to deploy a default Kubernetes metrics server available for us. So this pod metrics information is going to be sent to our respective metrics server. So when we enable the horizontal pod autoscaler for our respective application, so what happens is like it is going to query for metrics, and once it gets the metrics, it is going to calculate the number of replicas this horizontal pod autoscaler need to increase or decrease. So then it will scale the app to desired replicas. So there will be a kubectl scale option. Internally, it is going to use the scale operation to scale either scale in or scale out our number of pods. So once it's scaled, so it is going to either increase or decrease the number of pods in our respective application. So even whatever the new pods, whatever it gets created, those related metrics also will be sent to our respective metrics server. So the thing here is, this whole thing, whatever happens here, this horizontal pod, auto-scaling, collecting the metrics, calculating the replies, and then if required, it is going to trigger the scaling request. So all this happens is called a control loop, and this control loop is executed every 15 seconds. So next, how is HPA configured in our Kubernetes cluster? So that's another important thing which we need to know. So HPA requires scaling metric. So example, you can take our scaling metric as CPU utilization and target value. So which is nothing but in your metric, what should be your target value. When that reaches, then it can do a scaling in or out, whatever is required based on that. So if it reaches 50%, then scale out more, means like more number of pods need to be added. So target value is CPU 50%, and minimum replicas in my application can be 2, right? And maximum replicas can be 10. So whenever it triggers the scale out request, it can go up to 10 replicas. And whenever it is in the cooling period and then it want to cool down, it can come back to 2 replicas and then leave the application with 2 replicas. In our example, we are starting with minimum as 1 replica and then we'll go till 10 replicas. And the command looks this way: kubectl, autoscale, deployment, demo deployment, and it's means like deployment name, and the CPU percentage, which is nothing but the scaling metric is CPU percent, and the target value is 50, and min is minimum replicas, and max is maximum replicas. So this is about the HPA configuration, how we need to enable in our Kubernetes cluster for a specific application which is of kind deployment or replica set or stateful set, whatever it may be. So in our next lecture, we are going to work on the hands-on. So I'll see you in the next lecture. Until then, bye-bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. We are in the section 15 EKS HPA horizontal pod autoscaling. So just now we have looked into the introductory part, what is horizontal pod autoscaling, how it works, and then how it is configured. So the first thing we need to install in our cluster is install the metrics server. Okay, so the current version which is live is v0.3.6, but if you want to go to the latest version and use the latest version, so here is the releases. In the references, you have the metrics server releases section, so you can go there. And so if you see, the latest release is 0.3.6. okay, and at 17th April they have 3.7, but they still didn't make it as live release for us. Okay, so now we are using that one, but whenever you are doing this course and then if you want to cross check this command to be a different value here, so go to this releases section and then cross check what is the latest release. So verify whatever is, means like verify if metric server is installed on our respective kube system. Okay, so let's go here and verify it first. Okay, so there should not be any metric server in our existing cluster, so we can go ahead and then install the metrics server. So let me paste it, and it should install the 0.3.6 metrics server. Okay, so it will create equivalent cluster role bindings and then all the related stuff, and then so now it is installed. So if I say kubectl, right, get pods -n kube system, right, so we can verify the same thing. See, we can see that metric server is up and running in our kube system namespace, right? So if you want, you can even verify that deployment is available for us or not using deployment command. Okay, so metric server deployment is successful. So the next thing is deploy our application. Okay, so let me refresh here once. Okay, so yeah, so deploy our application. So before deploying it, we are going to review our template, right? So let me go here, and if you see here, so this is my EKS HPA horizontal pod autoscaler. So this is the HPA demo.yml. So if you see it here, this is a standard deployment whatever we have created, and its equivalent node port service with 31231 also we have created. So the image here is simple cube Nginx image, so which we have used in our initial sections of the course. The same thing. Only thing here is we have also provided the resources section with how much memory it need to use and then how much it is limited for it. Okay, so it can go max till 200 M, and then after that it cannot move on. So like this, we have also defined the resources for this respective deployment, nothing but for this respective HPA Nginx application. So that these means like metrics should have something right here. So in consideration with metrics, we are going to enable. So as we already deployed the metrics, so in equivalent with that, the resources also we have defined for our deployment. So let's move on and then deploy the manifest. Okay, so we are here, and then we'll go to 15, which is EKS HPA horizontal pod autoscaler, and I'm going to say kubectl apply -f kube manifest, right? So kubectl get pods should give the pod, and HPA demo deployment is up and running for us. So if you say kubectl get svc should give the services, where it will say that it is running on 31231, this HPA demo service, and kubectl get nodes -o wide, right? So our deployment is present in our private subnet, so we will not able to access this application externally, but you can generate the load internally. So even though we deployed our application, so we know that if it is only our cluster is in public subnets, we will be able to access via node ports, right? So that's fine. Okay, we can even deploy a load balancer type of service and then even access it, but our core focus here is on horizontal pod autoscaler and not anything related to other stuff. So what we are going to do is, like, in our next lecture we'll focus on enabling the pod autoscaler and then generating the load and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to create a horizontal pod autoscaler resource for our HPA demo deployment. So this command creates an autoscaler that targets 50% CPU utilization for the deployment. So with a minimum of 1 pod and a maximum of 10 pods. So when the average CPU load is 50%, the autoscaler tries to reduce the number of pods in the deployment to a minimum of 1. When the load is greater than CPU percentage 50, the autoscaler tries to increase the number of pods in the deployment up to maximum of 10. So the template for the command is going to be kubectl autoscale deployment and the deployment name, and the CPU percentage, which is the metric, and value is 50%, and minimum replicas are 1 and then maximum replicas are 10. So we are going to replace with our information here. The deployment name is HPA demo deployment, right? So if you want, we can cross check the same. kubectl get deploy. So whatever we have deployed in our previous step, the same thing, right? So now we are going to use that and then enable the auto scaling. So let me copy this and paste it. So once the auto scaling is enabled, so we can go ahead and then describe our HPA. So using kubectl describe HPA/HPA-demo deployment. So let me describe the HPA now. So whatever it is saying is minimum replicas is 1 and then maximum replicas is 10. Okay. So now we are going to get the horizontal pod autoscaler list. Okay. So let me copy this and then paste it. Right. So we have only one autoscaler which we have implemented, and current target is 0% currently. Okay. Which means like out of 50% it is only in 0% usage. Okay. So if you want one more time, we can check here the description. So you can see that when you describe it, you get the resource CPU on pods is 0% used and target is 50%. If it is above 50%, it is going to scale the pods, okay, to 10 pods max scaling. Okay, currently it is minimum 1 pod. So here also, when you describe any resource in Kubernetes, we already know we'll get the events information here. Okay, so now you can see it here, all the information related to HPA. The HPA was able to successfully calculate a replica count from CPU, resource utilization, percentage of request. The desired count is within the acceptable range. So like that, we'll be able to see the events also when we describe that respective resource. And current usage is 0%. That's the reason there is no trigger to enable it, okay, to increase the number of pods. So let's go here, and then so we can run a Apache bench to put a load on our HTTPD server, which is our Nginx server, and this is our Nginx URL inside the cluster. So this Apache bench also will run inside the cluster only, and then take the cluster IP service of our application whatever we have deployed, which is HPA demo service. So we can see that. So clear kubectl get svc, right? So now you can see HPA demo service Nginx. So that is the one. It is going to take it .default.svc.cluster.local is the DNS name, complete DNS name. Okay, so we are going to put a lot of load using this Apache bench command, and then see what happens. Okay, so let's take this, right, copy and then paste it, and when it is running, we can go to new tab and then also verify the list of HPA and also describe HPA. Okay, let's see what happens. Okay, so currently it is in 0% only. We don't see any issues so far. So we'll try one more time to generate the load. So let's see what happens. Okay, so it is trying to generate the load. Earlier we have seen 38,400 requests completed, and then it got deleted automatically, but let's see what happens now. Okay, so completed 50,000 requests, and in parallel we can come here and then cross check the stuff. 92% CPU, we can see it here, right? So 92% CPU. Reason is CPU utilization of the above target is crossed, right? New size it became 2 servers it became. In the same way, we can see 92% is the current size, and replicas became 2 instead of 1. So we can see that 2 pods are running here, HPS, and still the request is generating. So let's see what happens. Okay, so we'll try to put the load like this continuously and then keep checking. Okay, so I can say we have 4 pods now. You can see it, right? So automatically 4 pods came in. Only 1 pod is 6 minutes before when we have deployed it, but rest all is latest pods which are spinning up. And one more is we can see continuously the get HPA command to see 191% of the targets it is using. So if you see the number of pods now, so it got increased, you can see, right? So in the same way, we can also see the describe command to see what's going on in the events. See, new size is 4. Now the new size is 8. So it keeps increasing. So here the traffic is over. If we want, we can still run the traffic one more time and then keep monitoring our stuff. Okay, so from 2 to 4 it became 4 to again it doubled to 8, and then it's still waiting. Okay, current deployment pods 8, and then desired is 8, and max replicas are 10. Okay, so let's see what happens now. Let me run it one more time, and clear kubectl get pods. So we can see now 8 pods are running. So let's wait for these things to complete. So now it is only at the 30% range. Why? Because the number of pods are increased, right? So automatically it is not getting above 50% to get any new pods. Okay, So we'll see how it goes. Okay, so we are not able to put that much load now. Why? Because the requests are distributed across 8 pods. Okay, but that's fine. We have seen the overall thing, right? Which means like from 1 pod to 8 pods it increased. And if you give a 5-minute interval, means like if no, see, you can see that now. So it became 116% now, and then from 8 current to 10 desired it became, and then deployment pods also will become 10 pods now. So 10 current to 10 desired. So we reached maximum number of pods, how much our application can take it. Means like we have configured to max 10 replicas, and then all those 10 we have got it. Okay, kubectl describe HPA demo deployment. So 10, and CPU resource utilization is above the target value. So that's about it. So again, what I'm going to do is I'm going to stop this load now, right? And then I'm going to wait for 5 to 10 minutes so that it will cool down, and then again bring us back to the single pod. So I'll pause the video until then. So in step 6, we'll see the cooldown or scale down behavior. So the default cooldown period is 5 minutes. So once CPU utilization of pods is less than 50%, and then those 5 minutes has been completed, it will start terminating the pods and will reach to minimum 1 pod as configured. So let's go ahead and then see the number of pods now. kubectl get pods, and we can see only 1 pod is running. So let's describe the deployment and then see what are the events present there. Okay, so now if you see the current CPU utilization is 0%, so the target is 50%, so which means the desired is 1 and the current is also 1. And if we see the reason here, right, in the message, new size, from new size 10 to it has changed to new size 1. Reason, all metrics are below this target, so that's the reason it became 1. So this is about the horizontal pod autoscaler implementation. So we are going to clean up the stuff now. So let's go here and then delete the HPA deployment. So let me clear this and paste it and delete the HPA deployment, and also delete the entire whatever the manifest we have created, right? So we have deleted the HPA horizontal pod autoscaler related configuration, and also we are deleting the equivalent deployment and then service. So we have cleaned up everything. So one more thing which we need to understand about the same thing is in the latest versions, right? So as far as now, like Kubernetes 1.16 is supported, latest and supported on Elastic Kubernetes Service EKS, okay, in AWS. But in the real world, means like the current live version of Kubernetes is 1.18, and there is a beta changes available about that, which is related to HPA, which is nothing but so far whatever we have implemented HPA, we have done it using imperatively, right? So imperatively you have given the kubectl autoscale deployment command and then you implemented it. But in future, means like when you are using the 1.18 and then once this beta becomes live, so you can start using these things, right? So which means like you can declaratively define your Kubernetes horizontal pod autoscaler behavior in your YAML manifest and then execute them. So for additional information about that, you can reference this respective link, so which has the information about these things. Okay, so I'll see you in the next lecture with vertical pod autoscaler topic. So until then, bye bye. Thank you. Welcome back. In this section, we are going to understand about vertical pod autoscaler related autoscaling concept. So vertical pod autoscaler automatically adjusts the CPU and memory reservations for our pods to help right size our application deployed. So this adjustment can improve cluster resource utilization and free up CPU and memory for other pods. So the main benefits include cluster nodes are used efficiently because pods use exactly what they need. So pods are scheduled onto nodes that have the appropriate resources available, and we don't have to run time-consuming benchmarking tasks to determine the correct values for CPU and then memory requests. So maintenance time is reduced because the autoscaler can adjust CPU and then memory requests over time without any action on our part. So these are the very high-level things about vertical pod autoscaler. So moving on, so we have three types of VPA components available, which means VPA is not out of the box available unlike HPA in the Kubernetes resources. Okay, so VPA is an additional resource. You need to install that in your Kubernetes. So as part of that installation, so we are going to get three components from VPA side. So VPA admission hook, VPA recommender, and then VPA updater. So VPA admission hook, so what it is? So every pod submitted to the Kubernetes cluster goes through this webhook automatically, which checks whether a vertical pod autoscaler object is referencing this pod, or one of its parents like replica set or deployment is referencing this information. So if it is referencing, then it moves on to the next step. Okay, so what is VPA recommender, right? So VPA recommender is nothing but it connects to the metric server in the cluster and then fetches historical and then current usage data like CPU and memory for each VPA enabled pod and generates recommendations for scaling up or down the requests and limits of those respective pods. So what does VPA updater do? So it runs every 1 minute. If a pod is not running in the calculated recommendation range, it evicts the currently running version of that pod, so it can restart and go through the VPA admission webhook for that respective pod, which will change the CPU and memory settings for it before it can start. So we are going to execute it now and then with hands-on demo and then see how it happens. So we are going to put some load on our application once we deploy, and also write the VPA manifest and then deploy it, and then understand more about when we put the load, how our CPU and memory resources of our respective pod increases automatically based on VPA whatever we have configured. We are going to look into. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture, we are going to work on step 2, step 3, and then step 4. So as part of step 2, we are supposed to have the metric server installed on our Kubernetes cluster. So metric server we have already installed as part of HPA. So if you want, we can go ahead and then check that kubectl get pods -n, which is in kube system we have it. So let's verify in kube system. And we can see that metric server is up and running. So the next thing is we are going to deploy the vertical pod autoscaler. So to do that, we need to git clone autoscaler, Kubernetes autoscaler git repository. So we will come out of our existing git repository, and I'll try to create a VPA demo folder, and we'll go inside that, and then we will git clone this repository, right? So once that is done, we are going inside the VPA folder, which is nothing but a vertical pod autoscaler folder, and then we are going to install it directly. So to uninstall it is VPA down.sh, and to install it is VPA up.sh. So let's wait for it to complete. So we went inside cd autoscaler vertical pod autoscaler, and then to install we are going to use this option, right? So let it install everything, and once installed we are going to verify the pods present inside the kube system namespace. So it installed. So let's go ahead and then verify the VPA pods in kube system, right? So now we can see VPA admission controller, VPA recommender, and then VPA updater. So 3 pods are already running now as part of whatever the VPA deployment we have done. So in our next step, we are going to review and then deploy our application manifest, which is deployment and then service. Inside that, those are going to be a standard deployment and then service. So in EKS VPA vertical pod autoscaler, we have 2 kube manifests. Inside that, demo application is 01 and original VPA manifest is 02. Okay. So it is a standard kube nginx deployment, simple kube nginx file with replicas as 4, and to export it with node port service and internal cluster IP service also it will be available like this. But this one you can access externally only if your cluster node groups are present on the public subnets. So my cluster currently is in private subnets. You really don't need to access it externally to generate the load. We generate the load using Apache Bench, container and then pod inside the cluster only. So but just for a namesake I have created it as a standard, so we can leave it as is. So now the important point to discuss inside this is the resources section. Okay, so in the resources section for vertical pod autoscaler, we are telling the Kubernetes that we are going to request CPU as this much and then memory as this much. So these are very, very low if you see for any container or any pod, right? So these are very, very low, 5 MB and then what is 0.05005 CPU, which is very, very less. Okay, but we are going to put very minimal to our application, and then how our autoscaler, vertical pod autoscaler is going to performance tune your application when we put the lot of load on our application. We are going to see that. So to practically demonstrate it, we have reduced our memory and CPU requests for our deployment manifest to be very minimal. So now let's go back here. So that's what I want to discuss as part of this sections. So now these are the requests and the limits we define in our VPA definition. So when we are doing the VPA definition, we are going to discuss that. So let's go ahead and then deploy this. So this information I need to update little bit. Just give me 1 second. I just changed the path of our application where it is located. Okay, so it is present in kube manifest and then my file is 1VvQ7kBnJp6 demo application.yaml. So let me go ahead and then deploy this. So I can deploy from wherever it is, kubectl, right? So we can deploy it. Okay, so only one thing is like we are not in that location. We went to the vertical pod autoscaler. We have cloned the repository and present there, right? So we'll go back to our course repository, right? So I'll come back and I'll go to my course repository main folder, and inside that I need to go to 16, which is nothing but EKS VPA vertical pod autoscaler, right? So now I am going to deploy my application, right? So this looks good. So I'll say kubectl get pod svc deploy, all the stuff. Okay, so now if you see, we have the VPA demo deployment. 4 pods are running. Okay, all are up and running now, and it's equivalent VPA demo service node port service with the internal cluster IP with 80 also available for us. So deployment 4x4 ready. So now describe one of the pod here. Okay, kubectl describe and then pod, and then this is the pod we want to describe. Okay, so I'll say any one of the pod from our VPA demo, right? So if you see here, the current information whatever we see is it has requested 5M and then 5MI for our CPU and then memory. So just make a note of that and then we'll see later what happens. So now we have completed the step 4 also. And this one, if you want to access your application, you can access only if your application is in public subnet, means like if your cluster node group. So our cluster node group is in get nodes -o wide. It is in private subnet, so we really don't have any external IP. So that's fine. Okay, so this step is optional. Why? Because our test is mainly related to VPA resources. We can ignore this. Okay, so in our next lecture we'll discuss about create and deploy our VPA manifest, or review and then deploy our VPA manifest, and then move on with the next steps. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a VPA manifest required for our application, whatever we have deployed. So vertical pod autoscaler related manifest we are creating now. So if you see here, so its API version is autoscaling K8 IO v1 beta 2, and the kind is vertical pod autoscaler, and metadata is kube nginx VPA, whatever we want to put it. In spec, we have a few things, 2 important things: target reference and then resource policy. So target reference is to which deployment you are going to point to. So my deployment is means like to which application you are going to point to and of what kind, whether it is a deployment or stateful set or whatever it is, right? So mine is a API version apps v1 and its kind is deployment and its name is VPA demo deployment. So that information we have provided in target reference. And we also have resource policy where the policies related to respective container we need to define. So in our pod, if we have multiple containers also, per container how much it need to be defined also, you can provide the container name and then provide the information. So controlled resources we are doing is CPU and then memory by VPA, vertical pod autoscaler, and minimum allowed is whatever we have put in our request section. Okay, so in request section, okay, and max allowed, how much it is allowed for my respective deployment. For this respective container, how much it is allowed is 1 CPU and then memory is 500 MB it is allowed. So that is the max limit it can use, but it can use, this is the max limit, but it can use anything between 5M to 1 CPU. So 0.005 to 1 CPU, how much it want it can use. And even memory also from 5 MB to 500 MB it can use, how much it want it can use that much. So based on the load whatever it is coming, it is going to auto configure our respective pods resources there and then let us know. So if we describe the pod after generating some load, we'll know that how much it is going to be. So that's about the VPA manifest. Okay, so we can even see the same manifest here, Z02 VPA manifest. Okay, so let's go ahead and then deploy our VPA manifest. kubectl apply -f and kube manifest, and inside that we have 02 VPA manifest.yml. So let's deploy this and then we can say kubectl get VPA to see our list our VPS. So we have one VPA, kubectl describe VPA, and kube-nginx is the name of the VPA, kube-nginx VPA. So let's paste it here and we can see that. So for container name star, okay, max allowed is CPU 1 and then memory is 500 MB. So that's about the information, the policy of vertical pod autoscaler for our respective deployment, whatever we have defined, we can see it here. Okay, so the next thing here is we'll go here and then we'll generate some load and then test what happens. Okay, so on terminal 1 we are going to put clear and I'm going to say kubectl get pods and then keep watching the pods. So I have 4 pods here which are running from 6 minutes. Okay, so now I am going to take a new terminal and then paste the command which is it should not be hello, it should be just till here. Okay, so let me fix this also. As it is kube-nginx image, so on the root context itself we have the index.html. We really didn't apply any hello world service here, so it is just /. Okay, so I'm going to run this on 3 terminals continuously. Okay, so let me go here and then paste it and run it. Okay, so in one more also I'm going to run it, and in one more also I'm going to run it. Okay, so and then let me see how it goes. Okay, so what happened? So let me take one more time. So we are going to copy one by one, and then why? Because the names are going to be different. Apache bench 1, Apache bench 2, and then Apache bench 3. So let me copy bench 1 here and then run it, and this is bench 2. Okay, already exists. So here it is running. No, what happened? So let me close, right? So we can run it, right? So anyway, one load is also sufficient for us. We can see it here. So continuously it is changing, it is terminating and then recreating the pods. Okay, so if you want, you can go here and then get pods and then take a newly created pod. Okay, so which is 68 seconds before. Okay, kubectl describe pod and then verify this 68 seconds latest created pod, copy and then paste it, right? And then if you see here, it is taking 25M and then 26214 this much CPU and then memory it is requesting. But ideally, how much we have allocated? We have allocated only this much. If you see here in our respective deployment manifest, okay, so that's about it. So it is taking automatically and then allocating it based on the load, how much we are getting. So if you want, we can even say get pods -watch, and then some more pods will be terminating and then recreating it based on the need, how much we need. Okay, so all these pods already terminated and then recreated. Okay, so that's about it. So kubectl get pods. One more time if you want, we can check. Okay, so these are running from 3 minutes. We can even see those information, how much it is taking. Okay, so that you get a clarity on what happened. Copy and then paste it. So for this it is 25M and then 262144K. So from whatever we have requested, vertical pod autoscaler automatically increased the CPU and then memory of our 4 pods. So which means horizontal pod, where we have increased the number of pods for our application from 1 to 10. But when we come to VPA, vertical pod autoscaler, so all 4 pods are going to be as is 4 pods, but their CPU and then memory got increased based on the load whatever we are getting, right? So that's about it. If you want to run more and more load, so you can keep running these things in different terminals. Okay, so in one terminal with Apache Bench as your pod name you are going to run. In another terminal you are going to run it as Apache Bench 2, and then in another terminal you are going to run it as Apache Bench 3. Pod names I am saying, okay, so that it will get more and more load, and then you will get more clarity on how much it is going to increase based on the load. But as far as we have seen how VPA worked, we already got the clarity. So now few important notes about VPA is, VPA updater can relaunch new pod with updated CPU and memory when you at least have 2 pods in deployment. So this is very important. So we have 4 pods. That's the reason 2 pods at a time. If you see here, that is the important catch point here. Okay, so for these 2 pods it is 4 minutes 54 seconds as the launch time, right? From means like it took from last 4 minutes they are running, and these 2 pods it is running from 3 minutes 54 seconds. So what it does is, so out of 4 pods, first it took 2 pods and then modified its CPU and memory and then relaunched it, and then it waited for 1 more minute and then launched again 2 more pods with again the CPU and memory. So it didn't make any of the entire services down. It ensured that it has done in a rolling update fashion. So but when what happens if it is only 1 pod you have, so that also we need to understand, right? If we have only 1 pod running, unless we manually delete that pod, it will not launch a new pod with VPA recommended CPU and memory, considering the application availability scenario. So it is very intelligent and then understands that there is only 1 pod, and then if I terminate and then recreate it due to VPA recommendations, there will be downtime for the application. I should not be the cause for that downtime. So it will feel that way, and then it will ensure that that pod it is not going to delete if it is only 1 pod in your deployment. So if we terminate it, manually go and then terminate it, then it is going to relaunch with new VPA recommended CPU and then memory resources. So that's about the very important point we need to know about VPA. So let's go ahead and then delete whatever we have created as part of this section. Okay, so I'll go here and then clear the stuff and kubectl delete -f kube manifest. So whatever the VPA we have created and then deployment and then service, it got deleted. So this completes the vertical pod autoscaler demo and then understanding. In our next lecture, we are going to focus on cluster autoscaler for Elastic Kubernetes Service EKS. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are looking into cluster autoscaler from EKS. So how we are going to do the cluster node groups autoscaling, means like inside the groups, how we are going to autoscale the EC2 worker nodes. So on a very high level, cluster autoscaler is a tool that automatically adjusts the size of a Kubernetes cluster when one of the following conditions is true. So there are pods that fail to run in the cluster due to insufficient resources. During that time, so cluster autoscaler will increase the number of nodes so that these pods gets the sufficient resources to schedule on the new nodes. And there are nodes in the cluster that have been underutilized for an extended period of time, and their pods can be placed on other existing nodes, and then these underutilized nodes can be removed from the cluster and then get terminated. So from cost point of view, cluster autoscaler helps a lot for us in increasing or decreasing. So from performance point of view, for increasing the number of nodes, for scaling up the number of nodes, it helps us. And from cost perspective, it saves us when we are not using the resources. It can scale down and then help us from cost perspective. And the cluster autoscaler modifies our worker node groups so that they scale out when we need more resources and then scale in when we have underutilized resources. All in all, it is going to benefit us a lot. So let's go to our GitHub repo, and if you see here, 17 EKS autoscaling cluster autoscaler will be our current section. As part of that, we completed the introductory section, and then in our next lecture we'll focus on our step 2. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So we are looking into cluster autoscaler now, so which is nothing but 17 EKS autoscaling cluster autoscaler. So as part of its step 2, we are going to verify whether our node group, whatever we have, has the ASG access or not, right? So we have created our recent node group, which is nothing but inside the private subnets as part of 07 section, which is ELB classic and then network load balancers. So inside that we have created a private node group. So when we created a private node group, so we have ensured that, so we have the ASG access enabled. So what does ASG access enable mean? Autoscaling group access, and its equivalent roles or its equivalent policies will be associated to the node group role. In the same way, whenever we created our public subnet also, means like public subnet related node group initially also, we ensured that we are following the standards wherein our respective node group, whatever we created in EKS cluster, always will have the standard stuff. So if you see here also for our public node group also, we ensured that we created the ASG access. So that's about it. So now let's come back to our section here, which is 17. And in step 2, so we verified that ASG access is enabled. So that's what from command perspective. But let's go back to our management console and go to our EC2, right? So that is what this step outlines. Okay, so whether we have that respective inline policy associated with our node group IAM rule. So running instances, so we have 2 EC2 instances available here running for our EKS cluster. And if you go here, the IAM role, right? So this is the IAM role, and if you go inside that, and if you see, there will be a inline policies added. Okay, so one is for ingress, one is for app mesh, one is for auto scaling, right? So this is for external DNS. So if you see here, this is the one, whatever you are seeing policy auto scaling. So this is the one, whatever we have given for our ASG access, it auto associated here. Okay, so for this node IAM role, node group IAM role, this respective policy auto scaling has been associated. So we are good with that step now. Okay, so now we are going to move on with deploying our cluster auto scaler in step 3. So there is a direct link available from Kubernetes how to install the cluster autoscaler, which is nothing but this is the cluster autoscaler autodiscover.yaml. So the same concept, whatever regular Kubernetes applies, the same is also associated with the Elastic Kubernetes Service, which is EKS. So the same component we can use here. So, and we are using the master thing so that always we'll use the latest cluster autoscaler stuff. So let me copy this. So deploy the cluster autoscaler to your cluster. So let me come here, and I'm going to come out and then go to 17 and then be ready there. And anyway, this is from the URL we are deploying. We really don't need to worry. So kubectl apply -f, and then I'm installing the cluster autoscaler autodiscover.yaml. So it is creating the equivalent service account, role bindings, and then deployment and all the stuff. So let me clear this, and now add the cluster autoscaler safe to evict annotation to the deployment. Okay, so which is false will be there by default. So we need to add this annotation. Okay, so let me copy this and then paste it, right? So it's getting updated. So let's wait for it to get updated. So we have annotated it. So the next step is to edit the cluster autoscaler deployment to add cluster name and then 2 more parameters. So in our cluster name field, means like before change it is going to look like this, your cluster name. So there we are going to give our cluster name as EKS demo1. So whatever we have created. So you can even say EKS CTL get clusters to get our cluster name also, which is nothing but EKS demo1. Okay, so this is one change, and we are also going to add 2 more parameters, okay, to our cluster autoscaler deployment. So we need to add those information at this respective location under spec containers under command. So we are going to add this whatever is there with node group auto discovery information there. For the cluster name value we are going to put EKS demo1, and these 2 additional parameters we are going to add. So how we are going to do that? Using kubectl edit deployment. So if you see here, kubectl and namespace is kube system and the deployment name is cluster autoscaler. So let me copy this command and paste it here. Okay, and once we go inside that, so we'll start from end. So Shift G will escape Shift G will take me to the end of file, and I'll go little up, little up, little up. So you can see it here, right? So the cluster name. So here we need to provide the cluster name. So let me click on insert, and I'll go back like this, right? And I'll say EKS demo1 and enter. I will also copy 2 more things, which is balance similar node groups and then skip nodes with system pods false. Okay, so I'm going to also paste those things. Okay, so now I added 2 more parameters here in addition to my cluster name change. Okay, so now let me save this, and my deployment got edited, which means kubectl get pods -n kube system. If you see there, okay, so existing cluster autoscaler will get terminated and the new one will get creating from 7 seconds. You can see this, right? So that's a good thing. Okay, so now next thing is to set the cluster autoscaler image related to our current EKS cluster version. Okay, so our EKS cluster we are using is 1.16. okay, so if we go here and then go to Elastic Kubernetes service, right? So if we go here, we can find our clusters, and see, we can see 1.16 is our cluster version. Okay, and a new Kubernetes version is available for this cluster, and if you want we can even update it. So we can click on this, and then 1.7 is available now, 1.17. if we want we can upgrade this cluster to 1.7. I'm not going to do anything now, just I'll cancel this, and then my version is 1.16. as part of 1.16, so I need to find the cluster autoscaler version also 1.16 minor version, whatever latest available, that will be my image version here. Okay, so I'll go to this link here, right, and open it, and if you see here, so these are add-on resizers. So let me go down. So this is vertical pod autoscaler pre-release stuff. So let me go down. So if you see here, cluster autoscaler 1.18 this is. Okay, so let me go down, cluster autoscaler 1.17.2, and now here is the cluster autoscaler 1.16.5 is the latest in 16.x versions. Okay, so we can use 1.16.5 now. Okay, so that is what I also mentioned here. So we need to update that using this command. So at the end, whatever the version is there, you can put it here. So xy.z you can see here, right? So mine is 1.16.5, and then kubectl set image deployment, which we have seen in our earlier demos also. So which is related to rollout changes demo. We have seen this. Okay, so with set image, how you can update your respective deployments image version. Okay, so we'll copy this and then run it so that it will update the version to v.1.16. Okay, so our deployment is updated. So verify if our image version got updated. Okay, so using kubectl, get deployment and then export with YAML, so we can see that. Okay, so let me clear this and paste it here. Okay, and if you see, go here, see now our image is v1.16.5. it looks good. Okay, so that's good. So now this completes the step 6, and then now we are moving on to step 7, which is verifying our cluster autoscaler logs. Okay, so let me copy this and then clear this out and then paste it. Okay, so now if you see that, start refreshing cloud provider instances, and we really don't see any issues related to our this thing. Logs look good. So let's wait for a minute or less than that to see if any issues we have. Okay, node group means reached and all these things, these are standard logs. Okay, so we really don't need to worry. So 0 other pods unschedules, you can see, right, the sample logs you can see, and then the same we can see it here. No schedulable pods or no unschedulable pods, calculating unneeded nodes, all these things it is doing it. Okay, so in our next lecture we'll focus on deploying the sample app and then cluster scale up and then scale in, we are going to look into. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to deploy a simple application and then verify scaling up and then scaling down of our cluster and then clean up the stuff. Okay, so let's go ahead and then verify our stuff here. Okay, so this is a simple Nginx application, Kube Nginx. Okay, with one replica we are deploying, and we are ensuring that it requests for the CPU 200M and then memory 200 MI in the initial stage. So whenever we increase this replicas to 30 or 40, so then we will run out of system resources in our respective cluster node group, and then it will try to add 2 more nodes, whatever it is required. Okay, so let me go here and then paste it and copy and then paste it. Okay, so clear, and I'll say kubectl apply -f. I am in 17 EKS autoscaling cluster autoscaler, and then I am deploying my sample application. Okay, and now my application is deployed. My next step is to cluster scale up, scale our application to 30 pods. So in 2 to 3 minutes, one after the other, new nodes will be added and pods will be scheduled on them. Our max number of nodes will be 4, which we provided during node group creation. So if you see here during the node group creation, so we said that minimum number of nodes is 2 and then maximum number of nodes is 4. That's what we have given. So if I go here and for our private thing, right, so which will be in classic and then network load balancers. Okay, so this is the value I am talking about. So minimum nodes are 2 and then maximum nodes it can scale up to 4, we said. Okay, so now whenever we increase the load and then in the 2 resources, in the 2 servers, if the resources are not sufficient, then it is going to launch 2 more nodes and then schedule those stuff. Okay, so let me close this and then close this and come back and come down. And now first thing is, in one terminal we are going to watch the logs, whatever is happening. Okay, so in this terminal. Okay, and in another terminal we are going to verify how many pods we have. First thing, right, so we have 1 pod for CA demo. CA means cluster autoscaler, and we are also going to see get nodes to see how many nodes we have currently. So we have 2 nodes running which are in private subnet, no external IP, and then now we are going to scale with the replicas 30 for the deployment, CA demo deployment. Okay, so for this we are going to scale up to 30 replicas. Okay, so now let's see what happens. Okay, so if you see the pods, so few pods will be in the pending state because it really don't have the resources to schedule. Okay, so now the containers, whatever it is getting created, it will create, but rest of the things will be in the pending mode. So because it doesn't have the resources to schedule. So now if you see here, here the logs will be running quickly because it doesn't have the resources, and then it need to scale up to provide more nodes. Okay, so let's wait for it to happen. Okay, so now let's come back here and we can even watch our nodes here. Okay, so nodes and then -w, right? So and then we can come back and then keep watching these logs also. Okay, so let it schedule the new nodes and then we will see. So out of 30 pods, it is saying that 6 other pods marked as unschedulable can be scheduled. So it has issues with scheduling few of the pods, and let's see what happens. Okay, so kubectl get nodes, if how many nodes we have got. Okay, see 2 more nodes already created, and then they are getting ready, and as soon as they are ready, so now our pods also will be in the running state. So now all the nodes are available, the 2 more nodes are in action, and then you can see all the pods are in running state. So that's the good thing, right? So if you see here kubectl get pods, so all 30 are running, and if you see kubectl get nodes, we have 4 maximum. It can scale up to only 4 nodes, and on 4 nodes all these 30 pods are sufficient. Okay, but if you increased it to 50 pods, then remaining will be in pending state, and it already reached the max of 4 nodes, so it is going to put all those pods in the pending state only. So the Kubernetes scheduler will put it in pending state only. So that's about it. So now if you want to scale down, right, so what you can do is like you can again bring back to 1 node and 1 pod and then verify the nodes. Okay, so scale replicas to 1 and then wait for the pods to watch. Okay, and all the pods will go away, terminating, and then we'll have only 1 pod at the end. Okay, so only 1 pod we have now, and slowly this will also come down. So unneeded nodes will be removed immediately within 5 to 10 minutes. It might take close to 5 to 10 minutes to cool down and then bring back to from 4 nodes to 2 nodes. Okay, so let's wait for that to happen. So we can see it here, few of the nodes are unneeded, and then it is saying that we can remove them. Okay, so it will slowly remove it, and then finally we'll end up with only 2 nodes. So let's wait for it to happen. So we can see it now after 10 minutes for the 2 nodes, scheduling is disabled. So once the scheduling is disabled, the next step is to it will go ahead and then automatically terminate those nodes. Okay, so let's wait for it to also get it terminated. We can see now our number of nodes became 2 from 4. So that's about it. So let's go back and then clean up our application, whatever we have created, and we will clean that up. We'll go to 17 EKS clear and clean up the application whatever we have created, and that's all. Okay, so we have completed the end-to-end section related to cluster autoscaler. In our next section we are going to discuss about another topic. So I'll see you in the next section. Until then, bye bye. Thank you. Welcome back. We are going to look into CloudWatch Container Insights feature as part of this section. So we are going to look into many CloudWatch features and also a simple notification service as part of this. So what is this container insight and then what it is going to do? So let's go ahead and then see that now. So Container Insights is a fully managed observability service for monitoring, troubleshooting, and alarming on our containerized applications. Container Insights also allows us to collect, aggregate, and summarize metrics and logs from our containerized applications and also for microservices. So the metrics include utilization for resources such as CPU, memory, disk, and then network. It also provides diagnostic information such as container restart failures, so that you can consider as one metric to help us isolate issues and resolve them quickly. So we can also set CloudWatch alarms on metrics that Container Insights collects. And the metrics that Container Insight collects are available in CloudWatch automatic dashboards too. And we can analyze and troubleshoot container performance and logs data with CloudWatch log insights. So if you see from CloudWatch perspective, so on a very high level, it has covered the maximum ground, even the newest and latest container insights feature. So you can configure CloudWatch alarms inside container insights, and you can also have CloudWatch automatic dashboards for the metrics information. And you can also, means like container insights is collecting the logs, so you can also have log insights feature, and using log insights based on the queries whatever we have written, again we can create the custom dashboards for us, and then based on that whatever the patterns we select, right? So the type of errors our application is facing, and then create a log, and then for that log create a query, and then using that query create a graph, and then try to add it to the dashboard. So that what happens, we can continuously monitor that type of error in our application using log insights queries and then adding it to the dashboard. So like this, we can have lots and lots of benefits using container insights. So let's see what we are going to deploy as part of container insights to our EKS cluster, right? So in a Kubernetes cluster, let's consider you have two worker nodes, worker node 1 and then worker node 2. So let's consider this as our EKS cluster in AWS. So you are going to first deploy a FluentD daemon set. So we already discussed about what is daemon set and then what are the features it provides during our X-ray section. So daemon set in very simple terms is whenever you configure your application as a daemon set, it is going to deploy one pod per worker node. So on every worker node, one of our pod will keep running. So now we have the FluentD pod up and running as a daemon set in worker node 1 and then worker node 2. The next thing is, what is this FluentD pod going to do? So it is going to collect the application logs, which is nothing but the container logs, and also the Kubernetes cluster logs, and whatever, means like the data plane logs, application logs, performance logs, and all these things, and then it is going to push to the CloudWatch, wherein using CloudWatch log insights, we are going to analyze them and then create our custom dashboard screens for it, okay? And next thing is CloudWatch agent daemon set. So what is this going to do? So this is one more daemon set we are going to deploy. So this one will collect the metrics information of our applications, cluster, worker nodes, EC2 instances inside that, everything, okay? So it is going to provide the CPU, memory, pod, everything, all the information, service information, all. So we have a dimension of 134 types of CloudWatch container insights metrics that is going to get collected as part of this CloudWatch agent. And next is, if we deploy our application on this cluster and when these things are running, they are going to collect the necessary information and then push it to the CloudWatch service. And now the information is there in CloudWatch service. So who need to use it? Either a developer or a operations user can go to CloudWatch management console and then start looking and then analyzing the data. So first in container insights, the core feature is it provides a container map. So it is going to be a very nice feature, and then it is going to give complete picture of all the objects present in our Kubernetes cluster, pods, services, nodes, everything, okay? So you are going to see all those things in our next slide about the container map. So let's wait for that. And another thing is, it is also going to provide the list of all container resources. So container map and resource view is same, but only thing is you can see in map view or you can see in list view in the container resources. Next is performance dashboard. So from the FluentD daemon set, it is going to collect performance logs, and CloudWatch agent also will collect the performance related metrics, and all the information related to metrics you can see in performance dashboard with automatic dashboards created by CloudWatch for container insights. So container insights creates few automatic dashboards, and using that you will see the performance dashboards. So we'll see that also in our upcoming slides. And log groups and then log insights. So we are going to have 4 to 5 types of log groups available out of the box whenever we enable container insights. So for application, logs, which is nothing but whatever we deploy related to pods and then services, those things, and data plane logs, which is nothing but cluster control plane, and also we'll have host related logs. So all these types of logs will be available inside the log groups, and those things you can select inside the log insights and then provide the necessary queries to query the data and then add them as dashboard to our custom dashboards. And now the next thing is alarms. Okay, so now you have lot of CloudWatch metrics, means like this agent is collecting lot of memory, CPU metrics of your pods and then your worker nodes, everything. Now example, like if your worker node is running at 80% CPU, and if you want to trigger an alarm to an email, or if you want to take a automatic action that if this worker node is running at 90%, just go ahead and then using the auto scaling groups create 2 more nodes. So like that also we can do. So all those things are possible with alarms. So now the next step is, let's go ahead and then see the container insights map. So this is a sample map. So if you see here, EKS demo 1, which is nothing but a cluster, right? So the next level in the map is namespaces. If you go inside Kubernetes, on a very high level, it is distributed in such a way that everything is under namespaces from cluster, and then next comes the namespaces. You will have a default namespace and kube system namespace by default. And as part of our CloudWatch container insights, we have created an Amazon CloudWatch EK namespace, and then we have deployed our Fluent CloudWatch pod and then EKS CloudWatch agent pod. Okay, so now in our whatever related to container insights is this part of our map. And kube system, this is the core EKS cluster related map where you have kube proxy pod, AWS node pod, and then kube DNS pod. And in kube DNS you will have a service, and under that service you will have the pod. So now you also see the default namespace, right? So you can see EKS namespace, which is nothing but the default namespace. In that I have 2 applications running. One is app1 Nginx deployment, which is the pod, and it has a service node network load balancer service exposed. So like that. In the same way, I have a simple cluster IP service, sample Nginx service. Under that I have a sample Nginx pod running. So that's about the container insight. So how much the content you have, all can be displayed in a map. And also you can go to sub, means like you have a huge amount of containers and then pods and then services deployed. You can even go to a minor part of your map and then see those things also in a visual manner. So it's a very advanced model has been provided by CloudWatch here, and then you are going to enjoy that. And next thing is automatic performance dashboard, right? So as we said, whenever the metrics are collected using CloudWatch agent in our cluster and then push it to CloudWatch container insights, it is going to generate automatic dashboards. So these are automatic dashboards. So this is one sample. I have taken it from EKS pods. So you can see CPU utilization for each pod. I have kube system pod, and then I have Amazon CloudWatch related 2 pods, and then kube system other pods, means like in kube system namespace, whatever the pods are there, those are displayed here. In default namespace, I have app1 and then sample pod. So those information. So whatever is present in namespace/pod, all those CPU utilization is shown here, and memory utilization and network utilization. And also it also provides the pod limit, means like over a pod limit, if the CPU is used, those related information also provided here. In addition to that, if you see here, you have seen only EKS pods, but in the drop down you can have lot of automatic dashboards generated, which is EKS namespaces, EKS clusters, EKS nodes, EKS services, and recently, very recently, they have released a Prometheus related integration with CloudWatch, which means CloudWatch container insights, which means you need to deploy your Prometheus inside the EKS cluster, and you can get Prometheus style of metrics to our CloudWatch container insights. Okay, so that's a very good option, recently released, and then it is in beta option today. Okay, so that's about it. So you can have EKS pods, services, nodes, all have automatic dashboard generated for all these things. So this completes the introductory part of our CloudWatch container insights. So let's go ahead and then do some hands-on there. So I'll see you in the next lecture. Until then, bye-bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. So we are in 18 EKS monitoring using CloudWatch container insights. So we already discussed about introductory topics about this one in our introduction section. So we are moving on to our step 2, which is associate CloudWatch policy to our EKS worker node roles. So CloudWatch agent server policy need to be associated with our worker nodes EC2 role, so that it gets the, means like these worker nodes will get the access to push the logs to the CloudWatch or send the metrics to the CloudWatch container insights, or it gives the CloudWatch container insights to pull the information whatever is present in our pod metrics or cluster metrics. So now let's go back to our management console, and what I said here is go to your EC2 worker nodes and then find the IAM role parameter and then click on that role. So that is the easiest way. So I can go to EC2, right? And I have 2 EC2 worker nodes running here. So I can say, so this and then this. So I can go to them. So those are tagged with respective EKS only, right? So these are EKS demo 1 ng private 1. So which means those are deployed in our private subnets. kubectl get nodes -o void will give us the external IP. If it is associated, you can tell that it is on the public subnet of our cluster. If it is none, it is on the private subnet of our cluster. So I'll go here and then find the role EKSCTL EKS demo 1, right? So from any one of the instance you can find your role, and then inside that role we are going to associate the policy CloudWatch agent server policy. So let me go here, and it is loading, so just give it a minute. I don't know why it is slow. Okay, got it. Okay, so now let's go here and attach a policy named CloudWatch agent server policy, right? So for our EC2 instance role, worker EC2 instance role, we have associated a new policy which is nothing but CloudWatch agent server policy. So that's good. So now let's come back and install the container insights. So container insights you can install specifically, which means like you can install one after the other, means like it will have the components like CloudWatch agent and then FluentD. CloudWatch agent is for our metrics to be pulled, and then you will also have FluentD for pulling the logs also, means like from logs from our EKS cluster. So you can independently install CloudWatch agent and then FluentD, or with a quick start option you can install everything. So we are going to use the quick start option to install both of the stuff. Okay, so now when you are installing it, so what it does we are going to look into first. Okay, so this command will install everything. Okay, so what is this command we'll see in a bit, but what it does is it will create a new namespace named Amazon-CloudWatch in our Kubernetes cluster, and then it will create necessary security objects required for creating the daemon sets. So in simple terms, it is going to create a daemon set, one daemon set for CloudWatch agent and then one daemon set for FluentD. So now we already seen daemon set when we are doing the X-ray section, if you remember, right? So it will create per node one pod for us in the daemon set. So the number of nodes increases, the pods per node, one pod for FluentD and then one pod for CloudWatch agent will be always installed on each node. So in this step it is going to create security role, cluster, security account, and then service account, and then cluster role binding, whatever is required for that it is going to create. And it deploys the CloudWatch agent responsible for sending the metrics to the CloudWatch as a CloudWatch service in AWS as a daemon set. And it also deploys the FluentD responsible for sending the logs to the CloudWatch as a daemon set. And it deploys config map configurations required for this daemon sets. So that's what this entire thing, so the entire CW agent and FluentD quickstart.yaml is going to do. If you want, you can open it and then review it for your convenience. So means like you are now good at YAML, and then you are now good at reading lots of Kubernetes manifests after writing them. So now you can see that it creates a namespace, and then it creates a service account for us, and it creates a cluster role binding and then cluster role, and it also creates the config maps for CW agent, and then it creates the daemon set for CW agent with this information. In the same way, you will have the same for our Fluentd also in the down. So like that, so we can review whatever AWS has provided. Okay, so now what is this template and what is that replace the cluster name and region? So this is the template information, which means like this whole value, whatever is there is the template, and then inside this you are sending cluster name value and then cluster region value, so that in which region you are installing this CW agent and Fluentd, and in which cluster you are installing, you are providing those to your CW agent quickstart.yaml. So in our case, wherever you see cluster name underscore this in the red area, here you are going to replace with your EKS demo 1 and region is US East 1. So if you see here, that's what we have done here. So you can see, right? So for cluster name we have put EKS demo 1, and for region name we have put US East 1. So now as we already completed the section which is associate CloudWatch policy to our EKS worker nodes completed, so we can deploy this one now. So let's go here and then deploy it. Okay, so now it will create associated stuff, whatever is required for us. It first created the namespace, then created the service account, cluster roles, and then cluster role bindings, and then config maps, and the daemon set for respective CloudWatch agent. Again, same for service account for Fluentd, cluster role binding, and then config map for Fluentd, and its equivalent daemon set. So now once it is created, so we can clear, and then we can say kubectl-f, and then verify the daemon set here. Okay, so as we have already provided the respective role, ideally they should be ready. 2x2 is ready in both. Why? Because we have kubectl get nodes, 2 nodes, so we'll have 2 daemon sets, means like a daemon set is per node it is going to run, so 2 CloudWatch agents and then 2 Fluentd CloudWatches are going to run. Okay, so this completes the installation part of our container insights on our EKS cluster. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So we are going to deploy a simple Nginx application and then generate load on our sample Nginx application, and then access the details on the CloudWatch dashboard. Okay, so I'm going to say kubectl apply -kube manifest. Okay, so let me clear this and say kubectl. We are in 18 section, 18 EKS monitoring using CloudWatch. Okay, so I'll say kube manifest. So what we are deploying, so let's go ahead and then verify the manifest also. So in 18 EKS monitoring with CloudWatch, you can see sample Nginx app, right? So this is simple sample Nginx app which will have kube Nginx 1.0.0 version, which will have a root index.html inside that. So now what we are going to have here is the request section, which is important, requests and then resources. So I am requesting CPU for 5M and then memory for 5MI. And then limit also I have put only very less. Okay, and then I'm going to put huge load on this and then see what happens. Okay, so we are going to access the pod using a simple cluster IP service, okay, which is sample Nginx service. Okay, so if you come here and see when I'm generating the load, so I'm going to say kubectl run generate run pod v1, and I'm using the Apache bench as my pod name, and I'm going to use image as httpd, and then what I'm going to do here is this is the service name. Okay, sample Nginx service dot default is it is deployed in default namespace, and it is a service SVC, and inside the cluster dot local. That's all. Okay, and the part means like every time I'm going to hit with 1000 requests, and then I'm going to end up at 5 lakh requests. Okay, so let me generate the load on that and then see what happens. Okay, before that we can even verify get all will provide us the information. So we have only our simple sample Nginx service and then sample Nginx deployment. Okay, so now let me generate the load. Okay, so we are generating it. So total of only 3447 requests completed, and then connection reset by peer happened. So we are going to run one more time and let it run, and then we'll go back to our container insights dashboard and then see what happens. Okay, so let me go back here and then go to management console and then go for our CloudWatch, right? So let me, no, not cloud search, so we need to go for CloudWatch. So okay, CloudWatch, so this is the one. Okay, so now you can see it here. We have something called container insights. So it is in beta stage as on today, but it is live also. Okay, so now I'll click on this, right? And we have 3 options here available. So this is one more brand new feature also they have added to this container insights, which is container insights has recently announced the beta release for Prometheus metrics monitoring for EKS and Kubernetes clusters. So this is a very good news. So Prometheus is a very famous tool for cloud native related stuff, and they also integrated that also with the container insights. For now we are going to do direct in container insights what is available. Okay, so we can list all our container resources here and we can view everything in our map. Okay, so it can do application monitoring, infrastructure and performance monitoring, and even troubleshooting, and then right sizing. All these things it can take care using container insights. So first we'll go and then list our container resources. Okay, so let it load what all are our container resources available here, right? And let me close this. Yeah, so these all are available for me, right? In a namespace, Amazon CloudWatch is there, and App1 Nginx deployment, AWS node, CloudWatch agent, CodeDNS, all these are the resources available for us. Okay, so now if we go to the map, right, so we can see the map view here, and if you see here in the EKS namespace, means like in the default namespace, right, this is the EKS demo cluster, and in the default namespace you can find something called NLB App1 Nginx and then App1 Nginx deployment, which I have deleted it. For now it is not there. So now I have something called sample Nginx service, so which is nothing but whatever we have created, right? So sample Nginx service, and we also have sample Nginx deployment. Okay, so I'll say smaller, and so this is the one. So if you want we can see in a bigger view. And we also have in kube system namespace, we have kubeDNS, AWS node, and then kube proxy related stuff inside that, and also we have EKS pod also. Okay, so these are services and then these are pods. Okay, and in CloudWatch namespace, which we have recently installed, we have Fluentd CloudWatch pod and then CloudWatch agent pod. Okay, so that's about it. On a very high level, it is also going to show what are the memory and then CPU usages also about this stuff. Okay, so you can see less than 1% CPU average currently it is showing. So that's about it. In resource view you can see, or you can see in the list view or in the map view about entire our cluster what we have in detail. Now if we go here, we also have the performance dashboard. Okay, so for our EKS cluster we can also see the performance monitoring information for last 3 hours. If you want, we can see it. Okay, so for the cluster, CPU utilization is at 7% and then memory utilization is at 16.6%. you can see for the EKS demo 1 cluster, right? EKS clusters, and then I have selected we have only one cluster here, and its network and then disk cluster failures, number of nodes, everything it is going to show us. So number of nodes at this point of time we have 2 nodes, and disk utilization is 14% and no cluster failures so far, and network utilization is like this, and memory utilization is like this 16%. Okay, and like this we can see every information. So now in addition to EKS clusters, you can even see by EKS namespaces, right? So and what are the namespaces available for us? Okay, default we have some information there for the thing. So you can see default CPU utilization, how it is, and then you can see blue little high here, right? So like that. Okay, in the same way Amazon CloudWatch, it has 2.1, means like our system resources related to CloudWatch Fluentd and then CloudWatch agent is using 2.1 CPU utilization, okay, and memory utilization. For all these things you have CPU, memory, and then network, and CPU utilization over limit, memory utilization over limit also you can see, okay. So now you can see who is hitting the over limit. So CPU utilization for default, for which one it is hitting is, see, you can see it here, CPU pod over pod limit container insights, you can see here. So for in the default namespace it is using 71.9%, okay. So which clearly says that over limit related statistics also it is going to provide us, okay. So that's very important thing, okay. So why it is going, so we'll go to the pod view to see that, okay. So this is nodes view. Once we go to the pod view, we will see over limit in a clear manner, okay. So you can see per nodes, okay, nodes CPU utilization and resolved CPU utilization, CPU computation, and memory utilization, all the information is available here, okay, per nodes, okay. And services, so how the services information is there, we can see it here. Most important is per pod we need, okay. So EKS pods, okay. So you can see that pods, you can see CPU utilization and then memory utilization, okay. 3.9% in orange, which is CloudWatch agent, okay. And then for default how it is, and all those details you can see. And now CPU utilization is over pod, okay. So if you see here, over pod limit is this one, okay, blue one, which is nothing but sample Nginx deployment, right. So that is using the over the pod limit. So if you remember, so to show this over the pod limit informations, so I have defined the limit as 10M CPU, and then over this it is utilizing, and then it is telling us. So that's what is the over the pod limit, it is using the CPU, and this is a notification for us telling that it is using over the pod limit. Now this is the time for you to increase your pod limit information, okay. So if you made it to 100M or whatever, right. So like this you can know the statistics in a detailed way, right. So that's about the over the pod limit information. So now we have seen pods also, and this Prometheus we still didn't deploy, so we are not going to go into that, okay. So we only deployed EKS related stuff. So we looked into them. So now another important thing is in resources section, right. So where is this? We need to see my deployment name, right. So sample Nginx deployment, okay. So if I go inside that, we have this information. So this is the sample Nginx pod, right. So let's see the pod name once, whatever is there. So kubectl get pods, on which we have generated the load. So let's get the pod information. It is PMPPS, okay. So PMPPS is the information. So I can select that, and you can see here there are few things available here. So for this respective pod, you can click on application logs and then performance logs, okay. So first I'll open the application logs for this, okay. And this will take us to the CloudWatch log insights, okay. So it will take us to the CloudWatch log insights, okay. Log insights is another important feature. So as part of Fluentd, it is pushing the logs here, right. So now it is pushing the logs here. So now we are seeing the respective step. We are continuing our section here. So we have seen the CloudWatch dashboard. So we are also going to see CloudWatch log insights now, okay. So now we'll come here, and if I run the query like this, so we are getting the entire logs for that, okay. So for this one, if you see any of the log, if you want to see it, so what it is accessing, and all the information is available for us, okay. What is the log, and then what is the log stream it is using, and log message, you can see it is trying to get the slash, and it is getting the 200, and who is the agent is Apache Bench is the agent here, and the timestamp, and then Docker container ID, Kubernetes container image ID, and then container name, by container name, all the information. So means like we have a tons of information about our application, which we can mold and then get the information in any way, write the filters and then get in such a way that by this container name I need the information, okay, or from this timestamp to this timestamp I need the information, okay, of logs. So everything you can get, and even this information, whatever the filter you write, that respective filter. So try to get me something called whatever becomes with non 200, okay, 404 or 500 related stuff, and then add it to the dashboard so that those details you will be able to see in the dashboard. Okay, so like that you can do lots of information using this data. So you can massage and then use the way, whatever the way you want with this information. So which means Fluentd installed as part of our CloudWatch inside the EKS cluster is giving good amount of log information, which we will be able to manage in whatever the way we need it. Okay, so that's about logs. Okay, and one more thing we can see is performance logs. Okay, so this is about, again, this is another dimension of getting the data. So here you are going to get only how our performance of our applications is available there. Okay, so if I click on this, right, so you can see here you will get a different dimensional data. Okay, so container file system available, container file system capacity, container file system usage, and then container file system utilization. So like this you get the data in a performance view also. With this also you can generate the dashboards and then use it. So you need to learn more about insights related filters and then fields, and then using that you will be able to write better. Okay, so and then add them to the dashboards and then use it. But you have the data, you will be able to do those things easily. Okay, so that's about this one. Okay, and another thing is we already seen as part of X-ray for deploying our sample services, application services, we have seen X-ray traces, right? So if you click on this, for this is an Nginx application, I really didn't enable any X-ray trace here. Okay, so ideally we will not see anything, but if you have deployed any of the X-ray related application, right, so you will be able to see that. So from here itself you can go and then see the X-ray traces. From this screen itself you can launch the X-ray trace for that respective container image and then see all those traces also. Even those things, the service map, whatever you have seen in X-ray, those also going to get displayed here. So this is about the container insights, log insights, and then CloudWatch dashboard on a high level. In our next lecture we'll also see on a very high level how the alarms looks like, and then we'll wrap up. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about log insights in depth from container insights perspective for EKS cluster, right? So we are going to look into log groups, log insights, and then create a performance dashboard for us. Okay, so let's go back to CloudWatch Management Console, and if we go to logs here, so we'll have something called log groups and then log insights. Okay, so on a very high level we have seen log insights in our previous lecture, so we'll go in depth and then implement few of the things here. Okay, so let's go to log groups here, and if you find we can find following 4 log groups related to container insights for our EKS demo 1 cluster. So one is for applications, one is for data plane, and one is for host, and then one is for performance. Okay, so primarily we are going to look into performance and then application and then create few metrics for those things. Okay, means like create dashboards using few of the filters inside the log insights. Okay, so let's start with something called create graph for average node CPU utilization. Okay, so now what we are going to do is we are going to write a simple query here saying that from performance log group we are going to get the information from stats section, average node CPU utilization as and by node name, and average node CPU utilization using descending order. Okay, so we can copy this, right, and come here and then paste in the respective section here, editor, and then select the log group as performance. Okay, so in performance log group we are going to run this query and then see what happens. Okay, so node CPU utilization, so this is the one. Okay, so average node CPU utilization value we are getting by node name we said. Okay, so by node name, so this is one node and this is one node. Okay, so it is average CPU utilization is 3% for our both nodes. And if we want to get this, means like if you want this query information to be listed on dashboard, so that one more time we really don't need to run this query, right? So we can save them on our dashboard and then continuously monitor them. So I'll say add to dashboard and I'll create a new dashboard here. Okay, so I'll create a new dashboard and I will say EKS performance, or we can say EKS demo 1 performance. Just I'm saying EKS performance. So I'm going to create this one, and then I'm going to say bar chart for this. Okay, so whatever is applicable based on these 4 widget types, you can select that one. Okay, so I selected line, and then when I preview, nothing is coming here. Okay, so I selected stacked area, it also doesn't look good. And I checked log table, that looks good for me. And if I want, I can even use bar. Okay, so I'll say add to dashboard. So now this is added to the dashboard. So now the next thing is we'll go back and then add container restarts. Okay, so from performance you can find something called number of containers restarted. Okay, so as average by pod name, means like by pod name, and in a descending order provide that stats information. Okay, so let's come here. So now you can see our graph here. Average node CPU utilization is always 3. Okay, so now let's go back to our insights and then add this also. Okay, and select the log group as performance and run the query. We'll get a high level data and select it as a table. Okay, so I said it is going to be a simple table widget type, and if you see here, none of the containers got restarted inside these things. Okay, so now I'll say add dashboard and I'll select table, right, and this table is going to be there for me always there. Okay, so add to dashboard. Okay, so in last 3 hours there are no restarts. So like that we can see those things. Okay, and we have one more thing here, node failures. If you in a cluster, so count of node failures, anything happened, you can create one more of type table. And CPU usage by container. Okay, so I'm excluding node failures, anything you can do. So we can go and then add it also. So we can go to log insights, and again same drill. Okay, select the performance and copy this and then run the query. Okay, so cluster failed node count as count of node failures. Okay, so we see 0, so nothing happened. Okay, so I am not writing anything or adding it to dashboard. So I'll move on by CPU usage by counter. This is one important stat, right? CPU usage by container, right? Container CPU usage total. Okay, so Kubernetes.container name. So if you see here, per container how the CPU is happening, we will come to know. So we can see, right? So if you see here, CloudWatch agent is using this much, and then this much, whatever it is using, we are getting the information. So I'll go and then add it to our this one. Okay, so I'm going to add it as a bar chart also, we can add if we want. Okay, so we can even add it as a bar, and to see which one is taking highest CPU also. So add to dashboard. And the next thing is, let's come to log insights, and one more we have is pods requested versus pods running. So if you don't have the capacity, so the requested will be there, but running will be there, and there will be also a pods pending also, you will be able to see, right? So but we didn't request a huge amount of pods, so we really don't get that type of information here, but it's good to have such type of information also. Means like that is provided in the performance. So you have requested 100 pods and only 10 pods are running, right? So like that. So Fluentd only 1 pod you requested and then only 1 is running. So kubeproxy only 1 you have requested and 1 only running. Sample Nginx 1 you have requested and only 1 is running. So like that. Okay, so we can add this one also, add to dashboard, and this is only a table data, so we can throw it under table or even a bar. So bar also we can see it looks good. Okay, so I'll say add dashboard, right? So whatever you want, you can change it based on the widget, whatever is available for you, means like whatever is flexible for you. Okay, and the next one is we'll go back to insights, and then we'll also add something called error. Okay, so application log errors by container name. So this is from the log group application. Okay, so any std errors are there, those are going to log for us. So this is one more. Okay, so very important one. So if you go here to application and then run the query, so you will find those informations here. Okay, so if any errors are there, we'll come to know. So we can see there are some errors for few applications. So and then you can add them as a bar chart. Okay, so add to dashboard, and you can even see logs table, and only in kubeproxy you have 230, and I can add it under bar and then add to the dashboard. So once we add all the metrics here to the dashboard, so click on save dashboard. Okay, so if you don't click on save dashboard, so and then if you try to create another dashboard or anything, it is going to have issues. So one important thing we need to know here is, so these informations, right, these filters, whatever I have brought is from directly AWS documentation. Okay, so you can click on this link and you can find how you can use the container insight metric to create your custom dashboards from the log information whatever you brought from EKS using Fluentd. So using that you can create all these metrics. So you can write whatever you want in parallel, means like on the CloudWatch console itself. So whenever you are creating the log insights, right, so you can find the fields here. Okay, so let me also show that for you. So let me take any filter. So this is one filter, right? So let me go here and then in application logs, right? So let me make it bigger. So application and then run the query, right? So for this respective application related log group, so what all the fields available, so you will get here everything in detail. So using this information, discovered fields using for these logs inside this application log group, these fields are discovered, and using these fields whatever you want to write here, so filter by XYZ, filter by Docker container ID, or filter by whatever you want, you can do using these discovered fields. So that's about it. So like this, you have now a custom dashboard in last 1 hour, what is my CPU usage, and in 3 hours what is it, or in from custom date from this minutes to these hours in custom dates also. You can have all this information now. So one time you have stored, one time you have written these queries and then stored it as a dashboard, and then everything is available for you forever from EKS perspective, right? So in the same way, in our next lecture we'll focus on creating the alarms. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to create CloudWatch alarms using container insight metrics. So we are going to create a EKS worker node CPU usage related alarm now. So let's go and see how we are going to do that. So we can go into CloudWatch management console, and then we can go inside alarms and then start creating the alarm, right? In the metric section, we are going to select a metric which belongs to container insights. So all other AWS related metrics are under the namespace AWS, but only the container insight stuff, it came under custom namespaces. So if we go inside, there will be lot of metrics, 134 metrics available for us in different dimensions. Okay, cluster name, instance ID, and then node name. We have 16 type of metrics here. Okay, so which is related to node memory, reserved capacity, node file system utilization, etc. In the same way, with the cluster name, namespace, pod name, we'll have pod related metrics core. Cluster name, namespace, service primarily deals with the Kubernetes service related metrics. So pod related metrics, service related metrics, Kubernetes worker node related metrics, and Kubernetes namespaces related metrics. In addition to that, cluster related metrics also we'll find it here. Okay, so in EKS demo 1 cluster, so we are going to find a metric whose node CPU utilization. Okay, so if you see here, this is the node CPU utilization. So I have selected this and we'll go here and we can add this metric now. Okay, so and period how it need to run, every 5 minutes or how it need to run also we can check it. Okay, so for me, if it runs every 5 minutes is also fine, or every 1 minute is also fine, anything is fine for me. So I'll leave it to default 5 minutes, or we can even change it to 1 minute. Okay, so every 1 minute it need to poll and then get the data for us. Okay, so select metric, and these are the information about that metric as of now. So which is always it is less than 4, and whenever you put the load it will go above 4. So that's the reason I have put the threshold as 4. So to simulate this metric for us, which means like to simulate an alarm and send an email for us, instead of putting the threshold value as 4, 80% or 90% in regular use cases or in real-time use cases, the CPU usage is 80 or 90, it need to trigger an alert. I just put 4% because currently it is running with less than 3. So if I trigger some additional load on that, it might go above 4 and then provide me a alert. So for that purpose, I have put that. So metric name is node CPU utilization and cluster is EKS demo 1, and period I set it as every 1 minute it need to run, and the threshold type is static threshold, and when it is greater than so and so value, okay, so greater than 4, right? So CPU utilization is greater than 4%, then automatically it need to trigger an alarm for us, okay? And data points out of 1 immediately, means like if one time it occurred, then immediately trigger an alert, 1 out of 1. And missing data treatment, okay, treat missing data as missing only, that is fine for us, okay? So I'll click on next, and now alarm state trigger, when it is in alarm, trigger it, okay? So in OK or insufficient data, don't need to trigger an alarm and then send an email for us, okay? And it can send an alarm for us using SNS topic, which is nothing but using email, simple notification service. So we are going to create a new topic here named EKS alerts, and I'm going to provide an email dkalyanreddy@gmail.com and then create the topic. So it will create a new topic and a subscription in the simple notification service. So we can go to SNS console and then we can see EKS alerts here, and subscription also for our email is provided here. So I can go to my email and wait for that email, and once it comes, then I'll confirm the subscription, okay? So now my email confirmation is subscribed. So let me come back, send, and I'll come here and I'll refresh the subscriptions one more time to see that it is confirmed. Good. So and the topics, if you see here, email is confirmed for us. So now let me come back here and move to the next step, okay? So I have added one subscription, means like one email to be alerted, or you can give a group email support@so-and-so.com or whatever, okay? And now in auto scaling actions, so you can auto scale when this alarm happens, you can even do auto scaling, okay? So but our current focus is to just alert, so we are doing that one, okay? If it auto scaling also, if you create your auto scaling groups, so accordingly you will be able to alert it. So let me remove this and let's move on to the next step, okay? So alarm name, so it should be something like EKS node CPU alert, okay? And alarm description, so it can be like this, okay? And I'll click on next, and so if it is anytime above 4, then automatically it is going to generate the alert for us. So and I'll click on create the alarm, right? So now our alarm is in insufficient state because data is currently missing. Within 1 or 2 minutes it will get the data, okay? So we'll open this alarm and we need to get the data here. Yeah, okay, so our graph is good here. So now what I'll do is I'll go and then add this to our dashboard. So we have a EKS performance dashboard here. So to that I am also going to add this, okay? And I'll say add dashboard. So if I go here in EKS performance, right? So I have this now up and running, right? So now let's come back to our insufficient alarm state here, and let's go back to our GitHub repo and take this command, okay? So which is nothing but we are going to generate load now, okay? So I'll say clear and paste it. So I copied everything, yeah, and then paste it, okay? So it is going to generate a load on our thing. So let's see what is happening here, right? So what happens here, we can see every time. So one more time run it. So let's run it. So it is in OK state now, and we are running the load. So let's see what happens. Okay, so we are throwing the load. So now you can see the alarm went into the alarm state. Okay, so we can even see the CPU here. So it crossed exactly above 4 and then immediately it went into alarm state. Okay, so now we'll go to our email and we can see that we got the notification. So you are receiving this email because your CloudWatch alarm in this respective region has entered the alarm state. Okay, threshold crossed 1 out of the 1 data points above 4.4 CPU usage, so which is above 4, so it has alerted us. So that's about it. So like this we can generate multiple alerts for us. Okay, so let me stop this. Okay, and we can go here, and then like this we can even generate multiple create multiple alarms for us in such a way that you can go here and then select the metric. There will be some important metrics like pod CPU limit, means like pod CPU over limit. Okay, I'll show you that metric. Okay, pod number of container restarts, this is one. Okay, per pod. Okay, so and one is important one. Okay, so when your pod is continuously restarting, you should know, right? So pod number of container restarts, for that respective pod you can configure. Okay, so and in addition to that pod CPU utilization over pod limit. So this is also one. You have defined the limits and above that it is trying to utilize your pod CPU, then we will come to know this one. So this is also one important metric for us. So like this, there are different metrics available for us which we can configure for our applications. Okay, so that's about it. So if you want to clean up your container insights, so just use this command and then have the values whatever you have, means like a kubectl delete -f and then provide EKS demo1 and then region name to delete whatever you have installed. And for the sample application, whatever you have installed, if you want to delete it, so you can go ahead and then delete it by going inside 18 EKS monitoring and then kubectl delete -f kube manifest. Okay, so that's about it. And these are some of the reference links. You can click on link and then browse the stuff to understand better about this section. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to understand about ALB ingress controller on a very high level. So before going to ALB ingress controller, we are going to look into AWS application load balancer. So let's see what is application load balancer and then what it supports and how this application load balancer can be created from Kubernetes manifest using ALB ingress manifest using ALB ingress controller. So we are going to see all those things in our this respective section. Okay, so let's move on with what is application load balancer in AWS, right? So ALB is a super advanced next generation load balancer in AWS. So it supports tons of features. Let's see what are those to get a high level idea on how much it is capable of. Okay, so it supports path based routing, which is nothing but context path based routing for our applications. So single load balancer can be leveraged for using for multiple applications hosted on AWS based on context paths. Okay, in the same way it supports host based routing. So which means in addition to context path based routing, we can deploy multiple applications and then using different host names we can route to those respective applications back of this load balancer. Example, apps.kubencloud.com will go to applications. Okay, and users.kubencloud.com can go to user management REST services. So something like that. Okay, and next is support for routing based on fields inside the request like HTTP headers, HTTP methods, query parameters and source IP addresses. So by seeing these three features itself, we can understand that it's not only a load balancer, it is also a routing solution on the HTTP level. Okay, and supports for redirecting request from one URL to another. So more or less standard Apache web server or Nginx related features it has. Okay, supporting for a returning a custom HTTP response to, and supporting for registering Lambda functions as targets. So anything deployed in AWS, one service always integrates with multiple other services. In the same way, multiple Lambda functions also we can register them to these respective load balancer targets. In the same way, it supports for load balancers to authenticate users of our applications through their corporate or social identities before routing requests. So this is the latest feature available, and then it is for providing the out-of-box authentication for our applications hosted on this respective load balancer with our corporate or social identities. So it also supports containerized applications, mainly AWS ECS out of the box integrated with this respective application load balancer. It also supports monitoring the health of each service independently, as health checks are defined at the target group level. Okay, so that is also one important feature. It supports registering targets by IP addresses. So due to this support, we are able to leverage this very effectively in Fargate with EKS. Okay, so because of this respective feature. Okay, and it inside VPC or outside VPC also it can do this stuff. Okay, using the IP address. And all in all, ALB is latest and greatest load balancer with many good features. So this is about what application load balancer is capable of and what it can do. So now, if this type of load balancers, if we can use it as a ingress service for us from Kubernetes, so we are going to have a leverage of all these features for our applications hosted on Kubernetes. So that's the beauty of AWS here. Okay, so which means like AWS application load balancer can be provisioned for our Kubernetes using Kubernetes ingress manifest. Okay, so let's move on. So let's see what is this ALB IC. ALB IC is nothing but ALB ingress controller, right? So ALB IC triggers the creation of an application load balancer and the necessary support AWS resources whenever an ingress resource is created in the EKS cluster. Okay, with the annotation name kubernetes.io ingress.class is equal to ALB. Okay, so the ALB ingress controller supports two traffic modes, instance mode and then IP mode. We also seen that application load balancer supports both the traffic modes, instance and IP. So the same things are available in ALB ingress controller also. Okay, let's see what are those in detail. And so this is one more documentation link for this ALB ingress controller. So you can review this link and then understand annotations inside that and everything whenever you are going through it. And when you are going in the advanced sections, you will understand more and then more about it. Okay, so now let's see the instance mode. So in instance mode, ingress controller registers nodes within your cluster as targets for the ALB. So which is nothing but nodes are nothing but our worker nodes in our EKS cluster will be registered to the targets inside the application load balancer. So traffic reaching the ALB is routed to node port for your service and the proxy to the prods. So which means like whatever the node port services we are going to create in front of our applications, means like in front of our application deployments. So first ALB routes to those node port services and that node port service is routing to our pods. Okay, so this is the default traffic mode available in our ALB ingress manifest. Okay, and you really don't need to define or specify that implement instance mode. By default it is applicable for us, but we can also explicitly specify it like this with target type as instance annotation in our ingress manifest if we want it. And we have the IP mode. So in IP mode, it register pods as targets for the ALB. Here if you see, it registered the EKS worker nodes as targets for our ALB target types. Okay, but here it registers the pods as targets for the ALB. So traffic reaching the ALB is directly routed to our pods for our service. So now here if you want to use IP, then you can use the target type as IP. So now why these two instance modes and then how it is useful for us from AWS EKS perspective, that's the core thing here, right? So when you are using worker nodes, means like managed node groups in your EKS cluster, by default you can use instance mode, or if you want to use IP mode, still you have an option of using the IP mode. But when you are using only forget only profile, which means in your cluster you really don't have any other node groups, managed node groups like EC2 instances, you are just only using forget profiles. At that point of time, you need to use and if you want to use application load balancer, then you need to use only IP mode. Why? Because forget nodes doesn't support the node port service. Why? Because we really don't have control on forget related nodes, whatever it has created in the background, because that is a serverless concept, right? So that's about the reason you need to use IP mode. So whenever you are using forget, for those things, if you need ingress manifest, you can use IP mode. And whenever you are using managed node groups, you can use either instance mode or IP mode. So that's about these traffic modes. So now moving on, so let's see how ALB ingress works. So this diagram I directly took it from their website, and we will see what it is, and then from step-by-step process how it looks like, and the link for this diagram is available here in detail. Okay, so now you see this is a Kubernetes cluster, okay, and these are AWS resources. So we already said that whenever we provision our ingress manifest on the Kubernetes cluster, it is going to create a AWS resources. So what are those AWS resources is what we are going to see now, right? So in the step 1, the controller watches for, which is nothing but the Kubernetes controller watches for ingress events from API server, and when it finds ingress resources that satisfies the requirements, it begins the creation of these AWS resources. So what are those AWS resources? You can see number 2, which is application load balancer. So application load balancer is created in AWS for the new ingress resource provisioned in the Kubernetes cluster. Okay, but one thing here is this application load balancer will have a version of ELB v2. Okay, so whenever you see, we have 2 types of resources in elastic load balancers in AWS, and this application load balancer, whatever it is getting created, is ELB v2. So that's one important note you need to remember. Okay, why? Because whenever you are giving IAM permissions and all those stuff, you need to ensure that ELB v2 also included in those stuff. Okay, and the next thing is target groups. Okay, so now the point number 3 is target groups are created in AWS for each unique Kubernetes service described in ingress resource. Okay, so whatever the application related node port services you have defined in your manifest, so those related stuff has been created, and with that, including those node port services, it is also going to create whatever the pods you have defined also, right? So now another important thing in your ingress manifest is listeners, right? So whatever the listeners you specify for your application load balancer, those gets created here, which is 80 or 443, whatever you define. So those listeners also will get created in your application load balancer. So finally, rules, right? So as we said that application load balancer supports context path based routing, so which is nothing but /star/product/accounts. Okay, so /star should go to one target group, /product should go to one target group, and then /account should go to one target group. So all these things are supported in our respective application load balancer, which we are provisioning you as a Kubernetes manifest. Okay, so now another thing here is, like, if you want to delete, right? So if you want to delete all these things, just delete our Kubernetes ingress manifest here, means like ingress resource, whatever we have provisioned, delete it, and then all these things will get deleted. So that's about the ingress on a very high level. But the core thing here is what we need to look into is what we are going to build in next 5 to 6 sections related to ingress. So if you see here on the GitHub repo, right? So from application load balancer perspective, you are going to do close to 6 sections step by step, very big sections we are going to implement, and everywhere you are going to have multiple manifests available for us to implement the stuff. So what are we going to do? We are going to see in our next lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about what we are going to build as part of entire ALB section. Okay, so we are going to do lots of stuff here in step-by-step manner. In 6 major sections we are going to implement different stuff here. So let's go ahead and then see that in a architectural representation, right? So whenever we create in AWS Cloud, whenever we create a EKS cluster control plane, so what happens is it automatically creates the VPC and its equivalent public and then private subnets in respective availability zones with the NAT gateways for outbound communication provided if your workloads and the node groups you are creating in the private subnet. Okay, so now once we create the cluster control plane, we'll go ahead and then create the EKS private node group. Okay, so whenever we create that private node group, it creates the EC2 worker nodes 1 and then 2, and then these worker nodes will inside have the automatically installed Kubernetes components related to kubelet and then stuff, so which will communicate with the EKS cluster control plane using NAT gateway. So still here we are good, right? So now we'll move on to the workloads. Okay, so now whenever we install the applications or when we deploy the applications, so what happens? So we are going to deploy 3 types of applications. One is simple app1 Nginx, and then app2 Nginx, and one user management microservice. Okay, so now we are going to do 3 deployments with 3 deployment manifests, and we are going to deploy 3 node port services for each of them, one node port service related manifest. So, and for user management node port service, you also have something called external name service to connect to the RDS databases. So now once your worker node related everything is completed, workloads are completed, so you are going to also provision your ingress manifest. Okay, so which is from Kubernetes itself, you are going to write that ingress manifest and then kubectl apply and then provision the ingress manifest. And what are the features available in this ingress manifest? It will create a application load balancer, and then we will also enable SSL for our application. First we will create a SSL certificate in our certificate manager, and then automatically we will provide this certificate ARN in our ingress manifest, so that SSL is automatically applied for the application load balancer whatever we have created. And next thing is, so we want all our HTTP requests to be automatically routed to HTTPS URL. So we will implement those related changes, SSL redirect, and also we will enable external DNS service, which is nothing but for the applications whatever we are deploying, app1, app2, and then user management node port service, I want them to be registered with the DNS name as apps.kubeoncloud.com. So automatically whenever I provision the ingress manifest, it also creates a application load balancer and also DNS registers that respective DNS name in the Route 53 automatically using the external DNS pod running on our respective worker nodes. Okay, so external DNS is something like how we have ingress controller pod, we also going to have external DNS pod. So now to route to these respective deployments, means like these respective applications, app1, app2, and then UMS, so we are going to enable the context path based routing inside our ingress manifest, which is /app1 should go to app1, /app2 should go to app2, and /star anything other than app1 and app2 should go to user management microservice. So we are going to implement this in our ingress manifest, and whenever users access HTTP URL, it will automatically redirect to HTTPS because we enabled this SSL redirect option in our application load balancer, which is our ingress service. So now via it will resolve DNS, it will resolve to Route 53, and then it will come to application load balancer, and if we access /app1, it will go to app1 application and serve the app1 index.html page. In the same way, whenever we access app2, it comes via app2 context, it will verify here and then send it to node port service, which is app2, and from there it will serve the app2 page from its respective pod. And in the same way, if you search for anything with /star, nothing but we access user management / health status page. So it will come here and then access the stuff. And if you want to list users or some database information like create user or something you are calling it, so it will come to MySQL external name service, and then it will verify the details from RDS database and then send it back to the user. So this is what is the entire architecture we are going to build as part of this entire ALB section. Okay, so we have everything documented in a step-by-step manner, how to install your ingress pod and then what you need to do after ingress pod, and then in ingress manifest also you will see all the things are documented in a very step-by-step manner, and everything is implemented in a step-by-step manner. Okay, so let's rock this section now. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this step, we are going to understand about ALB ingress install introduction. Okay, so in step 1, we are going to discuss about introductory part of our ALB ingress controller. Okay, so now we are going to create multiple service accounts, IAM policies, and then IAM roles. So let's understand that on a very high level before going ahead and then implementing the step 2. Okay, so let's go back to our Microsoft PowerPoint, right? And then so we are going to discuss about ALB ingress controller access control, right? So we want to understand this on a very high level, so that for external DNS same concepts comes in, X-ray same concepts comes in. So lot of whenever we are dealing with the Kubernetes service accounts and then IAM roles of AWS, same concepts comes in. So we need to understand on a high level what is happening before moving on to all these IAM role and then service account concepts. Okay, so my question here is, how can ALB ingress controller pod in Kubernetes create AWS resources like ALB application load balancer, target groups, and register K8s pods or node port services to ALB targets? So how it is going to do? So this is the core question, right? So now, so from access control perspective, so we need to understand two things primarily. One is Kubernetes service account and another is AWS IAM role. So Kubernetes service account. So usually we create service accounts to provide access to what it need to do for our respective pods inside Kubernetes, what it can do inside Kubernetes cluster itself. Okay, but now whenever you integrate with AWS IAM role and then create a IAM role, and that IAM role is annotated on this respective service account, which means you are linking this respective IAM role with this respective service account. So you are telling Kubernetes that you can go out of AWS cluster and perform whatever you want in AWS also. So you are giving the Kubernetes service account whoever is using, which means that respective pod whatever it is using, telling that in addition to whatever you can perform inside Kubernetes cluster, you can also do some jobs outside of Kubernetes cluster in other AWS services. So that's the reason I am annotating you with IAM role, whatever it has access to. And now, so this respective Kubernetes service account will have its own cluster role and then cluster role binding informations, which it can do inside the cluster, right? And IAM role will have a IAM policy which will tell us what this role can perform with the AWS services present in AWS, right? So now with these two things, it will be able to perform whatever is required inside Kubernetes cluster, and this IAM policy via IAM role linked to service account. So whoever this service account means, like the respective ingress controller pod who is going to use this service account, he will be able to perform activities outside of Kubernetes cluster and in AWS, something like creating the application load balancer. So these things we are going to do as part of the ingress install controller. Okay, so step by step we have documented what we are going to do, and then we will implement accordingly. So now what is cluster role? So information is provided here. Okay, so just information about what it can do inside the cluster. Okay, so that is about cluster role. And cluster role, and then service account is how you are going to create a service account. The sample manifest I have provided here. And the cluster role binding, so it is nothing but you are going to bind this cluster role and the service account whatever you have created using the cluster role binding. And this is the IAM policy which is in discussion now. So we can copy it now and then go here and then verify the IAM policy, right? So this IAM policy gives allow to, means like it will have the permissions to describe certificate, list certificate, get certificate, which is required for our application load balancer. So which means if you see here, right? No, let me go out here 1 second. Yeah, this service account will be able to perform describe certificate or list certificate or get certificate from this location itself, because it is annotated with IAM role. So whatever the pod we have deployed and then associated with this respective service account, it can perform all these IAM policies, because this IAM policy is somehow integrated with this service account by annotating this IAM role. So now here comes a bigger question for us. Okay, so how I am going to do all these things? Okay, IAM policy, IAM role, service account, how I am going to annotate all these things? Okay, so with EKS CTL, right? So with EKS CTL CLI, things became pretty easy now. Okay, so you just create a EKS CTL create IAM service account. In means like the name of the service account is ALB Ingress Controller, and inside Kube system, and cluster is EKS demo 1, and attach the policy whatever we have discussed just now, this one, and automatically things will create and then link it. This linking and then this IAM role creation, this service account creation, and then linking these two will be automatically happen. So all those things can happen automatically. So that's about on a very high level about the introductory part of our ALB install Ingress Controller introduction. Okay, so in our next lecture we'll move on with step 2 of creating a Kubernetes service account named ALB Ingress Controller, and then go ahead with other steps. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in our previous lecture we discussed about the ALB Ingress Controller foundation, and then what are these cluster role, service account, cluster role binding, and then IAM policy, and also the IAM role. So now we are going to move on with step 2, which is nothing but creating the service account, which will also create equivalent cluster role binding and then cluster role. So in this concept, the main important thing here is we are not going to use any specific version whatever AWS provided in its documentation. So we are going to straight away going to use the master branch, so that always we'll get the latest information for this role from the AWS. Okay, so that's the reason we have implemented it by the link we have provided is RBAC role from the master branch instead of a specific version. So now we are going to verify what all the service accounts present in our Kubernetes Kube system namespace. Okay, so let me clear this, and what I'm going to say is kubectl get SCA is nothing but service account and -n Kube system, so which is nothing but in namespace Kube system, right? So now we have got a lot of information here, which is nothing but lot of service accounts available here. So we will leave this as is, and now if you see these are we really don't have any new service account here with us related to ALB Ingress Controller already created and present here. So we'll go ahead and then create that now. So we are going to copy this entire link and then paste it to create the cluster role binding, and then service account for ALB Ingress Controller. So you can see that it created the cluster role, it created the cluster role binding, and also it created the service account. So now if I again execute the same command kubectl get service accounts in Kube system namespace, I'm going to get the ALB Ingress Controller just now created, which is 13 seconds before, which is age, right? So now we have verified it. So now we are going to describe it. So the reason we are going to describe it is we'll come to know in our next steps. Okay, so we are going to describe it, and in the annotations we are going to review any of the AWS IAM roles. So in annotations you don't see any of the AWS IAM roles. So once we go ahead and then implement next steps, finally whenever we verify, here the AWS IAM role will be annotated. So which means like this service account gets the capacity to call, means like get the capacity to call other AWS services, means like from the pod, from the ALB ingress controller pod, we will be able to call other AWS services outside of the EKS cluster, right? So when this service account gets that capacity is when you annotate it with that respective role, and whatever is present, the policies, means like for which services the policies is present in that AWS IAM role. So those things will be able to be accessible from this respective service account using pod, right? So now let's go ahead and then, so for reference also I have put the output here for the comparison for you. So now we are going to create a IAM policy for ALB ingress controller. So we created a service account, cluster role, and then cluster binding. Now we are going to create IAM policy for ALB ingress controller. So why this policy? So this IAM policy will allow ALB ingress controller pod to make calls to AWS APIs. So if you want to call those AWS APIs, again those are also protected ones, right? So we give IAM policy and then create a IAM role, and then that role will be annotated with this service account, and then that service account will be configured in this respective ALB ingress controller pod, so that we will be able to access the respective AWS APIs configured in this IAM policy, means like respect to AWS API services or whatever it is, right? So now we have a issue with the IAM policy.json whatever AWS has provided. Due to that, you will not be able to create this directly, which means like whenever you try to create using command line, right? AWS IAM create policy, and then if you try to create it, so obviously it is going to throw an error. So you can even try it now. So an error occurred, malformed policy document. So due to that, we are going to do it manually. So let's see how we are going to do it. So we are going to take the same JSON file whatever we specified here, right? So we are going to copy it, open it in new window, and then entire thing we are going to copy, right? And then we'll go to AWS management console, and we'll go to IAM, and we'll create this policy manually by doing little bit of tweaks for it. Okay, so this is the policies, and here we are going to create a new policy, and in JSON whatever we have copied, remove the whatever existing here and then paste it, right? So whatever you have copied there from this location, you paste it here, and then go to Visual Editor. What it will do is it will validate whether this JSON is valid or not, and you can see here you are getting one error related to ELB, right? So I really don't want inside that and then fix that error or remove or whatever it is. Okay, so what I'll do is I'll click on additional permissions here and then choose a service which is nothing but ELB, right? And I'll give all ELB actions. Okay, and then I'll go to resources and then say all resources, right? So I'll minimize this so that now ELB all actions I have got it. So and here for this ELB, whatever the error it is throwing, I am going to remove that, right? So now that ELB is removed with 33 actions whatever has warning, and new ELB is added with all actions. So I'll review the policy and provide the name of my policy, right? So name of my policy is ALB ingress controller IAM policy, right? And my description is going to be whatever I have put it here. This API, this IAM policy will allow our ALB ingress controller part to make calls to AWS APIs, right? So now if you see this respective ingress controller pod, whatever we are going to create, you will be able to manage certificate manager, Cognito user pools, and then EC2, ELB, ELB-v2, right? IAM, resource group tagging, shield, and web application firewall regional, and then WAF v2 also. So all these things, this respective ALB ingress controller pod is going to get access from AWS services perspective, right? Close to 233 services it is going to get access. So now I'm going to create a policy here, right? So once the policy is created, so search for that policy, right? and then make a note of this entire policy ARN. Okay, so which we are going to use when we are creating the IAM role using EKS CTL. So let's make a note of this policy. So if you see here in the steps also I have provided, so make a note of that policy ARN. So it is going to be same, it's not going to change. So for me, so now I'm going to create an IAM role for this ALB ingress controller and attach that role to the service account, which is nothing but whatever the IAM role created, that is going to be annotated on our service account in Kubernetes cluster. So AWS IAM role we can create using EKS CTL, and if your cluster is created with EKS CTL, then only you can use this option to create it. Else you need to create it manually, and in manual process there is lot of things you need to work on, which is going to be a problem for you. And one important thing here is you should have already, means like if this step is not executed, so which step I'll tell you. So if you go in the EKS create cluster using EKS CTL, there will be something called step 2 in 02. Let me go there. So 0102, there will be one step called create and associate IAM OIDC provider for EKS cluster. So during the creation of the cluster itself, we have implemented it. So if this step is not implemented, then whatever we are doing here, right? So whatever we are doing here with EKS CTL create IAM service account, this is going to throw an error. So just a reminder for you here. So now if it is only a EKS CTL managed cluster, you can use this option. So now this command line will create an AWS IAM role and bounce that to the Kubernetes service account. So let's see what is this command, right? So EKS CTL create IAM service account, and region code you need to provide here. US East 1 we are using, I have provided, and name. So this name is nothing but what is your service account name. So K8S service account name, that need to be bound to the newly created IAM role. So my service account name, whatever we just described and seen everything, right? So if you can see here, so you have seen that, right? So this is the service account name, ALB ingress controller, right? So the same service account name we are providing here, and the namespace is kube system, and the cluster is EKS demo 1, and the attached policy ARN, which we made a note here, right? The same thing, policy ARN, we are going to paste it here, and we are going to override existing service account and then approve it. That's all. Okay, so we are going to override and then add the Kubernetes annotation here with the cluster ARN whatever is provided. Okay, so cluster means like the role IAM role ARN whatever after creation it provides, that one we are going to annotate it on this ALB ingress controller service account. So let's go ahead and then create this and then verify all those steps one by one. Okay, so let me copy and then paste it, right? So once created, so we need to test all this stuff. Okay, so we have close to 3 verification steps here. So let's go ahead and then verify them. So it is creating. So if you see here, it is going to create a Kubernetes CloudFormation stack as part of this, which means to create that role, it is going to create a CloudFormation stack. So if you want to delete this role, you can go and then directly delete that respective CloudFormation stack. So it is saying deploying the stack, EKS CTL, EKS demo, add-on, IAM service account, kube system, ALB ingress controller. So let's wait for it to get created and then we can move on. Mostly it would have been created now. Yeah, it got created. So now let's go ahead and then go to verify it. Okay, so we are going to say EKS CTL get IAM service account in cluster EKS demo 1. So it will provide all the IAM service accounts created using EKS CTL. So let me paste it and we get the information. So ALB ingress controller, that is the IAM service account and which is attached to this respective IAM role. So we can also verify in our CloudFormation template. So we can go to services. Let me close this whatever the cluster role binding stuff. Yeah. So we can go here and then we can go to CloudFormation, right? And in CloudFormation, we'll go to this respective stack which has created latest today. Okay, so if I go here, you can see it that it created a EKS CTL, EKS demo 1 add on IAM service account. Okay, so if you see here in outputs, so this is the role it has created, and you can see on the click on the resources, and if you click on this respective resources, it will take us to the IAM management console, that respective role in roles section, right? So and now if you see, this respective role is associated with the ALB ingress controller policy, because here in this step you have provided that the policy ARN what it need to attach. So that's the reason it attached this policy. So now we have created our IAM policy, IAM role, and also Kubernetes service account. So final verification is on the Kubernetes service account named ALB ingress controller. So do we have this annotation available or not, right? So let's go ahead and then describe the ALB ingress controller Kubernetes service account. Okay, so let me say clear and paste it, right? And once it provides the information, you can see it here in the annotations. EKS Amazon AWS.com role ARN is ARN AWS, whatever the account number, and the role whatever it is created. So this role you can see it here 1ACX or YJ1 at the end. Okay, so let's come back to our UI. You can say YJ1. See, so now this role is annotated here in the Kubernetes service account, so which tells us that whoever uses this ALB ingress controller service account, they get the access to these AWS services whatever is present inside this policy. So all these services it gets access to based on whatever it is provided. So whether it is list and read or full access or whatever it is, right? So that's about the steps whatever we have implemented as part of ALB ingress controller prerequisite steps. In our next lecture, we'll focus on deploying the ALB ingress controller and then testing it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of this step, we are going to deploy the ALB ingress controller and then edit the ingress controller to update the cluster name inside that and then verify it. So let's go ahead and then implement these three steps. So as usual, instead of using what is 1.1.4 whatever is provided in AWS documentation, we are going to use master branch. Always we are going to use latest ingress controller. So let me copy this and then paste it here to create the ALB ingress controller right on our kube system namespace. So now it is created. We can even see kubectl get deploy -n kube system. So the new deployment will be created related to ALB ingress controller. And even you can say kubectl get pods -n kube system. So to see that how the pod is coming up, see it has the error because it doesn't know the cluster where it need to create. Okay, so we'll clear this and we'll go back and then we'll say kubectl edit that respective deployment in kube system namespace and then update the cluster name here. Okay, so let me paste it and then edit the deployment. So I'll go to end with Shift G, escape Shift G, and I'll go little up here. Right, so I found the ingress class ALB. Insert and enter. Right, and now I'll provide this information, which is nothing but cluster name is equal to EKS demo 1. Right, and then I will save it. So now this will update the deployment. If I say kubectl get pods -n kube system should provide us a new ALB ingress controller which is running and the old one is getting terminating. Right, so let's wait for it to terminate and this to be ready. Good. Okay, so now this is only one ALB ingress controller running now and it is up and running. So let's go ahead and then verify it. Right, so verify our ALB ingress controller is running or not. Right, so we need to verify the logs. Already we verified the pod, so now we are going to verify the logs. So this will only get the logs from ALB ingress controller and whatever may be the pod name in after ALB ingress controller, it is going to take it here and then provide us. So let me paste it. Right, So on a very high level, we don't see any issues in the log here. So starting the controller, starting the workers, we don't see anything. But the real test we perform is in our next lecture, which is 0802 ALB ingress basic whenever we implement it, right? So at that time, we will know the real issue, whatever we are going to face. As of now, it is going to be straight through, it is up and running, okay? But if whenever we deploy our ingress basic manifests, right? So if it is not able to communicate with AWS APIs like ELB API or whatever the application load balancer APIs, then it is going to throw the errors. For now, everything is good. So let's move on with our next lecture now. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about AWS application load balancers. So how we are going to create AWS application load balancers from Kubernetes. So there starts the concept called ingress controller. So using ingress manifest, whatever we write in Kubernetes, using that we can create application load balancers on AWS. So we are going to learn a very basic fundamental ingress manifest, which we are going to create as part of this entire section, ingress controller basics. So we are going to create that. So as a foundation thing, as a first step, what we are going to do, let's see, right? So in 02 ALB ingress basics, right? As a step 1, we are going to discuss about the application architecture, which we are going to deploy as part of this, right? So we need some real-time application here. So when we deploy it, we get a complete understanding on what we are doing. So let's go ahead and then do that now. So let's go back to our PowerPoint and we'll see the network design about what we are going to implement as part of this section, right? So in AWS cloud, right? So whenever we create the EKS cluster, which is nothing but the control plane, it automatically creates the VPC and also creates the public and then private subnets, and also it creates the NAT gateway. So all these things gets created automatically whenever we create the EKS cluster. So after that, what we do is like we create our worker node group, right? So we create a private node group in the private subnets. It creates 2 worker nodes, worker node 1 and then worker node 2 in Kubernetes. So these worker nodes will communicate with the cluster control plane using the NAT gateways present in the public subnet. So the next step here is for our application, whatever we are going to deploy, which is nothing but the user management microservice application, right? So it needs a MySQL database. So we are going to use RDS database here as our underlying DB for our application. And so to connect to this RDS DB from our Kubernetes cluster, so we use the external name service to connect to those. In addition to that, we will deploy our UMS, which is our user management microservice application, as a deployment in worker nodes. So we deployed only one replica. It might be any one of the worker nodes, it will get deployed, right? So the next thing is to expose this application. So we are going to create a node port service. So which means like, so to expose this UMS application to the public subnets where the application load balancer is going to access it, we create a node port service, right? And this node port service also, what we are going to do is we are not going to provide any specific node port there. So any dynamic node port it can pick from the worker node, we'll leave that way, right? So we created a node port service here, and then we'll move on to the ingress concept now, right? So let's move on. So now in the public subnet, our ingress comes into the picture. So which is nothing but the application load balancer. So we'll write the ingress manifest and then deploy that so that it creates the application load balancer. And when we are writing the ingress manifest, we will tell that whenever a request comes with /tar, it should go to this deployment, which is nothing but this respective UMS pod, right? So now users, right? Whenever the users access ALB DNS URL / user mgmt / users, which is nothing but the list users API in our user management application, okay? And whenever they access it with ALB DNS URL with HTTP, the default port is HTTP, right? So it comes here and then it verifies / where it should go. It should go to this respective UMS pod. So how it is going? It will go via node port service, which means in this application load balancer, whatever it created, the target group, right? The targets inside target group are going to be both worker nodes with whatever the node port it has provided as part of user management node port service. So now the request comes here and then it needs to communicate with the database. So it will come and then connect to the MySQL external name service. And then from there it will go to the RDS database and then take the list of users and then display it to the users on the browser, right? So that's about the entire architecture we are going to implement now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to have a little bit understanding or little bit foundation about the application load balancer in AWS before moving on to creating a ingress manifest, right? So we'll go ahead and then create a simple load balancer, application load balancer here, and then get our hands-on about that before creating it via Kubernetes. So we went to EC2 and in EC2 we are going inside load balancers and then we are creating a load balancer. So as usual we have classic, network and then application load balancer. So we are creating a application load balancer and I can say some temp as the name. So temp1 or temp2 and the scheme where this application load balancer should be created, internet facing or internal. So it should be internet facing and type is IPv4 and the load balancer protocol is like load balancer port. It is going to have the default is going to be 80, so which we really don't need to define. So which means so the default listener it is going to get created is going to be 80. So the listener default HTTP 80 we really don't need to define. And in which availability zones it need to create and in which VPC. So we have a VPC for our EKS demo 1 EKS cluster. So I'll use that and I'll select 1A and then 1B availability zones and then I'll also say in public subnet. Why? Because we are using the internet facing, so it need to be created in public subnet. So I'll click on next, and I'll select some security group. This is a temporary one which we are not going to use it for testing. Some security group is fine. And configure routing. Routing is nothing but the backend part which is nothing but target group. So I'll say temp tg, right? So which is nothing but my backend applications whatever I am going to register are with the name temp tg I have given. And the protocol we are going to have on our backend application is port 80 just for something as a temporary. Okay, some Nginx application is running in our EC2 instance. Let's consider that way. And the path I can say /. So in our original case in our application whatever we are going to deploy is 8095 is the port and our health check path is going to be user mgmt / health status. These are just temporary one which is not going to work. So we are going to understand about what we are going to write using Kubernetes manifest, right? So this is the target group and this is the health check details. Protocol is HTTP and then health check path is user management health status. And I'm going to use the target type as instance, okay? And the port we are going to use is 8095. And we are going to register the target, right? So these two are the instances present which are our original instances related to our EKS worker nodes. I am registering here, okay? And then I am going to click on next and then create it. So this load balancer is not going to work, just for our understanding we have created it. So now let's go to load balancers and the first thing to check is the listener. So default listener is going to be 80. So that's good. So which means in our Kubernetes manifest also we really don't need to write anything about listener. If it is going to be 80 as your internal port whatever you are accessing from external, which means like from browser if you really don't need to put port 80 or from browser you are accessing on port 80. So you really don't need to define in your Kubernetes manifest. And the next thing is rules, right? So here are the rules, whatever we are going to define. So currently it is port 80, default action is going to temp TG. So these information we need to define in our respective Kubernetes manifest. Okay. So if you want to write additional rule, you can insert the rule and then say add condition, and then I can say path, and I can say /app1/star, and then okay, so if my path is /app1/star, then the action is okay, forward to one of the target group, right? So target group might be whatever the target group we want to create. So I'll set some temp TG and then I can save it. So like that. And if I have one more application, if I can save it and then add one more rule, or with path saying that /app2, then go to app2 TG, something like that. Okay. So I'll cancel it. So these are the rules what we need to define. So this is about listener, and inside listener the rules. So now one more thing important here is target groups, which will have the backend information ideally. So now we have created a temp TG, and inside the backend information in targets you will have the backend information. So both instances registered with a port 8095. In our case it is going to be a dynamic node port whatever we are going to get here, okay, with the same EC2 worker node instances. So that we are going to write in our Kubernetes manifest anyway. And these are the health check settings, which is nothing but protocol HTTP, path is user MGMT health status, traffic port or some other port you want to health check on that respect to EC2 instances, health threshold, unhealthy threshold, all these details we need to provide, whether stickiness is required or not. So these are the informations we need to write in our respective Kubernetes manifest. So before going and writing it, we should have a level set at about the ground what we are going to write, right? So for that purpose we have created this and then understood a little bit foundation about this load balancer. So I'm going to delete it, which we really don't need now. So I'm going to delete it. So this is deleted. We'll also delete the target group, right? Good. And one more thing which we need to understand is about ALB ingress annotations. So this is the reference link to review our ALB ingress annotations, right? So in this you can find different annotations. Okay, so for example, if you go ahead and then find health, right? So health check, right? So all the health check related, whatever you have seen, the traffic port and then health check port or health check protocol should be HTTP or HTTPS, and health check path /user MGMT /health status. All these things we need to define these annotations in our Kubernetes manifest, which we are creating for ingress, which means we need to write it in the ingress manifest. These details we need to provide in the annotation section, right? So that's about these annotations, and if you want we can even find other annotations, means like basic annotations here. So and all annotations are provided here, means like related to entire ALB ingress. So all these things you can refer, and then whatever is required we can start using in our applications. So we are going to use few annotations related to health check, and we are going to use few related to traffic routing, and then few related to SSL and SSL redirect. So like that we are going to use certificate manager related one. So we are going to use few annotations in our series of sections in upcoming lectures. So let's go ahead and then do that now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step we are going to create a ALB Kubernetes basic ingress manifest. Okay, so let's go ahead and then create that now. So we are in our 05 ALB ingress basic YAML. The rest all are going to be same, which is nothing but external name service we are going to have, and user management deployment we are going to have, and Kubernetes secrets as is, and user management node port service. Okay, so now ALB ingress will pick the node port service. How we are going to see it now, which means like the backends, which is nothing but the targets inside the ALB ingress basic, is going to be this respective node port service. So we are going to reference that there. Okay, so let me close this and then start writing first the ingress basic, so we will understand in a better way. So the ingress is the kind here. Okay, so this is API version kind metadata and then spec, our standard Kubernetes stuff, and then I'm going to say ingress, and it is going to be extensions /v1 beta 1, right? So currently this is in beta, but in future it might be moved away. So whenever it is updated to, as usual, when it is moved from beta to live, so I'm going to update it accordingly. But currently it is in v1 beta 1, this entire ingress section related to ALB, application load balancer. Okay, so we have created API version kind, and then in metadata, so the child elements usually we'll have is name and then labels, right? And name I'm going to say ingress hyphen user mgmt rest app service. Okay, and in the labels, as usual, this is our standard label we are going to put for our user management microservice, which is nothing but user mgmt rest app. Okay, and one more we are going to have as part of this, which is nothing but name, labels, and now annotations. Okay, so entire this Kubernetes ingress manifest, most of the stuff we deal with annotations only. So that's the reason we'll have one more section called annotations. And under the spec, we'll start defining our core load balancer functionality, which is nothing but rules, right? So means like for /star where it should go, which target it need to associate, or for /app1 which target it need to associate, all will define under spec. So first thing is, let's come back to annotations and then define the ingress core annotations. So what are ingress core annotations? Under annotations, we'll have two ingress core annotations. One is ingress class and the other is ingress scheme, right? Scheme, you know that it is nothing but internet facing or internal. Okay, so that one we are going to add, and one more is ingress class. Ingress class is ALB. So let's go back here for the documentation and then take these things from a sample. So these two things we need it. Okay, so let me paste them here. So which is nothing but ingress class is ALB, and then ingress scheme is internet facing load balancer we are going to create. In addition to that, there will be a set of health check settings and its equivalent annotations will be available here. I gathered all together and then put it aside. So we'll get those things and then paste it here. So we'll add all our health check settings here. Okay, so let me say health check protocol is HTTP. The traffic port, which is 8095, we are going to use, or whatever the traffic port might be based on the worker node, whatever it provides, right? So worker node port IP, and so that's the reason we gave it as traffic port, as usual, standard setting. And then health check path is going to be user mgmt health status, and these are some standard interval and then timeout settings, and then success code we have given as 200. So all these annotations we have picked it from here related to health check, whatever the annotations are there, all those things we have picked it here and then grouped them together and then put it here. So finally, one thing we need to write now is the spec. Okay, so under spec, the core thing here is the rules which we need to define. Okay, so and under rules we'll have a list which is HTTP, and under HTTP we are going to have something called paths, means like path of our applications. Okay, so I'll say my first path is going to be /star. So whenever we go for next level of things like adding additional applications, so we are going to have more number of paths here, like /app1 and then /app2 and then /star, like that. For now we are going to say path as default /star, and as usual, what is my backend here going to be, right? So under backend we need to provide two things here. So one is service name, right, and service port, so which is again in our Kubernetes language only, right? So which node port, service name, and then service port I need to provide as backend for /star in my ALB, right? So I can go here and then I can go to node port service, and this is my node port service. Okay, so this is the name of my service name for user management. So I'll come here and then provide the service name here, and the service port is 8095, which is going to get created. So I'm going to give 8095, right? So that's good. So let me close this and this is the complete ingress manifest whatever we have created as part of 05 ALB ingress basic, right? So in our next lecture we'll focus on deploying these things and then testing it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step we are going to deploy our ALB ingress template, all the manifests whatever we have here. So which is MySQL external name service, user management microservice deployment, Kubernetes secrets, and then user management node port service, and also ALB ingress basic. So we are going to deploy all these manifests and then test it now. So before going that, let's go to this MySQL external name service, which means like this MySQL RDS endpoint, and then ensure that it is up and running. So that's one important thing. So if it is not running, then the application will not come up, right? The user management microservice. So that's the reason. Go to DB instances and you can see that user management DB is up and running. It's available. So we are good. So that first step is done. Second step is like we can go ahead and then deploy the stuff. So let me go here and then we'll go to 08 is our thing, which is ELB application load balancers. Inside that we are doing with 0802, right? And there you can find our kube manifest whatever we have updated just now, right? So I'll say kubectl apply -f and then kube manifest. So any error is there also it is going to throw to us. So let's wait for it to get created. So MySQL got created, microservice deployment got created, DB password got created, node port service got created, and then ingress got created. So what is our next step here to verify the stuff? So kubectl get pods. So this is the pod. So I'll say kubectl logs -f and then I'll take the pod name. So I'll tail the logs and then see that it came up properly, right? So it started, but it's waiting on its liveness and then readiness probes to be completed. So I'll say watch get pods and then watch. So 0 by 1 is there. Until and unless it comes as 1 by 1, we need to wait ideally, right? So to access it via browser. But before that we can check other stuff here, right? So which is nothing but get ingress, right? So get ingress will provide the ALB DNS name. So this is our ALB DNS name, whatever it has provided for us. So it created a ingress user management REST app service, and this is the DNS name, whatever it is providing for us. Okay. So now we'll also verify our kubectl get SVC, which is nothing but the user management node port service, whatever it has created. We need to cross check. So it created the node port service with 31329 dynamic port. Okay. So that's about it. So now let's go back here and then verify the ingress controller. Describe the ingress controller whatever we have created. Okay, so we can paste it here and then describe it. So this is for our additional understanding only. So which means like what all annotations it has taken into consideration when deploying it, and what is the host */* should go to this node port service. All this information you can see. So whatever we have deployed, the same thing is going to be there in the describe also, but just to understand what it has deployed, we can see it here. And you can even see the events, right? Any Kubernetes object in Kubernetes, whenever you go ahead and then describe it, you will get the series of events whatever it has been implemented. So if any issues also, you can find it here. Finally, one important thing is always whenever you deploy your ingress manifest, at least for the first 1 or 2 times, go ahead and then verify the ingress controller logs. So why you need to verify your ingress controller logs is, so you have done lot of work related to creating a Kubernetes service account, cluster role binding, and then IAM policy, and then IAM role. So all these 4-5 things you have integrated. So if there are any issues in that process, then it is going to tell us from here. So I'm going to verify the logs. Okay. So successfully reconciled. Okay. So there is no issues or no error related. So if there is an error, it is going to show a error like this: reconciler error failed due to build load balancer configuration due to unable to fetch subnets. Okay, so some error related to access denied. So if we have any issues related to access, means like role based access control, whatever we have provided there, if we do any mistake, so this type of errors are possible. So that's the thing. So that's the reason always it's good to verify the ALB ingress controller logs. So now we have verified this stuff from the Kubernetes side. So let's go to our management console and verify the listeners, target groups, and then finally access the application. So let's go to EC2, right? In EC2, let's go to load balancers. And in load balancer, you can see a load balancer is created and of type application load balancer. Okay. And now one thing we need to see is in listeners, we need to go inside listeners. The default listener is 80. So if you see the manifest here, so related to ingress, you don't see anything here, right? So nothing related to listener we have provided, but still it has created everything for us. Okay. So default, because default is 80. And now let's also review the rules, right? In rules, anything with /* go to this target group. Okay, so let me open this target group, right? So anything with /* go to this target group, 100% traffic going to this target group. So we open the target groups. In target groups also you can find only one target group here. And in targets, right, it picked up the 31329 port. So this should be our node port, right? So let's go here and then clear this up and then kubectl get svc, right? So you can see 31239 is our user management REST app node port services node port. So this load balancer is created in public subnet. So let's go here. So this load balancer is created in public subnet. So it is connecting to this node port service on 31239 of this worker nodes port. So this worker nodes node port is 31239. Via that it will come to this service, which will be internally a cluster IP service of 8095. And from here it will go to the respective pod, means like target port is 8095. So this understanding is very important for us in what is happening from load balancer perspective and also on the worker node port service perspective, right? So that's about it. So it connected on 31239 and then from both the servers it is healthy. Why? Because service can be spanned across all the worker nodes, right? So from here you access also, you can access this pod, or from this worker node you access also, you can access this pod. So that's the reason from both the nodes it is connecting to this respective pod and then it is telling us it is healthy. And one final thing we need to cross check is group details, right? So which is nothing but whatever we have configured, the path, whatever we have provided in the annotation here, right? User management health status, the same thing came here. And it checked the health and ensured that our backend is healthy. That's about it. So this completes the creation of application load balancer using ingress manifest, whatever we have created just now. So we verified our load balancer, we verified the target groups. So now let's go ahead and then access the application. We can even say health status, or even we can list the users also, right? /users. So let's go and then get our ALB ingress URL. So which is nothing but the DNS URL. We can get it directly from DNS name in our load balancer here in the description section, or we can get from kubectl get ingress send from this address section. Okay. So I can take it from here, copy, and then go to the new browser, http:// and then I will say user mgmt/health-status. Okay, health is good. And if you want to list the users, whatever is present in our database, so we can say users. Okay, so we also have the list of users displayed. So now if you see it here, when we called the users, the request went from internet browser to the application load balancer, which is nothing but our ingress service, and then validated the path here /* and then went into the user management node port service present on these worker nodes, right? And from there it went into the UMS pod, respective pod, and from there it went into the MySQL external name service and it went to RDS database and then picked the user and then displayed to the user back. Okay, so that's about happened on an overall flow. If you want to again further test it via Postman, you can even do that. So you can go to settings here and create a new environment, and environment you can say ALB ingress basic testing, right? And the URL will be the variable name, whatever you can find it here, right? So URL and whatever we copied, this one, right? So this one we have copied. So I'll say http:// when I update an initial value, automatically current value should be updated. The primary thing is we need the value in current value only. Okay, so I'll click on add, right? And then close this, and I'll go to environment here, right? ALB ingress basic, and I can first test the health status. I got the response. I can test the list users, and I got the response, admin 2 and then admin 3 stuff. Now I can create a user, right? So I can create a user saying ALB ingress or ALB ibasic. Okay, simply ibasic is ingress basic. Okay, so I'll paste the same as the email. I'll paste the f name also same and l name also same. Okay, so l name and then f name, something like this. Okay, and then I'll post it, and anyway we'll get the 500 for our notification service. That is fine. I'll come back to list users, and then I'll list the user, right? So I can see that ALB basic user, whatever we have posted, it got created in our RDS database. So entire workflow worked for our post service also, in addition to guest service. Finally, let's go ahead and then clean up whatever we have created as part of our ingress basic section. So I'll go to my terminal. I am in 0802 ALB ingress basics kubectl delete -f kube manifest, right? So whatever we have created should get deleted now. So let's go back and then verify the same. So our load balancer should get deleted. So that's good. Okay, so our target should be cleaned up. Yeah, this looks good. Okay, so this completes the implementation of application load balancer using ingress manifest, the very basic. Okay, so in our next lecture we will enable the SSL, and then in following lecture we'll enable HTTP to HTTPS redirection. So like that we'll incrementally build the ingress basic manifest to a very good level, and then we'll close the entire section. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in the previous section we have seen this entire architecture, which is nothing but whenever the request comes via internet via /star to our ingress, it will forward it to user management node port service, and from there to our UMS pod and to MySQL. So now we are going to understand about ingress context path based routing. So first thing comes here is like why we need to have context path based routing. So there one thing is, if we have multiple applications which are deployed on our Kubernetes, and then we want to expose them via ingress, and then why you need to do that? Because AWS application load balancer is a costly load balancer, and for each application whatever you deploy in your Kubernetes, if you want to span one more application load balancer, then your cost is going to go so high. And if your application supports either the host header path routing or path based routing, which is nothing but context path based routing, so obviously we can use these features and then ensure that we use only one load balancer in the front, and then we can have multiple applications in Kubernetes serving via internet using context path based routing or host header based routing. So now moving on, so this means like from previous architecture we already know that what is EKS, cluster control plane, or availability zones, or public, private, subnets, worker nodes, all these things. So I just, for a good depiction purpose, I made these services to smaller, to restricted to this worker node, but they are spanned across any number of worker nodes, whatever is created as part of your cluster. Just for depiction purpose only, these were made shorter here. Okay, so I'll show you why it is. Okay, so I have two more applications coming in here. One is app1, which is a Nginx application, and app2, one more Nginx application, right? And this app1 will have /app1/index.html as the context or the application inside that, and this will have /app2/index.html as the application. So these both have two contexts. One is /app1 and the other is /app2. So now we will create their equivalent node port services in front of these deployments, app1 and then app2. So now here starts their equivalent path related information we need to update in our ingress manifest. So /app1 should go to node port service app1, and /app2 should go to node port service app2, and anything with /star should go to user management node port service. So now as a user, when I try to access with ALB DNS URL /user management /users, so the request will go to /star, and then it will go via pod and then go back and then get to the RDS database and then provide the list of users. So this we have seen already. Now whenever user comes with /app1/index.html or just /app1/ some other file, whatever is there, right? So then what happens is, once the request reaches this application load balancer, it will verify the context path, and if it is /app1, then go to app1 node port service and then serve the page from app1 pod here. In the same way, if you have app2, then from it will go to the app2 in the application load balancer context, and it will route to app2 node port service and then serve the page from app2 pod. So this entire thing we are going to implement now. So let's go back to our this one, and we should go to our 0803 ALB English context path based routing, right? So that is what we have discussed the architecture. So now we are going to these app1 and app2 are simple Nginx custom built images, and while routing we are going to update it with app1 Nginx node port service in our respective ingress basic or ingress context path based routing YAML files. Okay, so now we are going to create Nginx app1 and app2 deployment and service in our next lecture, and then move on with other steps. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. In the previous lecture, we have understood about context path based routing in Ingress in a architectural manner. So now we are going to create two more applications for us, which we are going to deploy as part of this demo, right? So we are going to create Nginx app1 and then app2 deployment and then service. So both deployment and then its equivalent node port service we are going to create in a single YAML file per application. So for app1 Nginx 05 Nginx app1 deployment and node port service, and for app2 Nginx it is going to be 06. So these are regular deployment and node port services whatever we have implemented so far, right? So we really don't need to write one more time a live template for these things. Okay, so that's the reason I have written them and then put it ready here. So this is the 0803 ALB Ingress context path based routing. Inside that Kube manifest folder, and inside that you can see MySQL external name, user management microservice, Kubernetes secrets, user management node port service. After that you get 05 Nginx app1, right? So its deployment is here. So standard apps v1 will be the API version, and names, all those things are as usual. Okay, spec will have in general for deployments replicas, selectors, and then pod template, right? So one replica, and then in match labels as usual we know that we are going to have the same value in match labels. So whatever is there, the same value will be there in pod template metadata labels also. Finally, the pod spec will have the containers, and inside that container my first container is app1 Nginx, and then I'm bringing that from my stack simplify /cube Nginx app1 and 1.0.0 version. And now it for this deployment you want to expose it as a node port service, which we have done for multiple times. So as usual it is node port, and then port is 80 and then target port is 80. That's all. We really don't need to mention any node port because it is going to dynamically take that value. So now one important thing here is annotations I have written here, right, in this level. So we'll come back to this in our next step. Whatever we have written for our app1 we have copy pasted and then just changed it to app2 here. Okay, so we'll discuss about this health check path annotation later. So now let's move on to 07 ALB ingress context path based routing. So here comes our real work which we need to do from YAML perspective or manifest perspective. So whatever we have implemented till ingress basic, the same thing I have copied here. We still didn't implement any of the path based routing here. So let's go ahead and then implement the path based routing. So our path based routing is, we have 2 more paths now. So let's go ahead and then implement. So this part I'll copy paste and then go to the home and then path, right? And one more also I have, which is nothing but one more, right? So I will say app1/star, right, is the path. If it comes here, then it need to go to app1 node port service. So I'll go to 05 nginx node port service and then I'll find this information, right? app1 nginx node port service, and I'll come back and then update it. And what is the port we are supposed to use? The port, it is going to be port 80, right? So this is the one. Now I have something called app2/star, right? So now for app2/star, we should have our app2 node port service, right? So which is nothing but this one. So let me copy this, come back and then update it. And the port is going to be 80. And finally, anything after app1 and app2, anything other than app1 and app2, if it comes with /star, go to my user management REST app node port service with 8095. So now one thing important here is, an important note is, okay, important note which we need to know is always, right, /star should be at the end. So the paths will be validated like this. Okay, so first if it is /app1, it will find it and then do it. If this /star, if you put it at the starting, so the order is very important. If you put /star at the starting, even if you send app1 app2, he will send the application load balancer will send it to user management REST app node port service only. So always in this context path related stuff, always we need to put /star as our last path for our entire manifest. Okay, so like that we need to implement. So now here is one more problem we have, so which I also mentioned in the step here, which is update health check path annotation in your user management node port service. Okay, so now if I deploy this, what happens? Okay, what happens is, for all my 3 applications, ideally if I really didn't define these things here, okay, if I didn't define these things here, annotation and then health check path there, for all the applications it is going to give user management health status, and then it is going to throw an error for app1 and then app2. Due to avoid such type of situations, like whatever is applicable at the node port service level, we need to move them to the node port service level. What all are generic, then you can have them in the ingress template. So again I am going to repeat this. What all are generic for all the applications which you are having load balancing as part of ingress, so generic you can have it in this ingress template, and whatever you feel like these are specific to those respective application, move them under that application. For me, these things are generic. I really don't want to change. Every application have these settings as usual, and for node port service I want to move this from here and then move under my user management node port service example here. Okay, I already put it here, but if you want it, you can move there. So you need to add annotations and then move that from here. So which means I need to just comment this here, so that I really don't need. So these are the changes we are supposed to do as part of context path based routing. So one is add the paths and then move /star at the end, and then ensure that your health check path is moved to the respective node port service where it should be configured. That's all. And in these things also you have configured your health check as app1 index.html and then app2 index.html. So in our next lecture we will focus on implementing them and then testing them. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In step 5 we are going to deploy all the manifests and then test it. Okay, so let's go ahead and then do that now. So let's go back to our terminal and I'll say cd 0803 will be our ALB ingress context path based routing. So I'll say clear and I'll say kubectl apply -f and then kube manifest, right? So once these things are created, we can go ahead and then test them. Okay, so I'll say kubectl get pods, and already nginx 1 and nginx 2 are running. User management microservice will take a while, around 90 seconds to get it up and running. So I'll go back to get ingress and then see that our ingress got created, right? So it got created. So let's go to our Amazon management console, right? And then verify the stuff. So if you want, you can even verify the ingress controller logs and all those things, but you can leave them as is, because earlier already we have tested in our previous section, right? So it should be good. Okay, so kubectl get svc also. We need to see our three node port services, which is app1 nginx node port service, app2, and also user management. So all these three things we should see. Now come back, go to management console and go to EC2, right? And in EC2, let's go to load balancers, right? In load balancers, so let's see the listeners. In listeners, let's see we have only default as 80, and we'll click on view or edit rules. And now you can see that whatever the rules you have written, path-based routing rules, right? So /app1 should go to this, /app2 should go to something different, and /star should go to something different. So 3 different target groups were created, and then for those 3 different target groups are nothing but your applications you can consider, right? And based on the path, we are routing accordingly, right? So now let's go back and go to the target groups. And in target groups, so let's start with 1, okay, so which is nothing but this is user management health status. Okay, so this might take a while to get registered and then ready for us. So this is user management one, which is first one. Okay, so and we have the second one, which is app1 index.html, right? So and you can see that it is also getting registered. It will take a while, but once it is registered, we can even see the health status. And the third one is app2 index.html, and it is also getting registered, and its node port is 30032, and same thing should be there for these things also, 31745, some dynamic node port from our worker nodes. So let's check them one more time. So this is the thing, so which is user management microservice, and they are healthy, right, from both the nodes. Okay, so we really don't need to worry about this picture here, whatever I've shown. This user management node port services across the worker nodes. Again, I am repeating the same thing for you. So now the next thing is this one. Okay, and then in targets, let's see, app1 also is healthy, and let's go to app2 and then refresh it, and app2 is also healthy. So now let's go ahead and then access our applications, right? So ALB DNS URL app1 index.html, app2, and then user management. So let me clear this. I'll say kubectl get ingress. So I try to get the DNS names as far as possible from my command line only. Okay, so let me copy this, and I'll go here, and then I'll start with http:// and user mgmt/health status, right? So it's up and running. We should be good now. Okay, so now one more I need to take. Okay, so which is http:///app1/ at the end you can directly put / and then enter, or you can even say index.html. Okay, so welcome to Stack Simplify, and you have the application as app1. So we'll also add one more application now. Is working or not? So I'll say app2/index.html. Okay, so welcome to Stack Simplify. This is app2. So with that said, so we should be good with all the 3 apps on the routing perspective, whatever we have implemented, context path based routing. So let's go ahead and then delete all these things, whatever we implemented. In our next lecture, we'll focus on implementing SSL. So I'll see you in the next lecture after cleaning this up. Okay, so delete -f kube manifest. So now we have cleared everything, so mostly everything should get deleted. Okay, so let me see here and go to load balancer, it's gone, and then target groups, it's gone. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to register a domain in Route 53. So we are going to buy the domain kubeoncloud.com. So let's go to AWS Management Console, and on the console home, search for Route 53. And in Route 53, we'll go for the registered domains. And then we are going to register a domain, and the domain name is going to be kubeoncloud.com. Okay, so it took something else here. Remove R here. Yeah, check it. Okay. And we got it, kubeoncloud.com. So everything looks good. KUBE on cloud.com, right? So add to cart and go down, and if you see here, you can click on continue, and these are the personal information. We can leave it, and you can see privacy protection enabled for my domain, enabled, and then I'll click on continue. And if I go here, do you want to automatically renew your domain? Yes, I want to renew it. And the terms and conditions, I'm going to accept it, and then click on complete the order. So our order got submitted successfully. It might take close to 3 days to complete it usually, but once we verify our payment, usually it might be faster, in a day or even lesser than that. So we'll go to domains, and my other domain is in action required for verified payment. I will leave it. Once this also comes into that same status, we will verify for this one. Okay, kubeoncloud. So I got the action required for kubeoncloud. So I'll go there at the end, and then I'll do the verify payment for the latest one. Okay, 1219. I'll go there. So one, I accidentally sent it, so I really don't want to pay for the other one. So now if you see 48302601 and then 2877. So 2877 is the latest. I'm going to say verify and then pay, right? So I'm going to pay it now. So let's wait for the payment to happen. Okay, I provided the OTP, and this should be done now. So we have completed the payments. If you go for bills, orders, and then invoices, so one should be like that only, and then one should be already paid. Okay, so let's wait for some time, or go to registered domains here and then pending requests. Okay, so it will take an hour to update the status. So let's wait for an hour to see what happens. So once we have completed the verify and pay, so we can see that for kubeoncloud, we can see domain registration is in progress. So let's wait for everything to be completed now. So within an hour, I have seen that my request has been moved from pending request to registered domains. So hardly within less than 2 hours, entire process will be completed for us for the register a domain. And only one thing is we need to verify our payment thoroughly. That's about it. So now I have the kubeoncloud domain available for me, kubeoncloud.com, and then its registrant is verified, and we can see all the details about it. If you want to extend this domain for another 9 to 10 years, if you want, you can do that now. Okay, and auto renew is anyway enabled, so every year it will automatically gets auto renewed. So now one important thing here is, if you click on manage DNS, it will take us to the hosted zone. So the public hosted zone for kubeoncloud.com is already by default created. Okay, so now here we will be able to DNS register our domains. Okay, so whatever the subdomains we want to register, or whatever the main domains we want to register, we can create a record set here, and then says that users.kubeoncloud.com, and then provide the IP address or the ALB DNS name, ELB DNS name, all these things here to DNS register it. Okay, so this is about the register domains section, which is nothing but our step 2, register a domain in Route 53. In our next lecture, we'll focus on creating a SSL certificate in Certificate Manager. So I'll see you in the next lecture. Until then, bye bye. Thank you.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.